Check, 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 check. And we're live. Welcome, everybody.
Hi.
Welcome, Carolina.
Hi, Luca.
Hello. Thank you, everyone, for joining us. I already see a lot of activity on the YouTube comments, so keep them coming. Tell us where you're joining from, and welcome. So I'm Luca, the moderator or one of the moderators of the Platform Engineering Community and host of PlatformCon. Joined today by my wonderful co-host, Carolina.
Hi, I'm Carolina. I'm excited to be here again for the second year.
Yes, second year, we keep going.
Yeah.
All right, so we're gonna keep this short and sweet, just like a few points that we want to cover to make sure that everybody has the best experience today. We're gonna go over the schedule for the day. We're gonna touch on a new format for the year, which is watch parties. We're gonna walk through the learning path, which is a fan favorite from last year. We'll cover how you can make the most of the Platform Engineering Slack at the Q&A session with the speakers. Code of conduct, quickly go over some of the highlights and the main talks of the day. And then another actually fan favorite from last year, the raffle. So just a quick thing. But before we get into all of this, I want to take a second to acknowledge, how far we've come as a community. It really doesn't feel too long ago that we started with a few meetup groups in Europe. Really, I think there are like 2 or 3. That quickly grew to 28 groups right now, over 13,000 members. It's crazy. It's crazy just to think about that. The Slack we launched maybe 6 months after the first few groups. And the idea was really, we looked at the groups and it was great. There's like a lot of engagement around, platform engineering and a lot of other cloud native key topics and trends. But it was really a one-to-many sort of like communication. We wanted to provide people with a many-to-many communication. And that's when we launched the Slack, and it nearly took off. I think it had like 500 members in the first few days. And it kept growing from there, and it's now crossed 14,000 members. It's probably going to be 16,000, 17,000 by the end of this PlatformCon. And that's really the beating heart of the community. So if you haven't joined it already, please go join. That's also where a lot of the action during this event will take place. So don't miss out on that. We also then showed after launch platformengineering.org. This is really the home of our community, is where you can see all the upcoming events, whether it's virtual, like PlatformCon, or in person, like the watch parties that we'll talk about later. It's where you can see the blog, key defining articles. There's a tooling section, job section, store, a lot of stuff. And small spoiler, we are actually reskinning it and restructuring it. And so a lot of new stuff and great stuff coming along there. And then finally, PlatformCon, right? This was really the first time that we did it last year, PlatformCon 22. It was probably the highlight of the year community-wise. And we had 7,000 signups, 6,000 attendees just on day one stream, this one that you're watching right now. And so extremely exciting, and frankly, extremely exciting that PlatformCon 23 has grown so much already, right? It's a 3x in terms of signups. We'll look at some more numbers later. This is crazy, right? It really speaks volumes to just like how much platform engineering has been exploding over the last 12 months and how much mindshare has been taking. And so let's dive more into PlatformCon.
Right. And so the first PlatformCon was truly special, proving how strong our platform engineering community is. And I bet you haven't seen such a dedicated audience like you can see in the picture before. But I believe, Luca, that we can even beat this harder this year, right? So if you host your own PlatformCon watch party, please share those moments with us. Last year we had so much fun with action going on 4-track channels with heated discussions, many new connections and conversations that kept going for 2 weeks after the conference. And We had so many fruitful conversations, like literally fruitful. And as for the very first conference, we really made noise by 250 Slack posts, more than 500 social posts, and over 1K comments. And even though the first PlatformCon was impressive, we already see that this PlatformCon is way bigger and better.
Correct. And here, just like an overview and a few numbers. I think what's really impressive for me, obviously, if you just start from the top, just the YouTube, right? We hosted PlatformCon 22 last year with basically a non-existing platform engineering YouTube channel. We had about 50 subscribers, and still this stream went completely viral. We had like 6,000 people watching it. And so really excited to, go into PlatformCon 23 with a considerably high number of 12,000 subscribers. Same for the Slack. And this is particularly exciting again, because I think one thing that truly makes PlatformCon special is that it leverages the existing assets, the existing destinations of the community, right? So it mostly happens on the YouTube, where we released all the talks for either day. So the talks are both released on the Platform Engineering YouTube channel and on the PlatformCon website as embedded videos, so you can consume them in either place. And then obviously the Slack is where all the Q&A, all the action with the speakers and attendee to attendee happens. And so it's great to see that we're coming in with 23 with such numbers, because really I think this is going to make PlatformCon 23 even better and more special than PlatformCon 22. We already covered the signups. I just want to cover one more thing, which is the talk submissions. Last year we had just over 100, and this year we had over 500, right? And so again, that speaks to just like the growth of platform engineering, the interest, and just how much people in the community and outside of the community want to share their platform engineering journeys with everyone else, right? You can also see the rate of submission accepted to actually talks that we're publishing is a lot better, right? So we had 105 submissions last year, 78 talks accepted. We were a lot peakier this year, right? Only 170 talks that we accepted, and so I really believe the quality is incredibly higher, and this is starting from a baseline that was already really good from last year. So I really hope that you can all enjoy that. All right, so on to the less clandestine watch parties this year.
Yeah. So we ran a post-conference survey after PlatformCon 22, and we noticed how much you missed in-person meetups. So we heard you last year, of course, and that's why this year, together with our amazing sponsors, Open Credo, Sintaso, Atlassian, and Adevinta, we host 4 in-person watch parties in Austin, San Francisco, London, and Barcelona. So regards for everyone who's watching this kickoff from one of those watch parties, and I really, really hope that you enjoy it.
Amazing. All right, so on to the trucks. So for those of you who were here with us last year for PlatformCon 22, you remember we had 4 trucks: stories, tech, culture, and design. We did a bit of shuffling around this year, so we replaced design with blueprints and impacts. So let me just quickly go over all of them. So stories, obviously, it's about the war stories of the practitioners, right? Like, what were the challenges? Why they got going on their platform journey? What was the impact on their organization? Tech is usually zooming in on specific parts of the platform stack, specific tooling choices, and you have both, beginner stuff and more advanced stuff, but that's really what tech is about. Culture, obviously, platforms are not just about technology; they're also about, getting internal buy-in and making sure that all the stakeholders are aligned. That's really key for a successful platform initiative, and so that's what we cover there. Going into the new track, so we have impact. Impact is really aimed at kind of the managers out there, the C-level, the executives, to get an understanding what is the ROI of a platform, right? And what is the total cost of ownership and all these sort of things. Now, I will say this is not just, so it's not that if you're not a manager, this is not interesting for you. In fact, I would say this is very interesting also if you're practitioners, because this really teaches you how to sell the platform initiative into management and into the C-level. And then finally, blueprints. And this is really, I think, the the track that I'm most excited about, I feel like the community has gone through the past couple of years of kind of, stomping our hands on the table and yelling, hey, listen to us. If you want true, you build it, you run it at the enterprise scale in the cloud native era, in an era of, an ever-growing complexity and crazy CNCF landscapes. You need to build a platform. You need an internal developer platform. You need to have a platform engineering initiative, right? And it feels like a lot of people are listening now, and it feels like, as we said earlier, really platform engineering has crossed the chasm over the last 12 months, and there's just so many eyes on it, right? There's so much interest, and so a lot of people, both in the community and coming fresh in the community, are sold on the idea, right? It's the thought leadership, if you will, has worked, and so now it's really about, okay, great, platform engineering sounds great in theory, but where do I go next? How do I get started, right? And that's really where blueprints come into play, right? These are reference architectures. These are clear design principles, clear starting points to get going on your platform journey. And this is a key theme for the community broadly for the whole year. And really one of the tracks that I'm most excited about for PlatformCon this year. So I hope you enjoyed the blueprints talks. All right, going on. So schedule. You are watching right now the EU kickoff. Again, we're not going to take too much of your time, about 10 more minutes, and then off you go. You can watch the talks on demand, again, either on the platformcon.com website, and then you're going to have /talks, and that's also where you can go and you'll be able to select day one, which is everything that we published today. And you'll be able to filter by the tracks, by the speakers, and so on, and go through that. Or you'll also be able to consume them on the YouTube channel, right? Also on the YouTube channel, this stream will keep going. So what we're going to do after we're done with the live kickoff, we're going to queue a stream of selected talks, and so you're also welcome to stay here. This is a selection that our content team has made for you, and really mixes everything, advanced, beginner. And it's just like the best of the best that we selected for you. So you have a few options, and it's really up to you how you prefer to consume it. Then this stream is going to go on until 7 p.m. In parallel to that, there's going to be another stream that starts to welcome our US and North American colleagues that will join at our 5 p.m. their 10 a.m. Central, and that's going to be a separate stream that is also going to start. So if you want to join a second kickoff, you're welcome to join that one as well. But otherwise, you can follow this stream. You can watch the talks at your own pace. And then important, at 7 p.m., we are starting the Q&A. If you remember, again, for the ones that were here last year, we had 2 of these Q&As last year. The first one was quite earlier. I think it was like 1 p.m. or something. Europe, and that was just a little bit too early, certainly for North American people to join in, but also for Europeans, frankly, and everyone else. Most people just hadn't had enough time to consume the talks to ask questions about it. This is why we decided this year to crunch all the action in one slot a little bit later in the day. However, if you can't join because you got to work, you have kids, whatever, life, and you have questions, please don't feel like you have to wait until 7 p.m. to ask them or the next day. Feel free to drop them into the respective channels that Carolina will cover in a second. And just ask people start jumping in. There's going to be threads that we'll start and we'll keep going for days anyways. This is one of the great things I think about this format. Last year, I thought, hey, it's a 2 days conference. And so that's how long the action is going to go. Actually, the speakers are hanging out on the Slack anyways. The talks on YouTube are available forever on the channel anyways. And so people just kept starting threads for something like 10 or 12 days, right? So don't stress out too much about it. But, if we can, join all at 7 p.m., obviously that's where all the speakers are going to be available. And it's really where there's going to be a ton of action. And so I hope to see you there. One final comment on this. So obviously there is a lot of talks, we said, like 169, that can be quite overwhelming to navigate, we know. And so we've put together a few paths for you to help you, sort through the noise. There's a fundamental path. This is really for, those of you who are starting on your platform engineering journey. Then there is an advanced path. This is for the ones that have already been building internal developer platforms, have already, messed around in the platform engineering community. And there's going to be different deep dives on tech topics, culture topics, and so on. And then again, a management path, to cover the more cultural and ROI aspect. All of these, again, you can find on youtube.com/@platformengineering. This is the YouTube channel. And and that's where you can find everything.
Yeah. So now about one of the most exciting parts. So the live Q&A session with all the conference speakers on Platform Engineering Slack channel. So we want you to get the most of PlatformCon, right? So don't be shy and ask questions you have about talks on corresponding channels you see in this slide. Q&A will take place, as Luca mentioned, from 7 to 9 p.m. Central European time. And you can find the schedule also on our PlatformCon website if you forget this, but we'll make sure that you find this easily. We'll pin some messages and send you reminders. One thing, just don't forget to tag the speaker that you want to ask a question to, so your question doesn't get lost. And if you, as Luca mentioned, I'm gonna repeat this again. If you can't join Slack Q&A, you can still leave your questions during the day, and speakers will get back to them later. And this is the warm-up before the day starts. So here you can see a few great speakers and their talks for today, including VP Analyst, DevOps and Software Engineering at Gartner, Manjunath Bhat, and his talk about communicating the business value of platform engineering. Also, Stefan Schneider, Digital Expert Associate Partner at McKinsey, sharing their newest implementation reference architectures for developer platforms on AWS, GCP, Azure, and OpenShift. Also, wonderful OpenCredos CEO and CTO Nikki Watt, explaining why is it so hard to create a great platform as a product. Then we have author cloud strategy Gregor Hohpe, reflecting on 2 decades of building complex distributed systems, highlighting where abstractions helped and where illusions led to major disappointments. And last but definitely not the least is Humanitech CEO Kasper Von Grünberg, going into detail about why focusing on day 1 golden paths isn't enough and how to think of every release as day 0. So these are just a few of them, but I think it's worth highlighting them for sure.
Nice. I already saw people asking for Gregor in the comments. So there you go. He's back this year. And I want to highlight Stefan's talk is really what I was mentioning around Blueprint. McKinsey is releasing this reference architecture as code. We're really excited about that as an example of the Blueprints track.
Yeah. And before wrapping this kickoff, we want to touch on some really important points. One of them is code of conduct. So please read it carefully, but TLDR, be kind and respectful to one another. And if you have any questions or concerns, please reach out to our community manager, Julia, Luca, or me, or simply write us an email to support@platformcon.com. We take all reports seriously, so we will respond with as much courtesy, confidentiality, and urgency as possible. And same thing with technical issues. Should you have any, reach out to the same support@platformcon.com or just Slack us.
Awesome. All right. And so before you go, one last thing, again, a fan favorite from last year, to get this PlatformCon swag that all our speakers got. You'll see some of them have recorded the talks with these t-shirts. And so if you also want to get some of this stuff, it's really easy, similar to last year. Go sign up for the Platform Weekly newsletter. This is our community newsletter, is where every week we send out updates, trends, long-form thoughts on platform engineering, cloud native, DevOps, and so on. And then similar to last year, you're going to play a little game with us, which is you're going to find the hidden rocket emoji in the video descriptions of your favorite talks. Once you've done that, it's really simple. Just take a screenshot, send it to look@platformcon.com. We'll double check that you signed up for Platform Weekly, and you'll be entered the raffle. We will announce the 10 lucky winners at the Q&A session on the side channel. So again, if you can't join, don't worry. We'll bookmark you also the next day, and then we'll send it over to you. One last thing, I want to thank you, all our sponsors. Again, for the ones of you that were here for PlatformCon 22, you remember this section was a lot smaller. We have some incredible names, some of the major players in cloud native, really, Google Cloud, Docker, Atlassian, and many more. And so really, thank you to our sponsors. This PlatformCon 23 wouldn't have been possible without you, at least not at the scale that we are doing it at this year. Same for our media partners. There's some incredible publications there, Newstech, TechStrong, Women in Doubt. So thank you for being a part of the journey with us.
Yeah, and lastly, share the platform love on your social media by using hashtag PlatformCon 2023. Share photos, experiences, and also follow us on your LinkedIn page for more great content. And that's it. Let's round off. And Luca, shall we start an exciting platform day already?
We shall start. So let me queue up the video. Just give me a second. Bit of a technical reshuffling involved. And here we go. Have fun, everybody. Again, stay tuned with the stream, or go consume the talks wherever you want on the PlatformCon website, on the channel. Have fun, and see you at the Slack Q&A.
Hi, welcome to PlatformCon. Good platforms provide useful abstractions, but sometimes those well-intended abstractions can also become illusions, and that's not a good thing. So let me explain what I mean and help you build abstractions that don't become illusions. So why do we need abstractions? Well, today's technology is pretty amazing. The kind of things we can build. I work for AWS. We have a cloud platform, right? The kind of things you can build on top of that are quite amazing. But to be honest, they also tend to be complex. We build fine-grained distributed systems, eventually consistent ones. They can scale out, right? They can do many amazing things, but also forces developers to deal with that kind of complexity. So what do? We follow one of the most proven principles in computer science, and that is, well, we can solve any problem by introducing another layer of indirection, and that, in this case, should shield us from this complexity. Good idea, right? But we need to see how this goes in practice. So what we're trying to do is something like this. Oh, no, actually, that's the slide from last year, right, where we build on top of the platform. What we're trying to do now is build a platform on top of the things on the platform that actually hide all the details underneath. So almost same picture, slightly different architecture viewpoint. So abstractions, one of those fancy words that we like to use a lot and sometimes perhaps use it too easily. So let's look at what actually makes an abstraction. So another slide from last year, cars, right? I'm famous for car analogies, so we wouldn't want to have a PlatformCon talk without one. And I tweeted a while jokingly that if the engineers or the software engineers had named the car, they would have called it piston, crankshaft, gear, wheel assembly, builder singleton, perhaps, right? And this is an example of a poor abstraction, right? Naming something by, the sum of the parts, provides actually no real abstraction. Automobile is a good abstraction, is something that moves by itself. That's what it does. That's what its value is. And that is actually a good name for this thing. Now, analogies are only as good as they reflect reality. And in this case, reality is not far off. So rather than, point at possible, poor abstractions in other people's domain, let me just go close to home, right? That way nobody is offended and say, Well, here are some abstractions that we have built. We call them solution constructs. You can see on our website. And one of the line items in the document actually says, they define high-level abstractions. So there's our magic word. But here's a list of these solution constructs. And even though they're all super helpful, right? These are things I work on the serverless team. So these are things I do all the time, right? Connecting event bridge to Lambda, to SNS, to SQS, event bridge to step functions. These are very common tasks, and having these solution constructs makes you more productive. Helps you avoid making mistakes, right? And generally makes your life easier. But this is not abstraction. This is composition, right? This is like, the engine, transmission, clutch, wheel assembly kind of thing, right? And they are useful, so they have value, but there's a simple way to understand that these are not abstractions, because if I don't understand the vocabulary underneath, right? If I don't know what a kinesis stream, a kinesis fire hose, event bridge, lambda, SNS, and SKS is, if I don't know what that is, then these things make little sense to me. So useful, yes, but these are compositions. They pull multiple elements together, and many in-house platforms do that, and that's very helpful, but it doesn't pass our test for being a proper abstraction. So a real abstraction needs to provide a higher level vocabulary. Right? It needs to provide a new language that shields the user from the underlying complexity. So here's a useful abstraction. It's the gas pedal. Behind there's actually a lot of complexity, like fuel injectors, fuel pumps, air fuel mixture, cold starts, ref limiters, right? I won't stretch the car metaphor too far here, right? But it's a huge amount of complexity underneath here that actually has a nice abstraction behind this pedal. And actually properly we call this the accelerator. That is the right language. And that is something that provides an abstraction over all the complexity in the car. And it works extremely well. People who don't know about fuel air mixture and cold starts and chokes and carburetors versus fuel injection, all those kind of things can drive a car pretty much just fine. So that's the difference between an abstraction and a composition. So here is a good abstraction, right? And one that we use all the time and quite like, and that are sockets, like socket streams, right? When you want to, send data over the network, one of the nicest and probably most prevalent programming interfaces for this is the socket. So this has been around, I would say like 4 decades, probably at least, maybe going on to half a century. So this is a really nice abstraction. And what it does away with all the complexities. Careful with the word all, I come to that. It does away with most of the complexities of packet routing, out of order delivery, retransmits, multiple routes, route optimizations to the network. And on top, you basically just talk about the stream. Get me the next byte in the stream and the next byte after that. And this is an example of a really nice abstraction. And we almost don't even think about it anymore. Now, I cautioned on the word all because there is a famous law from Joel Spolsky, well-known guy, and that's the law of leaky abstractions, right? He basically says all abstractions are leaky. And I would say that is likely true, and it's also okay. Well, in the picture, you see a leaky abstraction that is not okay. That is the abstraction that claims to be a safe power socket, but in reality, it's leaking water, actually in my house. So that is not a good leaky abstraction, very scary. But otherwise, what Joel is mostly referring to is that what leaks are the laws of physics. So if you have packet loss or overloaded or unreliable network with high packet loss, you will have a lot of retries, right? And that will impact your latency. And latency is something physical. That's like time, right? That is not going to be abstracted away, no matter how clever our API is going to be. So yes, the abstractions will leak, but I don't think that's a reason to not try to make good programming abstractions. Just be aware that you can have nice logical abstractions, but that many of the physics behind it you might not be able to abstract away. And I'll pick up that point actually just very soon. So Coming to abstractions versus illusion, we talked about composition, right? That's not an abstraction because it fundamentally doesn't hide anything. So a good abstraction hides something and gives you a new vocabulary, but naturally the question will be, well, how much should you hide? And that's where we come to the illusion. If you hide essential things, then your abstraction can become an illusion. Now, essential is one of those weasel words that I used very deliberately here, and that's why we have architects and brains and human judgment, because we choose what is essential in this abstraction and what is not. And this is where this topic obviously gets interesting. So staying within distributed systems and the physics of it, here is an abstraction that I consider a dangerous illusion. That's a screenshot right out of my reInvent talk, API 308, where I talk about distributed systems. And that illusion is RPC, the remote procedure call. It makes us believe that a remote procedure call is just like a local procedure call. But in reality, that is totally not true. Right? A local call has almost no latency. Well, with modern compilers, it even JIT, it doesn't have any latency at all, because the runtime takes care of it. It has a shared address space. It has a call stack. It has a return. Right? It has all these kind of things built in that a remote call does not have. But instead, the remote call gives us like nice things like partial failures, high latencies, bandwidth problems, security problems, right? What was the definition of a distributed system? Some computer you didn't know existed, fails, and impacts your service, right? All those fun things you get when you use RPC. So that to me is the classic example of a dangerous illusion. It makes an abstraction that absolutely does not hold. It leaks horribly because all these things leak through. So it pretends to be something that it cannot be. And that does not make a useful abstraction. And I've seen things like this happen when we build in-house platform. It's tempting to make things simpler. We think we reduce cognitive load by taking as many things away as possible. Let me default all these parameters. Let me make these higher level kind of things, right? Let me make this as simple as possible for the users. But there is such a thing as too simple. And at that point, the abstraction actually falls apart, becomes an illusion. People might be excited at the very beginning. That makes it even worse. And then, once they find out that this has many bad surprises for them in stock, then they will definitely not be happy. So summarizing the big difference and giving some high-level guidance is that abstraction is very useful because it focuses attention of the details of greater importance, amidst things of lesser importance, so that the user of this abstraction, right, in case of an in-house platform, the folks that program against your platform, that they can focus on things of greater importance. And the illusion is when you start omitting relevant details that mislead the user. For example, that there's no latency or no partial failure, that is clearly an illusion. So as much as we want platforms to hide complexity, we need to make sure that they expose abstractions and not illusions. So let's make this a little bit more concrete. So I work on a serverless team. I have a long history in building distributed systems. So let's see some concrete examples where I would say concepts that are essential versus maybe some other things that are not essential, right? And I don't want to say this is sort of the ultimate truth, right? There's always some interpretation, and that's why we have smart folks and we have architects. So when I think I built a serverless, event-driven, fine-grained kind of system, here are the things that I consider essential. Push versus pull. Do the events go in or do I pull? Do I have control over the consumption rate, over the shape of the traffic? Very important. At least once, first in, first out versus out of order delivery. Very important. Time to live on queues, right? How do I make a queue not fill up? If I have a high arrival rate and a low consumption rate, something has to give. I need to deal with that. I cannot abstract this away. Transaction scopes and consistency, right? We often say first law of distributed transactions, don't use distributed transactions, but there you lose your consistency. Batch sizes, how many things do I process in one run? If it's 1,000, one fails, what do? Do the 9,999 go through? Do I retry just one? Do I reject the whole batch? timeouts, retries. Often say retries is one of the most dangerous maneuvers in any distributed system. So it definitely matters. But what matters less? Maybe the cloud API underneath, exactly what fields and what names those have, that's kind of detail. Even the names of the services or which services I map to might matter less, except maybe for cost, right? And that's where things become interesting. For some people, that's relevant. If you have high volume, right, you do want to know what services, what AWS or other cloud services you use underneath, because that will determine your cost. If this is, a couple 100,000 messages a day or something, that's not going to bother you. So tells you that there's not one right answer. It is a judgment, but you need to make a conscious decision about what goes in and what goes out. Now, I made it convenient for myself and said, well, here's an abstraction we've been using for 20 years for building asynchronous distributed systems. It has a language. It's not just sort of one word or one clever construct we have here. It has a whole cohesive language. It has a structure to it, right? You can see there's higher level vocabulary like a translator, and then there's sort of more detailed vocabulary like different kinds of translators like an envelope wrapper. Also, it uses some metaphors like control bus is a concept that comes out of networking and telephony and other things. So sometimes you can use words like claim check, right? We know from sort of checking our code at the music festival or the opera, right? So it's good to use these kind of metaphors as long as they don't, again, mislead the user. One thing the original book didn't have, which is one of my happiest things on the blog post on the website, is the control flow. Pushing versus pulling, pulling versus driving, right? Are you pulling on the front and somebody else pulls from your component, or are you absorbing and getting pulled from the other side? That's a classic QR buffer, right? So we actually made an extension to these kind of icons, right? The Gregorgrams, we sometimes call them. We made a visual extension that expresses the control flow. And I would say that is actually very useful, because otherwise there's a little bit of illusion here. And I would consider control flow to be essential. So then this pattern language should actually express that. And here are some of the things I'm actually working on. I'm sort of have to disguise this a little bit into pseudocode, right? Cloud lives with automation. So these kind of abstractions are programmable, right? We have this Terraform or CDK, Pulumi, all these kind of things, right? That's how you program the cloud. So you would program the cloud in these kind of abstractions, right? Read from a table stream in AWS. You can do this with DynamoDB streams. Whenever the database changes, give me a change event, absorb that, filter that, maybe make it idempotent by deduplicating if your front end is maybe a little chatty, overly chatty, right? Split this, transform this, and put this somewhere else. So it's a very logical language. It describes the intent of what actually happens. But it also has some physical aspects, right? This is a polling model. It polls from the table stream. Rather than doing that, I could also say, I produce an endpoint where everybody can just pipe things in, whatever they feel like. So they would have control. And then I think maybe all this downstream stuff I'm doing here, let's say I need to enrich something or talk to a legacy backend, having something that allows any arrival rate is maybe not going to do the downstream systems a great favor. So I can insert a buffer like a queue and invert the control flow. So some parts, work at the arrival rate, and other parts work at my favorite rate or the rate limiting of the downstream resource I have. So I can build all this, right? This is totally doable. You can put this on top of CDK, where you have an expressive abstraction that gives you good logical intent, like what am I doing with these messages and events that flow through the system, but they also express control flow, and that keeps it from becoming a dangerous illusion. So hiding some details here, right? This is not the complete cloud. This is not like event bridge step functions, SQS, SNS, right? So there's definitely something missing here, and that's what makes the abstraction. But because it forms a cohesive language, it ends up not being seen as something that's constraining. It is actually very expressive, and in the end allows you to focus on the important details in this kind of language. So I find this to be a good example of an abstraction. So time to wrap up, right? Platforms need to use abstractions. That is a great way to reduce cognitive load. Abstractions bring a new language, and that is more than just a single word or something clever, right? A language has a grammar and a composition, so it's a set of terms that together form a language, and omitting too much is very tempting. But if you omit too many things, like in my case, the control flow, if you omit those, you'll make the users happy for only a very, very short time, and then you make them unhappy for a very long time. So my appeal here, don't fall into that trap. And to reveal the picture we had at the beginning, that is obviously an illusion. It's really cool to have 3D printed things like this that look like an impossible object. Really, really fun when you're building these things, not fun when you're actually building internal developer platforms. So thank you for your time. You guys probably know where to find me, architectelevator.com. I have a book out now in 3 languages, the Cloud Strategy book, English, Japanese, and Korean. And I promise I am making some progress on my book on platform strategy. So with that, I thank you for your time, and I hope you find this insightful. Enjoy the rest of PlatformCon.
Welcome to PlatformCon 2023. My name is Nikki Watt, and I'm the CEO and CTO of a hands-on software development consultancy called OpenCredo, based in London. And I'm going to be speaking to you about why is it so hard to create great platforms as a product. Now, I gave a talk at PlatformCon 2022 where we had a look at, given our experience as a consultancy, working with a variety of customers, what does it take to actually build or set up a great platform initiative? Had a look at lessons learned and things like that. So that talk has some background to this talk that I'm giving now, so I'll put the link here in case it's helpful to you. But whether it's that talk or other talks that give advice on the subject, it seems that many organizations still struggle to actually do this well. And this got me thinking, why is this the case? Is there something that seems to stand out more as specifically challenging, or something that is harder to do than really kind of meets the eye? And that is where this talk was really kind of born. So the clue is in the title. Why is it so hard to create a great platform as a product? So inherently in the title, I give away my very firm belief that great platforms are forged in the fires of a platform as a product or product thinking mindset. But it seems to be that it's this as a product bit, when it has to get applied to platforms, that there seems to be a little bit of a disconnect. And I observed that whilst on paper and theoretically it seems simple enough for people to follow, on the ground this is much harder to actually do in practice. And so we're going to dig into that and explore why that is the case. But first, we probably need to have a look at why do I think the platform as a product concept is important. Now, many people have done specific talks on this topic and gone really deeply into it, and I do recommend that you check out some of their talks as part of PlatformCon. But by way of a short introduction, product thinking is really core to building a great product, whether this is a platform or otherwise. And this is because it prevents us from building something that nobody wants. The whole point of product thinking is to make sure that we put our users and their experiences front and center of what we do, so we don't just deliver a nice collection of disjoint features, but something that really produces their outcome and that is useful to them. So applying this to platforms, and particularly to internal developer platforms, which is what I'm really speaking about here, is no different. So firstly, this helps us to focus on the problem space of the users. And from our perspective, that is more predominantly your internal developers. And this is about doing what is needed in order to make life easier for them, in order for them to deliver software to their end users. Now, as with any other product, a platform needs to be useful and desirable. So, as I said, not a ragtag collection of stuff, but rather a curated set of offerings and features that users will genuinely find useful and actually want to use to do their job. Now, this is where product thinking provides us with techniques and the approaches and the frameworks that really help us to engage our users, get feedback, and adapt the product and the platform in order to make it fit for purpose. Finally, with many products, you need to consider how do you actually deal with adding new features and options to your platform. So how do you deal with the upgrades and the downgrade paths? core ideas in any product that need to be thought about and designed in right from the start to ensure that you can proactively create a platform that can provide a sustainable service to your business. So in short, we really are relying quite heavily on some of the product thinking sort of tools and techniques to actually help us create a really good fit for purpose platform. So product thinking to the rescue, but we seem to have these stumbling blocks in our way. So let's have a look at why that may be the case. So the first stumbling block that can occur that I see is because we don't always afford the platform the same considerations that we might if this was an external product. So we know it's all about the users and their needs. But because our users are internal, we sometimes have a tendency to think that we have a better inside track into what they're actually thinking, what they want, and maybe we can just short circuit some of the sort of user interaction stuff and just get there a little bit quicker. Now, taking internal consumers for granted is not necessarily something that is done intentionally, but assumptions are made about them. And this includes things like their level of ability. So you might say, well, they're developers. I'm a developer. They should know how to configure a YAML file. So I'm sure it's okay if we just provide that as an interface for the system. You might also think that you know what's best for them in terms of best practice for CI/CD, and then impose that on them as the way to do things. Also, they are a very captive audience. They can't really go anywhere. And so there's an assumption on their willingness to just accept whatever is put in front of them because, as I said, they can't really say no sometimes. And this can happen in the case where maybe features are not quite ready yet, but they're pushed out anyway because, well, they're just internal users and it's not really going to make that much of a difference. They can always help us to, make it better. Now, you generally wouldn't or you shouldn't make such assumptions about external users when employing product thinking. Rather, you would expressly ask them and conduct surveys to find out what is required in order to tailor the interface and the approach to what they actually need. Now, in addition to this, because most platform teams don't actually ship an actual product to the end users, they are sometimes treated as a cost center. And this treating the platform as a cost center or the product as a cost center can actually cause problems if it's not recognized. So this can manifest where the initiative is run more like a project, where it's focused on delivering like very specific features on time and to a budget, but not really what we're looking for here is more of the product thinking where we have roadmaps and we have ways of interacting with users and getting feedback and having this whole kind of loop. Now, this can run the risk of having budgets and sort of cost-cutting measures sometimes apply to you because you're not shipping a real product or it's not perceived to be a real product, so it's seen as an easier target for cuts. Now, an example of this might be where if you were an external team, you might say, well, it's feasible enough for us to have a marketing team or a support team that is really kind of out there and helping users to onboard onto our product and use it properly. But if you then ask for something like a dedicated evangelist sort of role or these type of positions, you might find that they're deprioritized as sort of surplus requirements because, well, it's not necessarily seen as it's not a proper product. So the antidote to this, however, is if you are trying to do this and to try and change the perception of leadership, if you are in this particular bind, is to try and market the value of the platform as either a revenue or a faster to market enabler. And this can be done by suggesting the use of metrics. So, for example, if you might suggest that let's have a look, how fast does it take for a new team to onboard a new product and get it to market without the platform and with the platform. And this can be used to actually drive and provide evidence for the fact that actually the platform really does provide end usage to the end users and to the business. Now, the second stumbling block can come across because we often insist on making our platforms mandatory. So if you look at other successful products out there, no one forces you to buy an Apple phone or to use AWS services. You generally do so because you've decided it's worth it. Now, product thinking understands this and gears the techniques and the approaches to try and build in specific opportunities to solicit regular feedback from users to actually improve, adapt, and make it a more attractive proposition as you kind of go along. And this needs to happen with the platform as well. The problem is that if you make the platform mandatory, you actually close off some of these feedback loops. Whilst an optional approach invites more discussion and innovation because it actually gets you much closer to something that is built for fit for purpose. So if feedback is not provided, well, feedback is often not provided because people will think, well, if it's mandatory, why would I might not sort of bother giving feedback because it doesn't matter anyway, it's not critical, and they're not necessarily going to do something about it because they've decided how they're going to do it in any case. So optional is really the way to go. But why does it happen that we try to make the platform mandatory? Sometimes I would say this mandatoriness comes because there's a pressure to actually use the platform for purely regulatory or security compliance. Now, don't get me wrong, I'm not at all saying that this is not can't be a feature of the platform or that it can't be used to achieve this. But when it becomes the driving force behind things, then the focus shifts off of what the user needs and more onto how can we get them to actually comply with the least amount of fuss. But again, if this is actually one of your goals, what you might want to do is not opting for a command and control type approach, but rather give the teams a choice. So define and communicate clearly what is required of either the security or the compliance aspects, and allow the teams to do that themselves, but then give them the option of saying the platform can do it for you, and actually it will go X times faster, or it will be so much easier. And use a carrot rather than a stick in order to entice them onto the platform rather than force them because it's mandatory. Now, similarly, a platform is also sometimes viewed purely as a cost-saving exercise. And this may well be true, but again, this is something that is more of a benefit maybe for the organization and not so much for the end user in this case. If it's a driving force, the focus is going to shift off of the users, what they need, what they kind of need for the platform to do for them. And it becomes more about how can we do this as quickly and as cheaply as possible. So with mandatory platforms, you will find that your teams may still end up actually being successful, but it may be in spite of the platform rather than because of it. And you really want to change, it's a reputation you don't want. So shifting more to have an optional platform is the way to go in this case. Now, product thinking is all about focusing on the user, but also on the problem first and not the solution. And this is so that you can build the right thing. But many times our focus is often drawn to the solution in the first place, and specifically that there is one right solution that we need to build on one right platform, rather than recognizing that this could just as easily be a collection of various curated things brought together. So why are we sort of constantly drawn to this one mono platform to kind of rule them all outcome? So one of the assumptions that we see here is that there's an assumption that's made that the platform needs to support every single use case out there. So you may be on a digital transformation and you have a big legacy estate that you need to sort of port over, but this doesn't mean that every single application from that legacy estate needs to land and be catered for on your platform. Some may be deemed, they just need retirement. Some may be lifts and shifts, and these probably couldn't and shouldn't land in a cloud-native platform if it's not suitable. But the assumption that you must cater for everybody runs the risk that your the main platform that you're building just becomes diluted, and it becomes not fit for anyone in the end. And you just land up with a sort of a jack of all trades and a master of none type platform. Now, the other area where assumptions are made is around the offerings that are actually implemented in the platform. So if, for example, you're offering a CI/CD platform or a CI/CD feature, it may be that you think, well, there should be only one of these things. We've only got enough resources to actually build one, and there shall be only one. But there's going to be different teams with different requirements, some wanting a lot of control, some maybe just wanting to give one or two sort of parameters and get a pipeline going. And it's okay to have multiple different implementations for the same feature. It is not problematic. You obviously don't want a plethora of them, but this assumption that there must be only one implementation is something that can actually cause you to to create features that are not fit for purpose. So moving out of this sort of mono-platform thinking is a stumbling block that is well worth trying to avoid. Fourthly, some of the challenges can occur because of how we actually put our teams together to tackle building the right product. And sometimes our blind spots and our assumptions can cause us to create less than ideal team setups. Now, in many companies, platform teams start out by being staffed with predominantly infrastructure engineers. And this is a very natural play because the platform is seen as more OPSI in nature. You're building infrastructure services. However, we observe that this natural skew towards the OPSI-centric solutions lands up, op-centric staffing lands up with more op-centric solutions. And instead, what we really want is this balance of both infrastructure as well as application. And this means ideally we want to have a bilingual team, for lack of a better phrase, and a mix of engineers that really understand architecture and application requirements, some of the challenges around that, as well as infrastructure in order to help really kind of bridge the gap. Now, in a platform team, this point is particularly maybe a little bit controversial, but the product owner or the product management type role is really key. And I would say that ideally you want somebody who has got a technical background here. So this is not essential, but it is certainly helpful because being forearmed with some of this knowledge can really help to build more sort of natural empathy and understanding with the various different users of the platform in different situations. It can be useful when you may need to be sort of a referee in terms of different requirements coming in, competing requirements, or indeed actually to help sort of understand and assess when to make trade-offs about what things should be in platforms and not. Obviously, you would be working with your technical architects in this particular case and your platform engineers, but having this technical background, I would say, is quite important if you can find a product owner that has that, because it really does make a big difference in smoothing the sort of some of the road to understanding some of the challenges that your end users have. Now, another less than ideal setup is to have a static or non-evolvable team. And this is specifically where the platform team, in whatever shape or form you kind of find it, is not able to spare the time or the resources to help teams onboard and troubleshoot. So this time needs to explicitly be built in and factored into. Now, we find the concepts of using enablement teams, as it's described in team topologies, as a really helpful mechanism here. So this will allow your platform team to really engage with the users and build in solid feedback loops. So we've had quite a few sort of engagements where these enablement teams are really able to understand and work with the end developers and engineers to find out what is it that is problematic that we need to feed back into the platform, and go on this kind of loop where you have a decent sort of feedback. So the team itself made progress, but also that knowledge comes back into the platform, and you get this good sort of loop going. Finally, the fifth stumbling block is one of my main points actually from my previous talk. So I'm not going to go into too much detail on this, but really as engineers, we tend to have a very unhealthy focus on technology. We always want to start by building something concrete, and this can really lead to problems, and you can trip over yourself if that's the case. Key to building the right thing is to focus on your users first and the technology last. So don't let the tail wag the dog. Think of your users first, do the tech last. And if you want more on this, I suggest that you have a look at my previous talk. So in conclusion, just to reiterate, I think great platforms are indeed forged in the fires of platform as a product or product thinking mindset. But you need to be aware that there are some potential stumbling blocks on this path. And this can happen because there are either parts of you or your organization's approach and ways of working which may seem very natural and default to you, but some of these assumptions may ultimately work against you in trying to achieve the end outcome if you aren't aware of them. So I list them here in one slide for your convenience. But with that, I have come to the end of my talk. And so I just want to say thank you very much for the opportunity. And and I look forward to taking some questions in the forum after this. Thank you.
Hi everyone, welcome to PlatformCon. My name is Manjunath Bhat and I'm a Research Vice President here in the Software Engineering practice at Gartner. In this session, I'm going to discuss how can we communicate the business value of platform engineering. This is a topic close to my heart because I've been working on software engineering all my life. In Gartner, I cover DevOps, platform engineering, cloud engineering, and these topics come up a lot. Recently, as much as the debate has been around what's it like between DevOps, is DevOps dead, is platform engineering taken over, and so on. While organizations are trying to implement platform engineering, one thing that we find that most clients struggle with is how do you communicate the true business value of platform engineering? It's fair to say that the last decade was all about organizations introducing DevOps. Now, as you can see here, this is the problem that happens when you try to scale DevOps. So what's being depicted in this slide is that you end up with multiple teams all doing pretty much a lot of the same things. There's lots of duplication between teams, let's say duplicating the way they build pipelines, the way they manage databases, the way they manage infrastructure, the way they manage environments. There's lots of repetitive operational toil. This is not necessarily the most efficient way to do things when you want to scale DevOps. We can liken this to the way business owners, let's say, use food trucks, right? Let's use food trucks as an analogy. So the metaphor of food trucks is business owners will really use food trucks as if it was a standalone entity where you have multiple food trucks all managing their own sort of infrastructure, right? So you have water problems, you have supply of electricity, right? You have cooking needs and so on. And every food truck happens to be a clone in its own right. So you have replication of kitchens in each food truck. The problem statement, as you can see here, is how do we scale DevOps in such an environment? We want to enable multiple teams to build, own, and operate their own products, which is commonly called as you build it, you run it. But food trucks does not necessarily help scale this kind of operating model. The solution, what we've typically seen works, is when you create a platform engineering organizations that can externalize cross-cutting capabilities across multiple product teams. What you see here is that it's not necessarily that the platform teams take away all of the operational work from the development teams or the product teams. There's still what we would call app ops, which is there's still an element of you build it, you run it, but it's to do with the specific application that the product teams are working on. All of the underlying infrastructure complexity, the undifferentiated heavy lifting, right, automating of security and compliance needs, all of that gets subsumed within the platform team. That's what is being depicted here. And this leads to the model of shopping malls. Now, in a shopping mall, you can see, as opposed to food trucks, you have business owners that can focus on their core competency. They're able to focus on their customers, right? They're basically externalizing, in fact, outsourcing all of the non-essentials, whether it is electricity, air conditioning, and so on, to the management of the shopping mall itself. And this is a win-win both for the shopping mall as a platform, plus the business owner who manages the shop, which is the application itself. Scaling DevOps is great, but it is only part of the story. Most times we hear that platform engineering is a way of scaling DevOps, but the senior management does not necessarily understand, is scaling DevOps the true business value of platform engineering? How do we communicate the business value of platforms going beyond DevOps? We've typically heard, let's say, for instance, you could use agility as one of the business value parameters, right? What we would call value drivers of DevOps would be agility, in some cases operational efficiency, improved security, and so on. But the problem with using very standardized cookie cutter value drivers is that it's not necessarily a one size fits all. So in this session, what I plan to do is not give you the specific elements of what constitutes business value, but give you a framework, a model that Gartner has put together on how you should think in terms of communicating the business value. We call this the Gartner Enterprise Value Equation. As you can see here, the enterprise value equation is broken down into two parts. Now, the upper half is about the stakeholder domain, the lower half is the enterprise domain. Also, the other two halves are on the left and right, more importantly, which is you have these two very closely intertwined curves. On the left, you have the value creation curve, which is all about we as platform engineering organizations really look at our offering in terms of the value we provide. And on the right, you see the value realization curve, which is really about both the stakeholders who receive value from the platform teams, as well as the broader organizational goals that the platform teams aims to fulfill. If we look at, let's say, the specific elements of the enterprise value equation, it's fascinating to see how you can really take this in a step-by-step manner. The first step in applying this enterprise value equation to our platform team concept, which is basically saying, like, how can we use Gartner's enterprise value equation to communicate the business value of platform engineering specifically? We look at the first step, which is essentially to say we got to assess stakeholder priorities and concerns. And in doing so, what would be the first thing? We got to listen and sense. We got to listen to who the stakeholders are, what their needs are, and their needs could be different, right? In fact, that's the very reason this model is called the multi-factor enterprise value equation, because it's not single factor. Platforms don't necessarily serve just one audience. It's not one single stakeholder. So you have multiple stakeholders. So we got to listen and sense to different needs coming from these different stakeholders. In some cases, you look at what's being shown here. So you have stakeholder priorities and concerns, which could differ based on which stakeholder you're speaking with. Say, for instance, you're speaking with a software engineering leader as the stakeholder. For them, the concern would be, how do I attract top developer talent? If you're talking to maybe the chief technology officer, for them, the concern is, how do we accelerate the pace of innovation? In many cases, for chief digital officers, it could be, how do we build competitive differentiation? For security and risk leaders, it could be, how do we ensure regulatory compliance? How do we automate security and compliance? So depending on different stakeholder priorities, you can quickly see how your response in terms of the business value that the platform provides could be very different depending on which stakeholder needs we plan to address, which stakeholder needs we plan to prioritize first. Now, still staying on the value creation curve, the next step is to look at how we develop our options. Now, we call these value enablers. Let's break this down a bit. So value enablers are essentially like, what is the value we truly provide? Now, when I say value enablers are fundamentally, in very simple terms, it's the action the platform teams take. What are we building? What are we providing as the value to the stakeholders? It's very specifically, what you can see here are things like internal developer portals, internal developer platforms. You may have, in many cases, environment management tools. You could have container management platforms. In some cases, also increasingly, how do you institutionalize things like observability-driven development, things like fuzz testing, chaos testing. In many cases, it's also becoming, say, for instance, automating policy as code as much as you start moving to infrastructure as code. So all of these are what we would call value enablers. And these are, this is part of a step, what we call developing our options, right? Because it's not, like I said, one thing to one stakeholder. We're really trying to provide value of the platform and multiple platforms, in many cases, to multiple stakeholders. The next thing we do in communicating business value is, how do you build a value story map? A value story is essentially a very compelling narrative. It's a narrative, but it's not just an empty narrative. The narrative is accompanied with supporting metrics, which is, in many ways, you can think of this, we can think of value stories as an effective tool whenever you have to communicate the business value of any initiative. In this case, we just happen to be talking about platform engineering initiatives, but it could equally apply even if you want to communicate the business value of any software engineering initiative as well. So the key elements of a value story are, one, is it aligned to business objectives? Is it tailored to stakeholder priorities? Is it easy to communicate, right? Is it easy for stakeholders to digest and understand? So we got to build a value story that maps the value enablers, which is what are we building, to stakeholder impact. We have to support the value story, like I said, through metrics, but these metrics are not output driven. These metrics are outcome based. So output would typically mean like what you see on the left side, which is driven in terms of activity metrics, like how fast are we going, how many story points have we completed, what's our throughput, right? How many sprints are completed, right? Flow efficiency, all of that. What we look in terms of outcome is what we would call like optimizing for flow of value. Is the customer satisfaction improving as a result of the investment in our platform? Is our organization seeing a higher return on that investment? Is our market share growing? Right? What's the customer retention looking like? Are we able to attract good quality talent? All of these are outcome and impact metrics. So a key takeaway here is that we got to support our value story through outcome-based metrics and not necessarily output-driven metrics. When we do this, we also now look at mapping value enablers, so stakeholder impacts and outcomes. Now, where did we come from? We said we're going to provide value enablers. That's what are we building. We create a story map, or we build a value story to connect the value enablers, so stakeholder impacts and stakeholder outcomes. We then look at what we call balancing trade-offs. Remember I said that you're going to have multiple stakeholders. Right? And these multiple stakeholders in many cases could also have conflicting priorities. So the need for a security and risk leader could be very different from the need for a software engineering leader. So the platform owner, the platform's engineering leader should be able to balance these trade-offs. Some examples like you see here, if you're talking to the software engineering leader as the stakeholder, for them, maybe they come with you with a need saying we got to improve our developer experience for our development teams. The operations person, remember that platforms are not necessarily just I&O platforms. So in many cases, you could have the platform teams having a customer as also another team from the infrastructure and ops group. And for them, the concern could be, how do I reduce operational toil? Right? This is, in fact, also, you can think of the platform team itself having to create an impact on its productivity. So reducing operational toil is, in fact, a benefit for the platform team itself. Right? So and also more increasingly, SREs become one of the consumers of the platform. So improving resilience could be one of their needs. The other interesting aspect of communicating business value that I've often seen is to communicate the why. And this is often lost in all of the noise. Right? We often forget to communicate the why, which is extremely important if we have to incentivize mindset shifts. Remember, it's not throwing a tool at the problem and expecting magic to happen, which is, unless we bring in a mindset shift, we can't necessarily see the platform adoption growing. We can't necessarily see the platform driving business value. And you can see some very interesting examples like you see, like for instance, if you want to communicate the value of why do we need to go from enforced processes to paved roads as a concept. So we use this framework called the from, to, and because. So we say we go from enforced processes to paved roads because we have lots of infrastructure complexity. We want to minimize developer friction. We have to encourage automation, because without automation, it impedes our business agility. So we use from, to, because as a framework to communicate a lot of these shifts that are happening in the organizations. Many cases, it could be paradigm shifts. So the more foundational, more profound the shift is, the higher the value of from, to, and because. So you see here, the most, I think, if you look at the big shift in platform engineering, it's the idea of treating the platform as a product. So you can really see of one of the things I've highlighted here is how do we move from IT or infrastructure projects to treating platform as a product. So we're going from to treating platform as a product because X, Y, and Z, right? That's the framework we would use to communicate the business value and incentivize mindset shifts across both the people producing the platform as well as the people consuming the platform. Now, overall, right, let's look at it this way. On one hand, we said there's stakeholder impact. Now, the final bit of this is that we got to now look at what's the value that the organization realizes, right? So the final aspect of this is we have value enablers that are provided by the platform teams. We have stakeholders that derive value. That specific stakeholders could be security teams, like I said, could be SRE teams, could be software engineering teams. But it's also overall, what's the value of the platform to the organization as a whole, right? So this is where the last part of this curve, which is what's the return of value to the organization itself, becomes important. And like you see specific elements called out, which is improving customer satisfaction. And for organizations, driving revenue growth becomes even more important than to a specific stakeholder, right? So time to value is extremely important from an organization perspective. So this is more, think of this as CEO level concerns, that is chief executive officer level concerns, than the individual stakeholder concerns, which could be at a business unit. Ultimately, also one of the activities that needs to happen here is look at one of the phrasing called adjust and iterate. Adjust and iterate means that this is not a once and done activities, right? We look at what's the return to the organization. In some cases, we may have provided that value to the organization. In some cases, we may have to fine tune the platform so that the value to the organization is much higher. Overall, I've tried to depict this slide, which provides a comprehensive view of the entire enterprise value equation and contextualize this to platform engineering. Everything from identifying specific stakeholder activities or stakeholder priorities and concerns on the left, which is what are maybe software engineering concerns, what are the value enablers, that is what work do the platform engineering teams do, what is the actions they take, what artifacts do they deliver, right? That's all on the value creation curve. On the right side, you have the value realization curve, which is what are people getting out of our platform initiatives. On the top right, you see stakeholder impact, which is as software engineering teams, what they will expect from the platform is to enhance developer experience for their development teams. And as an organization, what you want to really communicate is the value that you bring to the organization in terms of driving revenue growth, increased innovation, and so on. A really good example of this comes from Nike. We did a case study. It's one of my favorite case studies because it talks about the value of composable platforms. If you look at the way they've used business value to communicate the value of their platforms, it's wonderful because the origins of Nike's initiative was they realized, especially as they were embarking on consumer direct acceleration strategy, they quickly realized that they had a spaghetti architecture, right? As you can see here depicted, which is their architecture underpinnings and the technology portfolio hindered business agility. In many cases, it was enormous operational complexity that they were dealing with. It was very difficult for developers to even discover what existed. But all of these are like tech speak, right? This is not communicating business value, but pay attention to what's mentioned at the top. So Nike's highly complex landscape of thousands of systems and components slowed business agility, time to market, and innovation. This is exactly what we were talking about all along with the enterprise value equation that I just showed on the previous slide, which is using business value terms in terms of how do we reduce time to market, how do we drive greater innovation. This is exactly what Nike embarked on, right? So Nike said the value of composable platforms is not necessarily to improve our throughput, but it's to drive innovation, it's to reduce time to market and so on. As you can see, they moved from a spaghetti architecture to a lasagna type architecture where you've created multiple foundational platforms. And this is another interesting aspect of all of the discourse going around platform engineering saying, is this just one platform team? Is this just one platform? It's not true, right? You could have layers of platforms, and these layers of platforms are quite dynamic. It depends on who the consumer is. Remember that one of the core foundational principles of platform engineering is that platforms are demand driven. So it's not the platform teams come up with this brilliant idea saying we're going to build a platform and then figure out who's going to use it. But it's all about identifying who the consumer is, what their needs are. We got to treat the platform as if it's a product that's going to continuously evolve and iterate based on our consumer needs. That is the customer who's going to use our platform. In this case, Nike came up with three foundational layers to their platform, which is about foundational platforms, core platforms, and then experience platforms. Finally, I'm going to leave you with the three value pillars for platform teams. This is I wouldn't call this necessarily a recipe, right? So take it with a pinch of salt, but these are the common value pillars I've come across when organizations undertake a platform engineering initiative. So the value pillars are reducing time to value, or faster time to customer value, as we like to say. And this is achieved through the bullets that are listed here. So faster time to customer value is provided through self-service mechanisms that are enabled by the platform itself. As you know, platforms simplify DevOps workflows. We shorten the feedback loops, and this is extremely important. So if you look at one of the three core principles of DevOps, actually one of them, the first one is shortening feedback loops, and this implicitly improves the time to value. Improving resilience is another key value pillar, especially if you want to make reliability a key differentiator for your product itself. And I'm sure if you're treating SREs as one of the platform's consumer, for them, resilience is going to be an extremely key value pillar. The last bit is on governance. How can you embed governance? How can you build governance guardrails, that is security and compliance guardrails, into the platform itself? So if security and risk leader are your target consumer for the platform, then pay attention to this third value pillar around governance. So with that, this is all I had to share on how you can communicate business value of your platforms. I hope you found it useful. Happy to chat with you. If you're a Gartner client, enjoy the rest of the conference. Thank you.
Hello and welcome. My name is Stefan Schneider. I'm an expert for software engineering excellence and developer experience at McKinsey. And together with my colleague Mike Gatto, we will be talking about developer platform reference architectures today. I'd like to start with this picture because this is the reality we see at many of our enterprise clients. Years and years of lacking standardization in organizations, and also a large amount of just legacy technology that has been growing wider and wider, just make a very complex environment for software engineers in large organizations. We then have growing more and more complex technology tool chains, deployment delivery tool chains. And that is also then backed by heavily manual work, non-value adding work engineers and operations folks actually have to do. And all that just adds up to a poor experience for software engineers. And where does that lead, right? So number one, productivity and innovation, right? If I have to wait hours and days until my code is testable, or even months until it hits production, right? I just get frustrated as an engineer, right? And that obviously brings innovation to a halt. But it also increases pressure on operations folks, right? So that is then waiting time for other teams. There is constantly pressure on people to, let's say, do their ticket ops, right? And then teams don't have the capacity and time or get their headspace to actually work on the depth and invest in automations. And then on top of that comes this increased cognitive load for developers, right? So today as a developer, with the idea of you build it, you run it, I need to stay current on the latest software engineering practices, the latest tooling. I actually need to understand how to run the show in production, plus understand how to integrate with all the cloud service offerings out there, and then actually also keep up with the ever increasing pace of feature delivery that is required, right? And then having let's say, an ever-increasing explosion of complexity of enterprise application landscapes just doesn't make it easy, right? But what in the end, what do organizations want to achieve? And that is developer experience and productivity for developers. Yeah? And how do I get there? By standardizing the engineering approach, right? So that means, on the one hand, applying and basically applying this wide and globally in the organization, engineering industry practices, right? Just following the basic cosmetics, but also the best practices. Yeah? That also means I need to empower and enable my engineers, right? Self-service, abstracting away unnecessary complexity, right? To also then enable faster onboarding and faster delivery for our engineering population. Yeah? And that means I need to standardize the tech stack and toolchain underneath. Yeah? And one means for that is a developer platform. And with that, handing over to my colleague Mike, who will lead you into this.
Thanks, Stefan. Hi, my name is Mike Gatto, and I'm a senior DevOps engineer at McKinsey & Company. Today, I want to take a high-level view of the reference architecture that we use to deploy an MVP developer platform. So in this case, we're going to start with the top, with the developer control section here, and we're looking at our version control. So this is where all of our developers publish their code that they write, and along with their code, in order to kind of provide the necessary information to run their application as a container in a Kubernetes environment, they provide a workload specification. Now, this is just a YAML config file that codifies things such as the image to use, any resources like CPU and memory, as well as any external dependencies. So things like, does it need a database, for example? So once that code is checked in, a CI pipeline gets kicked off, and that first, it actually builds the application code into a container or multiple containers, and then publishes them to a registry. Once that's done, the CI pipeline then notifies the platform orchestrator of the new artifacts in the registry and kicks off a build. So the platform orchestrator is managed by a different team, the platform team, and they configure, based on the environment, they might have different settings, for example, different clouds, different Kubernetes clusters, but that they basically examine the score file that was provided by the application team or by the developer team, compare it against their configurations, look at what resources they already have provisioned and what still needs to be provisioned to kind of meet this new requirement. They combine that with any Terraform code that they have to manage provisioning of those resources, which is stored in GitHub, and they use that to provision those resources. So, for example, compute, if there isn't an existing Kubernetes cluster, one will be built. In this case, the application might need databases, so we'll have MySQL databases being provisioned and whatnot to support that. Kind of moving on to more the AWS specific architecture. Obviously, there's different architecture for Azure and GCP. So this is a pretty standard VPC at Amazon, 3-tier subnets. So we have our web subnet, our app subnet, and our database subnet. We have EKS cluster, which is Amazon's Kubernetes service cluster, the nodes deployed into the app subnet. And then in databases we need, so we have 2 databases actually required for our reference application. And these are deployed in the database subnet. Now we're going to move on to a live demo where I actually show this all in action. In this demo, I'm going to be showing how we were able to separate developer and operations concerns by using this developer platform in a box solution that we built. This solution uses a combination of a workload specification tool and a platform orchestrator. For the workload specification tool, we're using an open source project called Score. And for the platform orchestrator, in this demo, we're using Humanitech, but you can use other options as well. So what this solution does is it allows us to set up an MVP developer platform for a client in about a day, which is a fairly complex thing. And the reason we're able to do this is because all the architecture is defined in code and only requires a minimal setup. For example, we need a cloud account, whether it's AWS, Azure, GCP, etc., and the configuration information on how to connect into that. Now, as part of the solution, we're also developing application patterns for developers and platform teams to kind of serve as a showcase of what's possible with the solution and to give some ideas. And it also serves as a starting point for developers to kind of create their own application patterns that better suit their needs. So what I'm showing here is a 3-tier sample banking application. And as part of this demo, we're actually going to walk through how this actually works and actually deploy it to AWS. So this application is made up of 3 microservices, which will run as pods inside of Kubernetes eventually. So we have our front-end service, our Money API service, and our Users API service. So if I click in the Money API, this is all built out of JavaScript, and this will be Docker container. So you see the usual suspect files, our Docker file and our other source code here. But I want to draw attention to this score.yaml file. And as the name suggests, this is the configuration file for our score workload specification tool. So if I click in and look at the contents, a lot of this is going to look familiar to anybody who's worked with containers before. We have our container image, we have CPU and memory resource requirements, and our variables that we pass in. But notice at the bottom we have this resources definition here for a database of type MySQL. But we don't have any of the other usual information you would need, such as the host, the port, the username, and the password. And that's because, from the developer perspective, developers don't care where or how this MySQL instance comes into being. They just care that it's there as a prerequisite for their application. So what will happen is that the score tool will translate this and send it over to our platform orchestrator, and then we're going to build it in our target environment. Speaking of target environment, let's take a look over there now. So in this demo, we're going to use AWS. So I have here an AWS Sandbox account that is pretty empty. So what we're going to need here is we're going to need a VPC. We're going to need a Kubernetes cluster, which we're going to run in Amazon's Elastic Kubernetes service. And we're going to need a MySQL database, which is going to run in Amazon's RDS relational database service. So let's start with the VPCs. So as you can see here, there's a VPC already, but this is the default VPC that comes with the account. I don't want to use this. I want my own VPC set up the way that I want it. So we're going to create one there. For Kubernetes, we're going to go to EKS. We currently do not have any clusters, so we're going to need to fix that and generate one. And for RDS, we're going to need a grand total of 2 databases for our Money API and Users API services. And if I look over in RDS right now, I currently have no databases, so we're going to have to provision those. Now to provision them, I mentioned that Score will talk to our platform orchestrator, so that's where we have here. So right now I'm looking at the resource definitions in my platform orchestrator. And what this does, it allows platform teams to define where and how applications get deployed. For example, in a development environment, we might have very different Kubernetes cluster settings, number of nodes and how big and how expensive they are, based on whether it's development versus staging or QA versus production. And they set all this up and they write the Terraform code for this, and this allows them to control that process. And again, by separating developer and platform team concerns and allowing them to control their respective areas that they're experienced in separately without requiring too much overlap there, what we're doing is we're making deployments more compliant and better aligned with the client initiatives. So now that's being said, so we're going to go ahead and deploy an application. So if I go up to applications here in my orchestrator, I currently have no applications defined here. So we're going to fix that. We're going to create an application called Bank Demo. And what I'm going to do is I'm going to kick off, and we'll see it's an empty application. There's nothing in here yet. So I'm going to go ahead and kick off a pipeline in GitHub Actions that's going to generate the code for our application here. And then we're going to take a pause and come back and let that build. So the actual provisioning of the AWS resources is going to take about 20 minutes or so. So we'll give that some time to provision, and then we'll come back and take a look at it. So we've given it some time, and it looks like the deployment is successfully completed. As you can see here, it shows in the running state. I look into the deployment details here, I should see my 3 microservices. And what that means is that all of these resources have been deployed to AWS. So if I go back to my AWS console, you can see I have my 2 databases that I mentioned earlier that are needed by the Money API and the Users API. If I go over to my VPC here, whereas before I had the one default VPC that came with the AWS account, now I have a second one, which includes all of the subnets and route tables and normal network plumbing that you would expect from AWS. And I should now have a Kubernetes cluster if I go over to the Kubernetes service here. Whereas before I had no clusters, I now have a cluster that is running my microservices. So if I bring up a console window here, I can go in and examine the contents of the Kubernetes cluster. So if I look at the namespaces here, you'll see that I have the normal Kubernetes namespaces. I have an Ingress Nginx controller, which handles our communication in from the outbound world so we can get to our application, which we will in a second. And then I have this randomly generated namespace name here. This is where those microservices has been deployed. So if I list the pods for those, for that namespace, you'll see that I have my 3 microservices right here. Along with, you'll see some Fluent Bit containers here. These are put there by the platform orchestrator just so we can monitor what's going on in here. So now I actually want to go to my website. So I need to get the DNS name. We are using dynamically generated DNS names. So if I look at my ingress object for this namespace, I should see a name that I can plug into my browser here to get to my demo application. So we'll see it right here. This points to an AWS resource here. And here's my name. So if I go up here to my browser and I paste that in, and here we are. This is the demo banking application that we just deployed from scratch, just from code, where we had the score config file. We passed it into our platform orchestrator, which built all of our resources out based on the Terraform definitions provided by the platform team. And we ended up with a fully deployed application.
Thanks, Mike. So with this reference architecture, we address some of these issues we mentioned earlier, right? So first of all, I'm reducing time from my idea to my first line of code that I actually write that solves a customer problem with these application patterns, you know, and standardized setups. But also from my commit until the code is actually in production, right? Down to hours instead of weeks and months. You know? The pressure from ops teams I release by providing self-service access and automating away these complexities. You know? In terms of the cognitive load for developers, that is also abstracted away on the one hand with application patterns by providing standardized setups, but also then with dynamic configuration management, reducing this explosion of complexity by keeping standardization and keeping my stack and application to the standards defined by the platform team. But a developer platform is in that case, first of all, just a tool, right? And it requires a lot more than just technology to really improve developer experience and productivity at scale, right? So starting with the foundation, so getting the architectural principles and direction in place against which that platform team, your platform teams can then operate, right? So that starts with cloud strategy, the proper guardrails on tooling, and making also very opinionated decisions on how to use and build technology. Right? Our capabilities and mindset. So it requires a really strong engineering culture, which is embraced from top leadership, right? So that also, for example, empowers your teams to invest in platform improvements, to work off and pay off technical debt, right? But also empowers and enables your platform teams to operate and work like a true product organization, a true startup that can also create pull to that platform. Right? Similarly, on processes, we need to drive the standardized engineering approach in the organization, and also establish a governance that enables flow, right? So that engineers and the platform teams are not stuck in organizational red tape, even though everything else around might be automated, but still the governance doesn't allow that flow through the platform. And then last but not least, of course, the technology. So establishing a developer platform as the one-stop shop that engineers want to use. So really creating this pull to the platform are key to making this scaling a success. I hope you enjoyed this talk, and Mike and I are both in the platform engineering Slack channel, so feel free to ping us there.
Hello everyone, my name is Gan. I'm SRE manager at Electrolux.
Hi, my name is Christina and I'm SRE product owner, which means that my consumers are developers.
Today we will speak about why we skipped SRE and switched to platform engineering.
When you introduce a SRE set of practices to developers, it's absolutely the same when you introduce something new. Which from our problem it's going to solve? And what will change if we go this path? And you need to explain, you need to teach. But which from developers' problems it's really going to solve? They would love to write a code and push it in production immediately. But we want them to be focused on the way how it's delivered, how their services monitored, how they provision the infrastructure for their services. Have they achieved their SLO? How does it cost for them? But do they really want to know all of this and do this? They want it to be done. And we want our consumers to be happy. Shall we list all developers' day-to-day pain points? But we already know them. Every service request, every direct message, every urgent meeting about how they blocked because they need new cluster, new pipeline to migrate from one database to another. That's why we don't need to do any user research. We already have all data we need. We need to create for them golden path where they can click one button and get new AWS environment, or they can simply name their service and after a few moments they can see it up and running. Automation already added this service in pipeline, provided base login, repo creation, vault configs, and added it in Kubernetes and Docker registry. So developer can actually upload it locally and write the code and push it immediately. To build such a solution, you need to know only one answer. What is SRE in your company? So let's pick what is SRE in Electrolux. We are one of the major appliance manufacturers with a strong focus on sustainability and providing meaningful digital experience that enable our consumers to live healthier and more convenient lives. Our appliances are divided into three categories: taste, well-being, and care. A subset of these appliances contain a Wi-Fi module that allows them to be connected to our connectivity platform. That's what we call connected appliance. And Electrolux Group holds a large number of brands, but the three brands my team currently support are Electrolux IG Frigidaire. We are currently launched in over 60 countries and support over 20 languages, and we run our services from 3 regions. Our organization inside Electrolux is called Digital Products Organization. Here is where connectivity started in Electrolux and being developed. So does SRE.
Let's look at how we grow as an organization and as a team. So we started with one product, which is our connectivity platform. We have around 10 developers, 2 SREs. But look at today, we have many teams, many developers, around 200. We have many products as well, but we only have 7 SREs located in 2 regions. And this is our SRE journey. Google has published their journey in their SRE book, but every organization is unique, so we need to figure out what is our SRE. We started with the first version of our connectivity platform. That is one team which contains both developers and SREs. We work very closely with each other. Developers, they focus on features, and the SRE focus on operation and maintenance. As usual, we had org change, so we were separated into 2 teams, but still it's the same product, and the collaboration remains the same. There's a bit change of the way of working. developers started to file tickets to SRE team for each request. For example, when they need some database or when they need a Kubernetes cluster, they will file ticket, and SRE team will resolve all those tickets and provide infrastructure to developers. Then our organization keeps growing. We have the second connectivity products, and we also involve cloud migration for our new products. Then we realized, okay, 3 SIs is not enough to support all the tasks because there are too many tickets created for different infrastructure, for maintenance, for troubleshooting. So SRE team focus more on knowledge sharing and automation from them, because we would like developers to take some responsibility of the infrastructure operation and troubleshooting as well. Till today, we now have many new products. As I say, team, we become the new product team as well. We started to build our platform, which will be used by our developers. And this is the new self-service model we provide to all product teams. The platform contains all the automation we had in the past and the different policies we have defined, the patterns, best practices we have learned from the past few years. If developers need any infrastructure today, for example, if they need a Kubernetes cluster, they need a database, they can simply go to the platform and click a few buttons and make some selections, and they will get their infrastructure up and running in a few minutes. They don't need to file any tickets to SRE team, and we can also ensure that all infrastructure got created. They have the same kind of policies. They follow the same patterns as well. So how does it work under the hood? The platform is connected with all internal tools, which means for developers, they don't need to navigate through different tools. They can use the single platform to access most resources from the organization. And we offer 3 main features, which focus on infrastructure, services, and APIs. Each feature contains multiple predefined templates, which has our policies embedded. So if someone creates a new infrastructure or creates a new service, we can ensure that it already has what we need, what we have for security, what we need for observability. This provided a paved golden path for our developers, so they don't need to worry too much about, for example, how to set up CI/CD, how to set up monitoring, how to set up alerting, and we also have predefined dashboards generated as well. So when the database got created, the dashboard for the database is also created. People can use it to check how it is running today, and if there's any issue, they will get alerting as well.
And how to measure the results? We have learned how to measure it in money. I will explain how we do this. There is a thing that Gank already mentioned. Our S3 team became a product team. It happened because in one moment we realized that rather to provide separate features and automation, we need to cover the process from the beginning, the whole journey. We have done several brainstorming focusing on the developer's needs. I mean that you can create a good automation, but if, for instance, there is no friendly interface, or it's hard to find, or developers need to use console, the usage will be low. The feedback will be low, and again, there will be service requests and Slack messages. So we took it as one of the vitals. We created a plugin to track costs and cloud costs and added it as a metric based on the amount service requests per month. The first intention was to show that it costs real money to do manual work, rather a S3 team can spend time and provide the automation, then it will be for free. Another one is saving. We have learned how to observe costs and identify what can be reduced. Before, our S3 team was responsible for costs for infrastructure. Today, we see how product teams became the owners of not only their products, but it finally includes the expenses for their for where they run their services, pipelines, etc. And we do surveys, interview, SRE office hours. We continuously speak with our developers to understand what they really need. To automate replication for the new region, or they need a small change in already automated user onboarding, like to add a new tool. So consumer experience is everything. There are additional positive effects, like visibility. Everyone got the understanding what the infrastructure is in our organization, because you don't need to log in and AWS console to see everything. You already have it in our platform. And the job is done the way we wanted it to be done. Because if you will try to explain one developer how everything should be set it up, and then you will take another developer and you will explain the same, the result will be different. Collaboration and sharing experience. Again, when you have visibility of what other teams are doing now, you can understand more and you can speak more and you can share this experience with others. And the last one, of course, time to market. Very nice side effect, I would say. Faster delivery. After watching this presentation, you shouldn't simply follow the same steps as we have done, because you might have not the same result.
And back to the topic, we didn't actually skip any SRE. Instead, we used platform engineering and get a better SRE.
Hi everyone, I'm Brian Finster, the Value Stream Architect for Defense Unicorns. If you want to know how to do continuous delivery on a submarine, you should probably talk to us. I'm also a maintainer of minimumcd.org, where we try to demystify continuous delivery. And today I'd like to talk to you about how platforms, when done correctly, can be major enablers of organizational improvement. So first, what's the point of platform engineering? It's to help others deliver better. And if we lose sight of that, if we focus only on, hey, we're building cool tools, it's going to result in very poor outcomes. So there's some common struggles that I've seen around platform engineering. First is hey, here's tools we've decided you're going to use, go use them. Well, that'll definitely generate angry conversations, but it's not going to improve delivery at all. Or if we ignore operations at scale, if we build platforms in such a way where we don't focus first on how do we make them self-service, how do we make them easy to use, how do we improve the developer experience, provide good training, good documentation. If we don't do these things, if we have platform as a service ticket where we have to have heavy touch white glove interactions, we can scale ourselves out of existence. And the last one is one I hear very frequently is just lack of adoption. We built these cool things, but no one seems to want to use them. How do we get people to use them? Well, you need a strategy for that before you begin. And we're going to talk a little bit about that. So I want to present you with a case study of, real thing that I actually went through, which was how do we develop a global platform for a Fortune 1 company. So here was our state in 2016. More than 18,000 developers across the globe. We had all the languages and frameworks, just all of them. We had dozens of legacy delivery methods, anything from open source tools like Jenkins to homegrown solutions that have been around for a couple of decades, commercial products, and even just we're going to build it locally in FTP to prod. And we had very commonly across the organization releases every quarter with a lot of drama in every single one, late nights, scheduled war rooms 24/7. It was lots of fun. But we also had some promising pockets around continuous delivery in the previous couple of years where we managed to show that we could deliver high quality at very small change all the time, multiple times a day, and not only improve business outcomes, but also improve team morale. And so we had a CTO who came on board who said, you know what we're going to do is we're going to use continuous delivery as the method for improving everything about the organization. Because one of the things we learned on these CD pilots was it wasn't automation. Yes, you had automation, but you had to improve everything in the entire value stream to really deliver that consistent, sustainable pace of very small changes multiple times a day. And so that was the goal, is use CD as the lever. Because solving that problem, that very big challenge of I need every team to go to production daily, means that they have to solve all the other little problems throughout, and some of the big problems throughout their entire flow. They had to be better at engineering, learn how to do evolutionary development. They also had to do better at product. And that was ultimately the goal, and we saw a lot of success with that. But to get there, first we needed to come up with a global platform that would support that and encourage those behaviors. So that's what we decided to build. Now, first, this federated model we had, people had entrenched usages out there, and if you want people to adopt, it has to be easier and better than what they have. It needed to be self-service because, again, we needed to make sure that we had sustainable operations. We needed good training and support because we're bringing them new tools. We can't just say, here's the tools, good luck. They wouldn't adopt. And we also needed the platform to be opinionated around those enterprise goals to make sure that we made continuous delivery the easiest possible way to deliver. And that we didn't eliminate everybody else and say, well, if you're not doing CD, you can't deliver. But if you had a complicated branching structure you're using, it was going to be a lot of toil to use the platform. If you're using trunk-based development, it was not going to be any toil to use the platform. Same with, we have long release cycles and versioned release branches we have to maintain. That's a thing that you go through while you start working through the process of how do we do this a little bit better. But it's harder work to use the platform that way. It's much easier to use it in a way. It's like we're delivering very frequently straight from the head of trunk. And when I say was opinionated about CD, we also presented people with dashboards to show how they were doing. Now, these dashboards had two purposes. I mean, number one, the most important one, honestly, is that this pipeline is green, that a team can see that each one of their pipelines is green and that they're deployable. But also, we added gamification to the dashboards to show people how they were doing against the goals of continuous delivery. You get high star ratings for things like we have branches that last less than 24 hours. We have everyone on the team is integrating code very frequently. We have code that has tests, has low tech debt. The build is stable and fast. We're deploying very frequently. And then we'd show them, it's like, okay, this is what good looks like. And you are here to encourage people to progress more and more frequently to good. And that was also very successful, and it led us to developing other methods of training people on not just here's how to use the tools, but here's how to use the tools effectively. But none of that would have mattered if we built it and nobody used it. So we started from day one with what is our adoption strategy going to be? Because without an adoption strategy, if you build the platform and say, now how do we get them to adopt it? We're building the wrong thing for the wrong reasons, probably building capabilities they don't need and not covering capabilities that they do. And so having that adoption strategy was core to the product development strategy of the platform. So what was that strategy? Well, one portion of that was, you know what? You have these Jenkins instances out there that you're operating in your area, VP. So what if we took over those Jenkins instances and we have the expertise in our area to operate those? We'll operate those for you, along with the operational cost. You don't have to have people doing that. You don't have to pay for that effort. You can redirect those people to working on things that actually are part of your area's value delivery. And then work with those teams. Hey, what are you doing with these tools you're using now to deliver that our tools can't? And there's some cases where they were doing things, we had to add features. Other times it was just 6 one, half dozen the other. So then we help migrate them over to our platform because ours is honestly easier to use. And then, try to shut down that legacy method that they had. Now, in some cases you'd have those people at the end who are like, no, I'm too busy. I just like the way we have it. I just don't want to change. Well, and that's the thing. And you shouldn't have to change. And so what we'll do is we'll just return operational costs back to your VP, and your VP can make the decisions of how he wants to fund that, because we just really can't afford to operate this thing and provide all the support for 1 or 2 teams or 3 or 4. You guys go figure that out. And what you would frequently see is the VP would suddenly figure out that there was time to help those people migrate, that, hey, you guys should go ahead and migrate to the platform. That was very successful. But we also encouraged adoption, right? We had excellent documentation and training, and the training was always current with the latest feature releases because we just kept re-recording the training. And our documentation was current because our documentation was how we did level 0 support. If you needed help on something, you asked a question on one of our support channels, we'd direct you to where that answer was in the documentation. It also incentivized the security and compliance were incentives for using our platform because, hey, you know what? Keep using your old platform. That's fine. But our platform is up to par with security and compliance because we work closely with them to make sure that we are. And you can use your platform that you have, your old platform, but you need to be on parity with us. Or you can use ours and it's just easier and you get it for free. And then again, those people asking questions, how do I improve our scores with the metrics? Well, we started the DevOps Dojo and to show them this is how you do continuous delivery in your context with your application. And that also helped encourage adoption and also engagement with the community. Partnering with early adopters. There was people who were interested in the platform and wanted to really accelerate continuous delivery in their areas. And they worked with us for those first sets of features. And they became some of our strongest advocates, the people you could count on to go out and talk about how great our platform was. They'd have our stickers on their laptops. And we did road shows and DevOps events, bringing people together to talk about what we're trying to do as an organization. And not only building awareness around the platform, but also excitement around, hey, we are moving towards continuous delivery, and here's some good ways to get it done. And then working with the community. There was already a community of practice around CD based off of those pilots that have been started and the excitement around those. And we worked with that community with materially. We didn't just say, hey, good job, community. We gave them money for swag to help spread their message. And so then we developed a symbiotic relationship with them where they would help us with, honestly, even some of the support. You would see community members chiming in with answers on our support channels, even before some of our team members could. So where were we 3 years later? Well, we had more than 85% of the organization on our platform. And we could tell because we had metrics to show how much of the organization was using it compared to how much of the organization existed. And in our community channels, and not ours, but the continuous delivery community, there was more than 2,000 developers engaged in those communities. You'd have special interest groups around subsets of continuous delivery, but also just continuous delivery as a whole. And it was an exciting conversation. It was going on. We had demand for the dojo, looking for either quick little help. Hey, how do I test this thing better? Or how do I break this work down and deliver it in evolutionary changes better? All the way up to, hey, can you guys come and do a 6-week engagement with us to bootstrap us into continuous delivery? And the conversation was normalized. CD was no longer some sort of unicorn thing that only edge cases were trying to use. It was like, hey, we're all moving this way. And then leadership changed. And I cannot stress how important it was for this effort that the platform alone wasn't going to do the trick. It was the incentive, that challenge from up top, that our priority is how do we get everyone delivering to production every single day? And when we lost the leadership that was pushing that, and the message got diluted, and then you'd have people who had the ability to slide backwards, who just didn't feel comfortable with what we were doing, pushing to slide backwards. And it made things stagnate. You'd have to have that push from the top. So what were some lessons that we learned from this? Well, number one, branding was very important, and we took branding seriously. Our platform had a brand. Every single product within the platform had a brand. We pushed those brands. We talked about the brands. We had stickers. We had T-shirts. The teams formed around those brands. It became each one of the product teams in the platform. It became the banner they rallied around. And people recognized us for who we were. Documentation and training absolutely lowered operational overhead and became the primary method we used for customer support. Using CD to deliver CD, which is what we did, we also used our platform to deliver our platform. It allows us to dog food and build empathy with our users to experience whatever pain they're experiencing. Also gives us credibility that when we talk about continuous delivery, we know what we're doing. Here's how we do it ourselves. And the gamified metrics can be very effective. And I talk about this all the time. I would have done it slightly differently than knowing what I know now. But it has to be accompanied with leadership training. If leadership doesn't understand the metrics, they will be misused and cause all sorts of unfortunate outcomes. So have a deliberate improvement strategy. Make sure that there's challenging problems people are trying to solve, that the platform is helping to enable those solutions. Make sure that you don't just supply tools and a challenge. Make sure you have to have good methods for getting that done. So have recommended resources and workshops and work with the teams, and you can elevate the entire organization. But you must ensure there's active executive participation. It's not enough for someone in senior leadership to say, we need to make this change, and then step away and wait for it to happen. They have to be actively incentivizing it and be cheerleaders for it, or it will go nowhere. With that, here's a couple of links I captured for you. These are both articles I've written for IT Revolution. One is talking about, it's a deeper experience report of lessons learned from this experience. It's pretty long, but it talks about everything, including platform engineering, that I feel you really need to have in place working together to achieve that holistic change. And then based off the experience with metrics, how to misuse and abuse DORA metrics. We're seeing this all over the industry where DORA metrics are being used in ways that they're not supposed to have been used for ever. And this suggests ways they should be used and other metrics that you should really also be paying attention to, if not more. And with that, again, I'm Brian Finster. You can read some of my writings on rant.brianfinster.com. You can reach me on LinkedIn or email me at brian.finster@defenseunicorns.com. And let's just compare notes. And Defense Unicorns, again, it's an amazing company. We're trying to keep the nation safe. We make software delivery easy for the most secure systems in the world. And we really believe in the mission we're on. So I look forward to talking to you, and thanks very much.
Hey everybody, welcome to PlatformCon 2023. I'm Susie Julius, SVP of Product Engineering focused on platforms and content at Realtor.com. Today I'm going to talk about how Realtor.com went from a culture where you couldn't say the word platform to now a culture that encourages it. Our leadership team brought together a diverse set of backgrounds and experiences, pulled together a success story that excited the company, and is continuing to get smarter, faster, better to achieve our end state. While the journey wasn't a straightforward path, realizing it was not only a technical but a cultural mind shift, we're now well on our way of creating a real estate platform that is differentiating and allows us to quickly react to the market and our end users. Before I jump in, let me give you a bit of context on Realtor.com. Our purpose is we make buying, selling, renting, and living in homes easier and more rewarding for everyone. We're one of the most visited real estate sites in the US. And in the last quarter, an average of 86 million people visited Realtor.com per month. We monetize through media and connecting agents and brokers with consumers. And lastly, a little bit about myself. I joined Realtor.com in 2021, and my platform organization is roughly 150 people, both product leaders and engineers. And I'm also a mama of four, the most recent one joining us last month. So if I look a bit tired, that's likely why. So now that I've set a little bit of context, let me tell you about the challenge in overcoming at Realtor.com. You all may relate. Despite the success of Realtor.com over the years, we've scaled via acquisitions such as ListHub, OpCity, UpNest, and our tech stack became extremely complex, slowing down our ability to build features in a fast and reliable way. Despite knowing all that, there were some barriers to entry. There was some reluctance to a platform, a misunderstanding on what that actually meant, that it would slow us down, that it would create more complexity. So in the next couple of slides, I'll highlight each part of our journey, then spend some time at the end talking about what we call a playbook, artifacts we continuously use to build our platform culture. One of which I'd like to highlight is what I call identity, which I don't think a lot of people spend enough time talking about. It leans in on the importance of vision and purpose, understanding what your success story looks like and working backwards to identify key aspects of that story. So realizing the need and barriers to entry. In 2020, the entire company started going through a transformation. In tech, the strategy was simplify to scale. And with that, we had a divergent and often duplicated tech ecosystem where a platform could really benefit us. The existing tech stack made it difficult to ensure a quality product or ensure reliable feature releases. It was then we set out to not only tackle that, but strive to unlock leverage and innovation. And of course, with any change, there were barriers to entry. There was reluctance and a misunderstanding, but I can't emphasize mindset enough because it was the key to our success, to enable, to provide a service to others, to help everyone around us go faster and more reliably, to understand as a team what our vision and our team principles are and get buy-in from the company, to show those short-term and long-term wins, to measure, iterate, and evangelize our vision to be a platform powering all products, unlocking business opportunities. We started with two key platforms, the developer experience, which is the main focus of today's talk, but also the data platform, given we didn't have a clear line of sight to understand business metrics or give analytics the ability to create a canonical source of truth data set for our consumer and customers. So where are we today? We are enabling the company to deliver on features that drive our purpose. And our vision is to be the trusted and preferred product technology platform on which to build, continuing to tell that story, connecting the wins with features driving business metrics, be it revenue or user engagement, using the playbook, which I'll touch upon in the next section, to improve, align on key decisions, and continuously stay focused on our vision. We keep our vision top of mind, constantly using it and our team principles to create that long-lived platform culture. We use this to make decisions and to build trust not just with each other, but with our stakeholders. We have things like team mindset, mastering that no-look pass, smarter, faster, better, having that really high say-do ratio that our stakeholders can depend on, and truth and positivity, understanding that a lot of times failure is the path to success. So speaking of truth and positivity, turning conflict into opportunity, viewing failure as the path to success, we have a lot of lessons learned. And we've used these lessons learned to define our path forward and where we're headed. We realize that it's not just technical, but a cultural shift. We realized we lacked onboarding and documentation or awareness and adoption. We didn't have that feedback loop to understand how hard it was, or that stakeholder sentiment, how you know what's working and what's not. We over-indexed on microservices. We had things like rate limiting in different locations, making it hard to wrangle and harder to build client features. We had too many programming languages. It was hard to build platform features like logging and monitoring. And we realized we needed that continuous investment, prioritizing when the business is up and also when the business is down. And so where we're headed is really to treat our platforms as products, continuous feedback, stakeholder scorecards, understanding we need to continue to solve problems and make it easy, intuitive to use our platform. And we need to realize gains beyond tech, more involvement and input into what the platforms do and how they can help the entire company, pulling that thread all the way through to incorporate how platforms impact our end user strategy and experience. Evangelizing. We're all busy and we all get a lot of noise in our inbox and Slack. So we have to feel okay about saying things repeatedly and making sure our stakeholders know what problems we're solving for them. We're going to focus on onboarding, knowing we may need something more along the lines of product marketing, maybe a technology like Backstage to bring it all together. And lastly, go all in on the data graph, creating that visibility to simplify our microservices layer, allowing us to move more of our logic to the back end and create lean clients who only get answers from the graph, having that design first thinking. And obviously with all that comes the performance, security, and reliability gains. So now that you've heard about our journey, I want to leave you with a bit of what we've used and continue to use, our playbook and those components. First, we have our maturity model for our platforms. It's recognizing and reminding us that we don't want to stop at a platform that just works, but we want to be seen for the good and invested in. There are 3 clicks here: seen for the bad, not seen, and seen for the good. The way we talk about this and relate it to home buying is that a platform is really the foundation or the common components of a house. Typically, when you go look at a house, you don't really notice those things unless they're, broken, like a window doesn't work or the foundation is cracked. It's that rare occurrence. It's where we strive to mature as a platform. When you notice those things, you notice the doors, you notice the windows, and they're seen for the good. The second one here is our decision-making frameworks. To slow down, to speed up. It's really important to create that flywheel on how we make decisions collaboratively, cross-functionally, in a way that where we can keep coming back and pointing at that decision as we progress. There's 2 key frameworks we use here. First is the Strategic Technical Initiative Groups, what we call STIGs, for technical decisions to ensure collaboration across the business on our future tech stack and feature development. And we also use cross-functional workshops, really to collaborate and focus on both our product and tech strategy. Last up, we have what I call identity. I could have spent the entire talk talking about this identity and how important it is. This is all about having the end state in mind, combining the fundamentals with your vision. It's that compelling story of success. In order for us to tell that story, we had to figure out what elements are needed to allow for that to happen. We had to have principles and self-awareness, knowing our values, like the importance of failure, while also awareness of our blind spots, having extreme ownership, knowing our intent to give context, not controls. We had to think about our reputation and brand, not just execution and our mode of delivery, but owning the problems and embracing failure. Putting ourselves in our stakeholders' shoes to understand the areas of improvement, be it the technology choice or onboarding process. To treat our platforms like products and our internal customers with the same level of care as our external users of our products. Thinking about execution and barriers, being one step ahead spending time thinking about those elephants and those barriers that would prevent us from succeeding. What was going to be that conflict? And then bringing it all together, the characters, the values, the conflict, to create this success story and to fully understand how we win. That's the end of my talk. Thank you for taking the time to listen in.
Hey everybody, welcome to PlatformCon 2023 and to my talk, How to Build Golden Paths for Day 50 and not Day 1. I'm Kasper from Humanitech and very excited to speak to you today. Let's look at the agenda very quickly. First, I want to highlight what's wrong with focusing on Day 1. Could every day be Day 1? And then we're going to revisit some paths. Before we do that, what is a golden path? Well, a golden path is any procedure in the software development lifecycle that a user can follow with minimal cognitive load that drives standardization. If you ask 9 out of 10 platform engineers today, and you ask them what is a golden path you could think of, they will probably say the scaffolding workflow that a user would utilize to create a new service or resource. And if you ask them to describe this, they would say you go into a portal or the templating function of a version control system, you hit use this service, it then calls the GitHub templating API, clones the template, executes it, and you have your new service running. This is the focus on Day 1. That is what I mean by most golden paths are focused on Day 1. If you look at the entire software development lifecycle, then these approaches focus on the standardization, on the create phase of both a workload and resource. The problem is pretty obvious, actually. Think about the lifecycle of a workload, the lifecycle of a resource. How long is that thing around? And often for a very, very long time. Years, decades. Remember, the stuff that we're building today is the new legacy. And if we're looking at the entire lifetime of such a component, how helpful is it if we only focusing on standardizing the Day 1? The actual return on investment for golden paths for platforming is not in Day 1. It's in Day 100, in Day 1000. And that doesn't mean that you shouldn't standardize Day 1 as well. But we need to change the way we think about golden paths from that first starting point and that Day 1 focus. And we have to get to a Day 1000 focus. Every day should be Day 1. That's the key mindset change that we need. Golden paths have to be designed alongside the entire lifecycle of an application, alongside the entire software development lifecycle. And there is only one way of doing this. And that way is by creating app and infrastructure configurations with every single release. We need to treat every day like it's the first day. We need to create and we need to treat every deployment as if we're deploying for the first time. Only if we are doing this are we actually able to continuously standardize, to continuously yield the benefits of standardization and low cognitive load that we are looking for in platform engineering. How do you do that? For those of you that have heard other talks of me, you know that I'm a big fan of dynamic configuration management, the idea of dynamically generating app and infrastructure configurations with every single release. And before we actually look at a couple of golden paths and examples, I want to explain that idea, that architectural approach in a little more detail. Dynamically creating configurations is possible if you have an abstract description of the architecture and the dependencies of your workload. So everything starts with that specification, that abstract specification. We call that a workload specification. The developer describes in an environment agnostic way how their workload depends on other workloads and dependent resources. A workload specification can have many forms. Most used are code-based workload specifications. There are several open source projects that cover this. And a workload specification, there's exactly one for every workload. It sits next to the source code of the service in the version control system. And a workload specification could, for instance, say, hey, I'm the workload specification of a workload of name Python service. And this Python service has a dependency on a database of type Postgres, DNS of type S3, and on a file storage of type S3 and DNS of type DNS. So one file, and it's agnostic, it's environment agnostic. It works across all the possible implementations, all possible environments. Now, the developer experience in this world means I want to run this locally. I do score compose, for instance, and it will convert this into a local config format. And now I actually want to deploy this into a, let's say, staging environment. I push that through my normal CI process. It hits the CI component. It hits something like a platform orchestrator. And that orchestrator is responsible for actually now dynamically creating the app and infrastructure configurations. It's reading what the developer wants. It's looking at the context. Oh, this is an environment of type staging. It's matching this with the baseline configurations provided by the platform team. And then it creates the app and infrastructure configurations. And once this is done, we have those files. Well, then stuff gets orchestrated and maybe handed over to dedicated CD systems. That's pretty much it. With this approach, you can now design the most beautiful, scalable golden paths alongside the entire software development lifecycle. Let me give you an example. A simple deployment to development. You're a developer, you're doing this several times every day. Nothing about this is really special, and you can do that with every GitHub Actions today. But what's different is that with this approach, every single Git push is a chance to standardize. The workflow doesn't change. We have our source code. The changes get propagated through the CI pipeline. The workload specification is always part of this package. Hits the orchestrator gets the context. The orchestrator executes a read, match, create, deploy pattern and says, okay, well, let me actually treat this as if it would be day zero, create everything, and make sure that the infrastructure is in the right state and the application configs are created. So why would you care if you can already do that with any CI flow? Well, because assume something changes at scale. You want to have different labels and annotations. You want to upgrade something. You want to change your security posture. Because we are actually working against baseline templates, we're basically scaffolding every single release cycle. You can just apply those changes to the baseline configurations and they will propagate throughout your workloads, all of your workloads and across the organization with the next deployment. Let's take another example. Let's say we want to have another environment. And now, because we are creating things dynamically, no change in the workflow for the developer. We are taking the workload specification again, we're sending that through the CI pipeline. Now, the only thing that changes is the context. It hits the orchestrator component. We see read, match, create, deploy, and you have your new stuff running. Again, possible because of dynamic configuration management. Let's look at an example for the platform engineering team from the platform engineering perspective. And let's say we want to update Postgres from version 14 to version 15. Yes, there is a golden path for that, absolutely. Now, in this world, because we have single source of truth and that continuous generation, we can posed the simple question, what services depend on what resource definition? In this world, there aren't 80 different versions of Postgres. There may be 3 or 4, and they get reused with every single deployment. So we're asking that question. We get the answer from the orchestrator API, for instance. Here are the dependent resource definitions on services that utilize a specific resource definition. The only thing we do is we update that resource definition. We update our baseline configurations. Send that against the orchestrator, read, match, create, deploy. We auto-enforce the deployments across all workloads, and the new version of the Postgres is updated. It's really as simple. Now, let's look at one more example. What does it mean to go off the golden path? And let's assume we want to add an ArangoDB as a developer. The beauty of this approach is that this is totally possible. So it's using a design principle I call golden path over cages. Developers should be able to use the golden path, but there should be a clear way how to leave that path. Let's say the developer needs ArangoDB, but there is no global rule on how ArangoDB is actually created. That's not a problem. We're just adding a new resource definition. Post that to the orchestrator. The orchestrator now knows how to create ArangoDB. Read, match, create, deploy, and ArangoDB is there. That resource definition, that baseline configuration could be a simple Terraform file plus the information when to use this Terraform file. It could be a cross-plane file, it could be Pulumi, it could be whatever. We just need to follow that logic of dynamic configuration management. And that brings us to an incredibly interesting point. Platform engineering, if we do it well, the design of golden paths is actually about structuring repositories more than anything else. There are developer-owned repositories, the workload, with the workload specification, the source code, and all of those things. And then there are platform engineering-owned repositories. Resource definition, baseline configurations, infrastructure as code, workload profiles, automation, compliance, all of those things. Now, if we think about it this way, if a developer leaves the golden path and creates their own path, they can now actually take that path on a code-based format and send that to the platform engineering team and say, hey, I've left the path, but I think this should be a golden path. This should be a global path. And all the platform engineering team has to do is to accept that path globally and start supporting it. And this way, we actually develop the platform almost decentrally. We are developing the golden paths based on the user need. And we stop guessing what the user might need, what the platform might look like. We are getting from a prescriptive mindset to a product mindset. And this is really what platform engineering is about. Now, golden paths are good for everybody because they make things so much easier. In this world, adding an S3 bucket is exactly 2 lines of code, nobody else involved. Spinning up environment, 1 git push. We had that example updating a Postgres from version 14 to 15, 1 file. Understanding the immutable difference between states, between deployments, because we're regenerating everything, that's a single command to run a diff. What's running where? 1 API call. That is the power of dynamic configuration management. That is the power of designing golden paths in a decentralized way along the entire software development lifecycle. I hope this was helpful. Enjoy PlatformCon 2023 and see you very soon in the community and some of the next events.
Hi everybody, my name is Rohan Kapoor and I'm the product manager of Ethos Flex, which is Adobe's new CI/CD orchestration platform. In this talk, I'll give you an overview of Adobe's internal developer platform, IDP, and share some learnings from Ethos Flex, which was launched last year and is a key component of our IDP. So our IDP's motto is to help developers write better software faster. And these developers write code on behalf of 3 primary clouds of Adobe, which are Document, Creative, and Experience Cloud. These consist of various products like Acrobat, Photoshop, and Adobe Experience Platform, to name a few. These products are using several platforms like data, content, and sensor machine learning. Both product and platform services run on top of the Adobe IDP. Finally, the IDP runs on top of AWS, Azure, and our own data centers. So back in 2012, Adobe had already moved to a subscription model, which was a game changer. From 2015 to 2017, Adobe made the decision to move to a cloud-native containerized model, and the Ethos team was created, which I'm part of. Ethos started its journey by moving initially to Apache Mesos. In 2018, we built abstraction to move clients over to Mesos and created the Platform Champions program, where we did enablement training and brought in more than 1,000 services in a calendar year. From 2019 to 2020, Kubernetes had matured, and we decided to essentially migrate to it and created two offerings, namely CAS, which is abstracted pave path CI/CD, and PaaS, which is DIY, do it yourself. The good news was that our abstraction on the DCOS or Mesos platform came handy, and we were able to migrate over these services to Kubernetes. Come 2021, we started building Ethos Flex, which brings the best of both worlds. And in 2022, we launched Flex. We also did an internal and external IDP workshop to share our perspective on the IDP and collect common developer pain points. Finally, in 2023, our focus is to support more than 5,000 developers deploying code across more than 250 Kubernetes clusters. We also made the decision to choose Backstage as our internal developer portal. So in the middle is our internal developer. And as you can see, our internal developer constantly navigates a magnitude of different technologies, tools, as well as the endearing CNCF landscape, which essentially leads to high cognitive load. The point I'm trying to make is that these capabilities exist across the board at Adobe, but some of these are disparate and disjointed. When I first joined this team, we started off by benchmarking the time it takes developers to get from zero to production readiness. Based on the results, we found that it takes developers more than a month to do so, and 70% of the time is consumed when developers integrate with external tools and have to wait to get access to them, which is the wait time. So based on this, we prioritize the pain points, and we are already in the process of automating onboarding, and we have already worked on reducing wait times. We are slowly but surely, seeing the benefits of that. There's obviously a lot more work to be done. Okay, so these are all the capabilities which we've identified as the key components of an IDP. I want to mention that we are still early in our journey to integrate these, to reduce silos across Adobe and bridge gaps. But our goal is to make incremental progress on each of these and partner with different teams. So looking at the three developer lifecycle phases, which are highlighted in yellow, green, and blue, the first one is discover and create, which provides capabilities that address the initial part of the development lifecycle, which includes onboarding, documentation, training, local development, etc. The integration and deploy capabilities cover deployment, configuration of resources, integration of various systems, to name a few. I will be covering delivery and deployment and workflow orchestration, which are highlighted. Finally, we have the operate and improve phase that includes cluster management, observability, monitoring, and cost efficiency, to name a few. At the bottom, you can find a GitHub link showing a detailed view of the IDP, and we'd like your contribution and comments on it. So our incumbent CI/CD solution is being leveraged by more than 3,000 services today. However, it has some limitations which did make it conducive for a larger number of clients who still use our DIY model. And some of those limitations are lack of customization of the deployment pipeline, waiting in the queue, not being able to contribute code easily, which made us the bottleneck to unblock our clients. The new deployment model of Flex, on the other hand, makes it very easy for clients to customize the deployment pipeline as it leverages the open source Argo project. and facilitates open contributions. In addition, we support deployment models like Canary with analysis, which isn't possible, with our CI/CD tool, the incumbent tool, and there is no need to wait in the queue as Flex is primarily GitOps based. So this is a slide shared by one of our clients using Flex, where you can see that in the old CI/CD tool, they had a total deployment time of 45 minutes, which was primarily due to babysitting deployments in the queue, waiting for the pipeline to complete for each of the environment. With the new model, you can see that time has been reduced to only 5 minutes, primarily due to the GitOps nature, GitOps deployment model of Argo and Flex, which facilitate a parallel deployment across environments. Let's take a look at those learnings, and starting with the first learning, which is treating internal developers like external customers. So I come from a technical consulting background where everything we did was tailored for clients. I strongly believe we need to have the same mentality towards internal developers as they too are our clients. So this essentially involves focusing on building relevant abstraction to reduce complexity, improve developer experience. Learning also plays a big role, and at Adobe we have a platform champions program where we encourage participation by publicly recognizing platform champions who have completed certifications with the community and the leadership. Next, I want to share some learnings from our internal go-to-market launch of Ethos Flex. First is creating a GTM checklist to cover the most important aspects. In addition, doing a pre-mortem, which includes meeting with your platform team 3 to 6 months before launch and listening to their concerns in a candid manner. I've actually shared a pre-mortem template, which I built in Miro, and shared a link to the parent template from where I got this idea. The other thing we did was a product lighthouse where we worked with early adopters of our product and prioritized key features for them. This was very helpful in shaping the product that we have today. Finally, this may be preaching to the choir, but it's paramount to constantly engage and listen to your developers. This could happen with surveys or in real time. In case of surveys, consider sharing the results openly with everybody and proactively act on the feedback. Tracking the success of your IDP is critical, but it's also important to set realistic goals and follow through on those. Now, one way you can do that is by leveraging OKRs, which are objectives and key results. I've given an example of what an OKR focused on stability might look like. I've also included some initiatives on how to accomplish some of those goals. In addition, there are other ways to measure performance of your platform. From my experience, I could share things like tracking how long something takes, measuring adoption rate, churn rate, collecting developer feedback either quarterly or twice a year. At Adobe, we track NPS holistically and CSAT at a feature level. Now, as you go through your IDP journey, you have to adapt and pivot depending on the situation, and there will be turbulent times. Some hard decisions will have to be made, like pausing new feature development work or reducing outreach in favor of stability. Another one could be ending trainings that consume time in favor of a more self-serve model. So in general, it's always a good idea to retire unused feature with low adoption. You may also need to make strategic trade-offs to make key decisions. An example is, you may need to compromise on reducing complexity to meet certain security mandates. But it's important to be vocal about resultant challenges with leadership and keep finding opportunities to automate. Finally, change may not be such a bad thing, which could happen either at a team level with some platform developers joining other squads, or via organization level changes where two previously siloed orgs could join hands to streamline processes. So first up, the image that you see was generated in a tool called Adobe Firefly, which is a generative AI tool. It leverages Ethos Flex as its CI/CD engine. The analogy I'm really trying to draw is that the amount, the armored figure that you see is actually a developer who is trying to grab a hypercube, which is the IDP. I'm honestly not sure how accurate this is, but we'll see. Now, let's assume that you have built an IDP. Then what? So, in my experience, you have to constantly prove the value of an IDP to leadership to justify, ongoing investments, and to developers as adoption is not guaranteed. So, my recommendation is for you to treat your IDP like a product. What that means is that there needs to be an active roadmap with prioritization, the prioritization happening at the feature level with proper themes allocated. If you already have a roadmap, openly share it with your developers, and also consider hiring a product manager. And I'm not being biased here. Like any product, there is a constant need to lower adoption barriers, and doing kind of regular outreach via blog posts, lunch and learns, and presentations is obviously a good idea. There is also, status quo bias for existing technology. So in some cases, disruption may be needed to change the mindset of users. We actually did that with Ethos Flex in our case. Next, I can share an example from Flex where we have formalized an open contribution inner source model to tap into Adobe's developer muscle. We leverage GitHub projects, which is based on Kanban, and we have a dedicated cohort which reviews all incoming PRs and basically provides guidance on various testing strategies. So far, we've already merged more than 10 open contributions from clients in a very short amount of time. So we essentially help clients get unblocked quickly, and we also are solving problems at scale. Finally, I'll cover some product best practices. So it's important to strategically build features, for your platform and prioritize, features that boost mass adoption. Another approach which could help is to forge a symbiotic partnership with other product teams. In our example, we are only supporting our new API gateway platform with Flex and not with the incumbent CI/CD tool. Finally, for any old platform and essentially moving users from the old platform to new, it's very important to proactively announce, communicate end of life dates, and build any migration or conversion tooling to bring users over. So what's next? So I've included a comment from one of our clients who shared that customization is possible with Flex, but it is hard to use. So we are prioritizing the simplification of the platform by abstracting onboarding and the post-onboarding experience to reduce the need for developers to edit complicated YAML files. We are also focused on replacing verbose documentation with a more simplified set of technical docs. Now that we are in production, we are quickly learning that it is very different than being just production ready. Our current focus is on hardening stability, performance, and preparing for 10x scale. We are also working constantly to improve our the actionable error messages, which trigger a notification in Slack to communicate the error message and link to the troubleshooting guide to help developers get to the root cause faster. We are also working to, future-proof our existing Flex architecture using Argo to prepare for scale. Finally, we are integrating Flex in our developer portal on Backstage to reduce context switch by consolidating all CI/CD insights in one place, but also providing developers access to raw diagnostic tools if necessary. So that's a wrap. So you can connect with me either on LinkedIn, Twitter, or my personal blog. Thank you. And I'll also be available to answer any questions on Slack.
Hello, and welcome to this session about the journey to the internal developer platform in Yux Net-a-Porter. Yux Net-a-Porter, abbreviated YNAB, is the leader for luxury and fashion e-commerce. YNAB is made up of 4 different multi-brand websites: Net-a-Porter, Mr. Porter, The Outnet, and Yux, but we also offer our platform and our technology to other brands that want to leverage it. And we call this business department online flagship store. Currently, we are serving our products to more than 180 countries around the globe, and we have 5.3 million high-spending customers active every year. Those customers are generating more than 1.2 billion visits, and we receive most part of the orders through mobile platforms. We have 10 local offices spread around the globe, and we manage 9 distribution centers. In those 9 distribution centers, we host 7 digital production centers where we create content and media for the product we sell. My name is Leonardo Romanato, and I'm the Global Head of DevOps Platform and Services at YOOX Net-a-Porter. If you have any question or doubts about the presentation, or if you want to share your feedback or share your experience about platform engineering, or talk about anything represented in the images below in this slide, you can find my contact here. DevOps platform in YNAB is the area that is providing capabilities to whoever is dealing with code and need to build, deploy, run, and maintain an application, a service, a script, an API. DevOps in front of platform is to distinguish this area from other YNAB platforms, such, for example, data platform. We are serving around 600 developers in an hybrid scenario, so both on-prem and cloud, where we use AWS as a cloud provider. We are currently supporting multiple languages, and you can find here the most common one, as well as multiple runtimes, from bare metal machines to virtual machines, both on-prem and cloud, as well as containers, both within and without Kubernetes, and serverless. Not just Lambda, but serverless services in general. Also, considering the company is almost 23 years old, we have the full range of different architecture, from monolithic software to microservices. The DevOps platform area is composed by different domain teams. Some of those domain teams have a pretty long historical background within YNAB. Possibly the most historical one is continuous integration, which has been formed around 2010, and later started to take care also about continuous deployment capabilities. Then we have application delivery, which is a team which is taking care of the content delivery network, as well as the public DNS and the public certificates. Finally, we have monitoring team, which is the first incarnation of the team that is now called observability. Those teams have been created back in time with a central management organizational model in mind. So those teams were building, maintaining, but also operating the capabilities that they were providing. So not having at all any self-service capabilities provided to other teams. In 2010, a big project has been launched focusing on a big migration to cloud. For this reason, few organizational changes happened, and CI/CD, application delivery, and monitoring teams have been brought together to form the DevOps platform department. At the same time, in order to leverage all the cloud capabilities, there has been the creation of a central DevOps team, which was operating on top of the capabilities offered by the DevOps platform. Also, in order to help DevOps platform teams to scale their capabilities and to provide those with a self-service approach, a new team called automation has been created. At the beginning, everything was running smoothly. but soon some issues started to arise. Development teams were exposed more and more to the cloud, and they were acquiring new skill and so generating new requests on their own on DevOps platform, bypassing the DevOps team, which started to become a bottleneck. DevOps platform and DevOps team were not able to cope anymore with all the requests coming from the development team, also because of the centralized automation model that was put in place. In fact, the automation team, which has the role to create and enable self-service capabilities for other DevOps platform teams, started to become a bottleneck itself. Due to the scenario just described, DevOps platform teams started to develop their own automation, but in a siloed way, without a common approach. At the same time, the central DevOps teams, in order to cope with the requests, started to build automation and product capabilities on their own, sometimes on top of the platform capabilities, but sometimes also leveraging new technologies outside of the platform. Development teams as well started to build capabilities on their own, mostly on top of platform capabilities, to cope with the increased business demand. The result was a chaotic situation, with a lot of capabilities replicating each other, maintained by different teams. At the same time, also, it was very hard to understand which was the standardized solution and understanding also if any guideline was in place in terms of software development lifecycle. In order to bring back order and governance, but also improve YNAB technology department efficiency, a reorganization happened late 2021, beginning of 2022. A new structure for the DevOps platform area, defining clear mission and reviewing teams and their operating model. DevOps roles working on product capabilities have been moved to the DevOps platform area, and a rationalization have been provided for product capabilities after a first assessment. At the same time, DevOps central team have been dismantled and DevOps embedded into development teams. Meanwhile, an SRE team has been created. A strong focus has been placed in defining the DevOps platform mission in order to clearly communicate the goal of the area to the whole technology department as well as to the internal DevOps platform teams. Finding the balance between meeting the needs across delivery teams and minimizing the complexity and the cost of a central tool chain. Relying on a collaborative approach where new capabilities are co-created with delivery teams, trying to have a quick feedback loop. Continually assess the platform to make sure that we retire redundant or end-of-life tools, we strive for rationalization, and we always match delivery teams' needs, but also YNAB technology strategy. Implementing platform metrics such as Net Promoter Score, percentage of adoption, percentage decrease in feature cycle lifetime, this trying to apply the Google Earth framework. And then actively market the platform to drive the adoption. Do not rely on a mandated approach for the platform. Here you can find the organizational model for the platform. As you can see, the development teams are directly communicating with the platform, but we are providing them a single point of entry, and we are removing for them the need to have to know which is the organizational model for the platform itself. The platform is also communicating directly with the SRE team, which is the team which are having the comprehensive view of the YNAB technology platform. On the right, you can find also some other functional team which the platform is collaborating with: enterprise architecture, cloud governance, cybersecurity. The platform is focusing on embedding in the products and the capability that they provide all the guidelines that are provided by those teams. Here is the list of the challenges that we are still facing as a platform within YNAB. The first one is the communication, where we find pretty hard to maintain an aligned communication, making sure that everyone is aware of the capabilities that we make available or we are working in or developing. In order to manage this, we try to shift our communication approach to be more close to the point of view of our internal customer, mapping all our product capabilities to different phases of the software development lifecycle. So making it easier for a developer to try to spot what they could use or what the platform is offering and could benefit them. The second challenge we are facing is related to the product manager role. At the moment, we don't have a dedicated product manager for the platform, and the role is covered by the team manager or by myself. However, due to the extension of the customer community from the platform, a product manager role could be a full-time job. The skill set needed for this role is pretty tricky and is not easy to find in the market someone fitting it totally, considering the highly technical scenario that the product manager is facing. The next challenge is a standardized self-service portal. As I was mentioning, the platform grows in a siloed way, and different ways of approaching the capabilities have been provided to the development teams. However, we would like to consolidate those approaches and provide a uniform way to approach the capabilities for the platform. The next challenge is FinOps. We are already applying FinOps to some area of the platform, especially about the cloud and some of the most used product and capabilities that we provide. However, we would like to apply FinOps to everything we provide as a platform, but consolidating different kind of data and making sure that we fit together different commercial model, especially when we talk about tools that are provided by different vendors, is not that easy. The last challenge is related to not providing the full spectrum of capabilities. The DevOps platform is providing quite a lot of capabilities when it comes to developing an application. However, not all the capabilities needed for that application development are provided by the platform. An example is, for example, database, which are responsibility of another team, or integration tool like message queuing, which is responsibility of another team within YNAB. We would like to provide for development team a single point of entry in order to be able to access all the capabilities needed for developing an application. In order to try to solve the last three challenges, we are experimenting some of the tools which appear in the market in the last years, so-called PlatformOps tool. Those tools will be able to provide a single layer where development teams as well as SRE would be able to access as a single point of entry in order to access all the capabilities needed to develop and maintain their application. Those tools are offering also opinionated way to implement self-service portal, but as well they are providing capabilities for FinOps. The most famous tool in this category is probably Backstage from Spotify, but quite a lot of others are appearing in the market. Just to mention few names, Crateo, Mia Platform, or Cycloid. I hope you enjoyed this talk. If you want to share your feedback, if you are living a similar experience when it comes to platform engineering, or if you are living similar challenges that the one that I presented before, please be in touch, and I will be more than happy to have a conversation with you. Thanks again, and enjoy the rest of the conference.
Hello, Istio, simplified. How does that work? My name is Jon Skapteig. I am the tribe lead of the global platform tribe at Signicat, which is a high-growth software as a service company. We cater for regulated industries, which includes financial institution, health insurance, and government. I'm located in our headquarters in Trondheim, Norway. So how does Istio simplify things for Signicat? Well, it allows us to have team autonomy, to really double down on this platform engineering approach with an internal development platform. And it allows us to have security guardrails so that individual teams can deploy with confidence. It allows automation of manual processes for us to successfully scale. It has a consistent API for traffic, both from the outside in, but also in between services. And it enables a unified looking glass into how the traffic is running inside of the different products. And the uniform security is also key for us, especially when we're having audits, because then we can confidently say that this is secure, this is how it works, this is the one component that guarantees some of the crucial security features. But what is Istio? It is known by a few names. Service Mesh is the most common one, but it's also an API gateway. It also induces nightmares for those who operate it. It has a number of names internally: Pilot, Citadel, Galley. There's a lot of features. There's a lot of complexity, and to the point where it's named the worst value to complexity ratio ever. And it is fairly complex because it has a lot of features. But what does it actually do? Well, it configures reverse proxy, namely Envoy. And the reverse proxy, it's essentially a web server. So you have your requests, they go to the web server, which proxies them before they enter the actual product or the service. And what Istio do is to configure this reverse proxy. In software-defined networking, this is referred to as the data plane and the control plane, where Envoy is where the data flows through, and Istio, the control plane, is the configuration component. So why do we have a tool which all it does is configure web servers, more or less? Well, Signicat needs horizontal scaling. In order to do that efficiently, we need automation. For a static setup that has, configuration files and conf file on the file system, there's a number of other tools which help with that, like Puppet and Chef. In a dynamic fashion, you also have the basic ingress controller of Kubernetes. But once you start looking at the complexities of all the bits and pieces that fits together with networking, where you have a number of different domains that have their own specific certificates and different security options, and then you want to add some gRPC into the mix, this is where one abstraction becomes really useful. But if you have a very simple use case, you probably don't need the complexity that follows with a lot of features. So you're probably better off with a simpler solution. But Signicat, we do need these features because we have customers in regulated industries. And this wonderful picture that came from Edward Snowden, where the internal network is all unencrypted, and as soon as you are able to get in there, you can see all what's going on. This illusion of a secure network is no more. So we absolutely need to have security, encryption, also between services. We are also seeing a number of teams. We have an exponential increase in capacity requirements. So we absolutely need a dynamic scaling. And we have, through mergers and acquisitions, quite a fragmented tech stack. So we have Java, we have .NET, we have PHP. They all communicate through APIs with a microservice approach. And on top of this, we have white labeling. So we have a number of customer domains pointing to our servers, have their own security requirements, their own certificates. That all needs to seamlessly integrate into the platform. So how does Istio help us? It covers a lot of the functionality. I mean, SigniCat has been around for some time. It's not like these are new problems per se. And we have had other solutions in place, which is Apache and Squid and Agent Proxy, and then mitigating this internal network with huge ACLs to kind of determine what traffic can go where. Then a number of control plane components like Puppet and SaltStack. But at the end of the day, you kind of had manual provisioning of new nodes, new capacity, new certificates, and then you roll out this static configuration update. It wasn't really as flexible as we wished it was. But Istio also provides things that we didn't really do much from before, at least not uniformly. So you have these reliability properties that you now have in the proxy. Instead of having the Java library to do this, the PHP library to do this, you have one uniform way to do this across the platform. The observability is also uniform, so you can see all the requests, regardless of whether it's some Tomcat or if it's Nginx or what have you, that kind of spits out the logs. You have the Envoy layer, and then you can have topology maps across all of your microservices. And of course, the security, we can enforce encryption, meaning we can guarantee that it's also encrypted. All of this now happens in a consistent API, which means we can integrate with our way of working. So ultimately, it's about scaling digital delivery. This is the promise of platform engineering, that you can have a set of services, set of rules that can be used by service teams. They are self-sufficient in configuring routes and network policies and the different options for reaching the individual services. And Istio is the boundary between platform owners, which operate and install Istio itself, and service owners, which create ultimately the end customer value. And with the uniform API, it means that we can have an integration point with our self-service platform to set up custom domains, to have customers upload certificates signed by a specific CA. And it allows us to have centralized dashboards, which is universally useful. One example of this is the red metrics. And you can see these red metrics from all the services, and you just get it out of the box. It's available in the platform. So ultimately, complexity, it's the cost of scale. And Istio itself, it doesn't do anything but abstractions. It doesn't remove the underlying complexity. I mean, the space which Istio operates in, which is Kubernetes and web services, network and security, and even as part of the internal developer platform, they are complex systems. Modern software development is complex. So are we stuck operating this Istio complexity forever? Hope not. So The Kubernetes project has also recognized the need to provide vendor neutrality also on API gateways and adjacent technologies. And the gateway API is getting some traction, starting to make progress. There's still missing support for the service-to-service communications, but assuming this is successful and gets part of the official Kubernetes project, that opens the options for vendors. So the world-bearing turtles, that is the different cloud platforms, could offer this as a managed service. Then it doesn't matter so much if it's Istio or if it's something else that actually implement this, as long as the API is readily available. You just use it and you expect it to work, and you can offload the problems of operating it to vendors instead. So that is what I had. Thank you for watching. Feel free to reach out if you have any questions.
Hi, everyone. Welcome to our talk on standardization and security. My name is Vinnie Carpenter, and I am the Vice President of Engineering at Northwestern Mutual, where I lead the cloud and DevOps engineering teams. I'm honored to be joined by my colleague, Ravi Rajan, who is a Senior Director of Engineering, and he leads our DevOps engineering organization. Today, we're going to tell you a story of how we are on a journey of standardization and simplification, and how that journey has led to improvements in our overall security and development posture. Before we dive into the meat of the topic, I wanted to tell you a little bit about Northwestern Mutual. So we're a Fortune 90 financial services company that strives to be at the center of our customers' financial life and provides insurance, investment, planning, and advisory services to help our clients achieve financial security. We have 5 million customers and a revenue of around $34 billion. We're a privately held 165-year-old company with great financial strength. Today, we're going to start by discussing the seminal work of Barry Schwartz, who is a famous American psychologist and the author who describes the paradox of choice. Then we will dig into our experiences with unlimited choices and unlimited flexibility, and then pivot to talk about how standardization has helped simplify and secure our environment. Finally, we'll discuss the approach, our approaches, technology and cultural implications, and share some of the outcomes and lessons learned as we embark on this journey. With that, I'm going to turn it over to Ravi.
Thanks, Vinnie. I'd like to introduce this concept called paradox of choice. As Vinnie mentioned, a lot of these ideas have been borrowed from a book by Barry Schwartz. So the first and the most common example of the paradox of choice is found at a grocery store. Try walking into any aisle. You will see a number of varieties of cereal, olive oil, toothpaste, shampoos, etc. Right? Next example is TV. Number of TV channels you get from cable TV is 1761. And if you look at the number of streaming services available, Netflix has over 4,000 titles available. Prime Video has even more, millions of hours of content. And that's just scratching the surface. Many choices with the providers, way too many shows, movies. This is practically true for everything we see in real life. Choice is a luxury. More number of choices is considered a symbol of privilege. Too much choice is the current reality of our society. But hey, isn't that a good thing? Having a number of options will help us choose what's good for us, right? Not really. If you look at the graph here, you will see that having no choice results in very low satisfaction. Initially, as more choices are added, satisfaction increases. But as the number of choices keep increasing, people tend to feel more pressure, confusion, and potentially dissatisfaction with their choice, which can then lead to anxiety, indecision, analysis paralysis, and dissatisfaction, right? There are a lot of names to describe the same phenomena. Fear of missing out, you can call it as law of diminishing returns, and whatever you call it, it's just quite real. And there's a more scientific angle to this too. There is this research that's published by American Psychological Association. It says the more decisions an individual makes in a short period of time, the more each decision decreases in quality. It creates what is called a decision fatigue. Because we have a finite amount of mental energy to exert, the more energy you use for trivial decisions, everyday decisions, the less energy you have for critical ones. Steve Jobs used to wear the same kind of dress every day, black turtleneck and jeans, right? That's all you ever saw him in. President Obama always wears blue or gray suits. He talks about paring down trivial decisions. Now we'll talk about how this idea applies to us in the cloud world. This is a quick look at the tool landscape, right? This is just a small sampling of a plethora of tools available in the market. We have tried to organize it into logical categories. You can see there are categories that are high-level steps in a software development lifecycle. Each of these are stages. So you'll see how many options we have for tools that provide a similar capability. For example, you can see source code. We have GitLab, GitHub, Bitbucket, AWS Code Commit. All of these tools provide a way of version control. Similarly with coding, there are hundreds of programming languages. I've only listed a few there, and I'm not talking about all the options available in the market. I'm talking about how companies typically end up with multiple tools that they actually use for the same capability, right? So what happens if you have too much tool sprawl, right? First is high cost of maintenance. You're probably paying multiple licenses for the same capability. You're probably logged in with multiple vendors. Your automation that you create is reusable only in your technology island, not broadly, right? And so your technology islands create these islands of automation. Too many tools, hence the complexity is high, right? You're creating standards that apply to the whole enterprise is a challenge. Tool sprawl leads to data sprawl, which then means that capturing your data metrics, success metrics, is going to be a challenge. Security is a challenge because you have to constantly patch across all your tools. This adds to the cost as well. A lot of lost productivity. Team members can change from one team to another easily, and Vinny's going to talk about this idea a little bit later. So what do we do, right? What I have described so far is a buffet. When we say with a buffet, here's all the things you want to eat. Go make your own plate, right? When we do that, every plate is different from every other plate. Very few people think about nourishment and health when there's a buffet. I would load up on dessert, for example. And there's a lot of wastage too. With too many tools, it's exactly what we're doing. We're saying, here's all the tools, go create your applications. What we want to say instead is we will provide a set menu, limited options, but good options. We think about health and nourishment. We vet and select these tools very intentionally. We streamline our tools, we streamline our process. We want to improve efficiency, free up resources, right, to invest energy into actual differentiators for the business. This is called a purposeful evolution of technology. We're saying we want to create a golden path, a path in which all the developers have to do is drive, right? So an application development team doesn't need to worry about what supply chain tools to use, what CI/CD security guardrails they should use. All they do is develop and deploy their application. And this is an example of what a standardized platform might look like. Very clean, right? This is a very limited number of tools standardized across the enterprise. This is our set menu, right? If you need to write code, you use GitHub, or a small number of approved programming languages. One tool to do your builds, and one place to store artifacts. One tool to orchestrate your deployments, and one tool for infrastructure as code. Intentionally standardizing the tools landscape, right? If you compare that with the previous diagram, it's definitely much cleaner. So once we standardize on the tools, we want to create a single way in which an application can be deployed all the way to production. So all the steps that a change needs to go through from commit to production deployment, that's your pipeline. You want to standardize that pipeline. One pipeline to rule it all. This provides a standardized build, scanning, testing, standardized artifact storage, signature, deployment. If you do this, a lot of different development standards can then be enforced, things such as code reviews and artifact security. So if you're an application developer, you don't need to think about how to deploy your applications or what security steps you need to take. You just write code. You just write your unit tests and everything is ready to go. So in one of our previous examples, we said we only use a few programming languages, right? So what happens if someone just ignores this and chooses to use a programming languages that's more modern or more fun, right? What can we really do? So what I've showed you before is a carrot approach. What we're saying is that if you want to deploy faster and in a more secure way, use our standardized pipeline. Now that's a carrot. You want to start with this process, obviously, by offering carrots, but only carrots and no sticks. It's not going to work. We need both. We need to enforce certain standards such as code reviews, or that you need to create a change ticket for every production change, or security scanning in your pipeline. Everything, even things such as setting limits on how much cloud spend you want to allow, or how much CPU you want your applications to use. Pretty much anything your organization wants, you need to be able to enforce. This is a key to success. Sticks are as important as carrots. Now, this sounds like way too much policing, right? Less freedom. Obviously, there's a lot of cultural and organizational implications to this whole idea. And Winnie's going to talk about some of those.
Okay, thanks, Ravi. So Ravi laid out the case of why essentially unlimited choices may not be all that it's cracked up to be. Having unlimited options leads to cognitive load, anxiety, and variability, and honestly complexity in your environment. Decision fatigue, as Ravi described, is a real thing. I want to start with a quote from Alan Kay, a computer scientist at Xerox PARC and a pioneer of object-oriented programming, who famously said, "Simple things should be simple and complex things should be possible." So that idea informs our approach. So when you're picking tools, start with the end in mind. Are you choosing the right tool with the end in mind? Have you laid out all of the pros and cons of the tools? Will it integrate into your existing ecosystem? Will it scale to meet your future needs? Are you just picking new tools because they're new and shiny, right? The goal is to focus on business outcomes and not undifferentiated technology choices. As you pivot to focus on business outcomes rather than undifferentiated technology choices, the path forward becomes clear. As you embark on this journey, you must know that this will be a multi-year journey, but you will get incremental value along the way. Know the road is long, and you'll have to make these changes without disrupting the business. So a big bang approach, in our opinion, will not be optimal. Data migration is also critical. So if you're moving from one source control management system to another, as Ravi was describing earlier, things like the commit history, comments, merge requests, all have to be part of the new system. And training is also critical on how best to leverage the new tools. So I often get asked, is standardization detrimental to innovation? And the short answer is no. But in all seriousness, there's many things to consider when standardizing across a large enterprise, right? First, we know that technology decisions don't always have a correct answer. You operate with a bias for action, and you make the best decision based on the information that you have in front of you. Historically, we've given our teams a lot of decision-making abilities at the local level, which can lead to teams building things that already exist. I know I'm guilty of this as a recovering software engineer. Builders love to build things, and we want to encourage our builders, but they have to try and build more things that advance our business capabilities and just not commodity technology components or libraries that already exist in the marketplace. So it's crucial to know what's worth building and what is just a commodity that could be leveraged. Finally, we have to discuss the incentive models, right? Are we incentivizing the right behavior? If we celebrate folks making shiny new things all the time, well, that's a behavior you're going to encourage. So this is not to suggest that we shouldn't celebrate folks building shiny new things. We should celebrate those things as well as celebrating business outcomes. Speaking of outcomes, let's talk about the outcomes we experience. Right? A couple quick items. Centralized governance is possible and can help improve security by leveraging automated guardrails. As we move forward with more standardizations, teams that adopt these new capabilities see improved lead time to change, and we have a more consistent environment. We have less variability in our environment and less snowflakes. This leads to more developer collaborations. Right? If all of the developers provide and follow a standardized way to work, you make it easier for engineers to move from team to team. We're seeing things things improve, such as developer onboarding, right? We talk internally a lot about this notion of fungibility, and having developers use the same set of tools and technologies and processes simplifies that ability to swarm on crucial efforts. So if your developers can swarm to your biggest opportunities, you're going to get more value from that developer. I'm going to now turn it over to Ravi to talk about lessons learned.
Thanks, Vinny. In all of this, there were some key lessons that we learned. First, single source control is an absolute must. If you have multiple SCM systems, your code is fragmented essentially. Your developer permissions are fragmented, which causes high cost of maintenance. It's a nightmare. So if you don't have a single SCM system, please fix that first. That's a one SCM system for your entire organization. That's a must. Next, having a central team that takes a global view of the entire process, of all the automation, of the common libraries, creating an overall vision, or centralized metrics, centralized governance, all of this is essential, right? Like you can call this centralized DevOps team a tools team, or you can call it a platform engineering team, whatever the name is, but such a team is essential. Next one, Vinny talked about picking the tools with end in mind, right? Like we have to understand that when selecting a tool, we don't need the best tool in the market. We need a tool that fits the business needs. If a tool is pretty good and fits all your requirements, that's all you need. Choosing one tool that's pretty good is much better than having multiple amazing tools in the market. And finally, when we talk about standardization and governance and security, it could be considered as boring or too much policing, but it doesn't have to be. It can be made fun. We can implement several gamification techniques and build excitement and make it fun. It goes back to the point that Vinny was saying about incentives aligning to business outcomes. This is a great way of making standardization and security super fun. Thanks for everybody for attending this session.
Thank you for choosing to watch my talk, From Infrastructure to App Deployment, Where Does a Platform Start and End? I'll start with a quick introduction. My name is Paula Kennedy. I'm COO of a company called Syntasso. We make an open source framework called Kratix, which aims to make life just a little bit easier for platform engineers to build a developer-centric platform. Our code is all on GitHub, it's open source, so if you want to take a look and give us some feedback, then we'd love to hear it. So diving into my talk, today I'm going to be talking about what a platform is. Then I'm going to try and dive just a bit deeper into what a platform really is and cover some common platform patterns. I'll offer some suggestions of what good could look like for a platform, and I'll cover some boundaries of responsibility for teams and parts of a platform that you might want to consider. So part one, what is a platform? This is my favorite platform definition. It's from Evan Botcher in 2018, and I quote it quite frequently. He said, a digital platform is a foundation of self-service APIs, tools, services, knowledge, and support, which are arranged as a compelling internal product. Autonomous delivery teams can make use of the platform to deliver product features at a higher pace with reduced coordination. Now, I like this definition for lots of reasons, but it is a lot of words. So I searched for a simpler definition, and I found this one from Gartner that basically says a platform is just a product that serves or enables other products or services. Very simple. But let's be honest, we're in 2023 and we're at PlatformCon. So it feels like probably we've all got a good idea of what we think a platform is, and definitions are quite boring. The good stuff really happens when we try to build platforms. So let's take a bit of a deeper dive. What really is a platform? Now, I said in my talk abstract that I wouldn't say it depends because that's quite a classic consultancy answer, but really it does depend on your context. Your platform and how it looks can depend on lots of different things. The size of your organization, the skill set of your teams, how much technical debt you've got or legacy software that you're trying to manage. There are so many areas to consider when you're looking at how to build and manage an internal platform. A platform can be just as simple as an internal wiki, which has guides and steps telling people how to deploy software. Or it can be as complicated as weaving together multiple cloud providers, vendor-provided solutions into a patchwork covering thousands of application instances across different availability zones. It can be big, it can be small. I myself have been in the platform space for quite a long time, and my team and I have talked to lots and lots of people in platform teams. So we've seen some pretty common approaches and patterns, all with pros and cons. So I'm just going to highlight a few of those now. My team also published recently on our blog an article that covers this in more detail, but like I say, I'm going to cover just a few. So a first pattern is tickets. Regardless of what your underlying platform consists of, it's a very common pattern that the way teams interact with the platform is through tickets, quite commonly Jira, but I'm not picking on Jira. The good news in this pattern is that the workflow can be quite customized for your organization. You can customize what fields a application team has to complete, and that information gets passed to the platform team. The bad news is that the work to fulfill those requests is quite often slow. It involves manual work and can be quite error prone. And because of the time delay, teams might often look for ways around this process. Another pattern that I've seen frequently is giving teams, application teams, access straight to the cloud provider and treat that as the platform. Now, the good news is that the big cloud providers tend to have lots of services available and they're on demand so that folks can quickly get access to the services that they need. The downside is that these services that are available are not necessarily the ones that your organization needs. You are at the mercy of that cloud provider. There's no customization for your organizational requirements. And also this can get quite expensive very quickly if there's no checks on what the teams are spending. Another pattern we see, particularly as Kubernetes is becoming more and more popular, is that it's a common pattern to give Kubernetes straight to the developers. Now, the great news for that is Kubernetes has a very nice API. I'm a big fan of Kubernetes. Nice API and a huge community behind it to provide support and answer questions. But the downside is Kubernetes itself is not really a platform. It was never intended to be given straight to developers. It's quite a low-level starting point. And by giving this straight to developers, you're really asking developers to then navigate their own steps towards a platform, which puts a lot of cognitive load and effort onto those development teams. Now, your internal platform may have one of those patterns or more than one of those patterns or other patterns and approaches that you're taking. But really, where your platform starts and ends is kind of up to you. I was recently described in an interview I did with Jen Riggins as Madonna, because I was doing the Vogue where I said your platform is going to sit somewhere between infrastructure and application deployment. But really, that's accurate, and how deep down it goes or how high the abstraction goes needs to be tailored for what your organization requires. An important lesson that I've learned in more than 10 years in this platform space is that there's no one true platform. There's no one size fits all. Your platform needs to fit your organization needs. But a good set of platform characteristics that you could aim for include having a platform that is customized for your organization, having services available on demand as far as possible to get speed for your developers, and a clean and consistent API so that your teams aren't having to learn different commands for different things. They've just got one consistent experience that gives them a lovely developer experience. So, given all of that, let's take a look at some other areas that can be considered when working out how to handle your platform. Some ideas for what good looks like. If we refer back to the Evan Bottcher definition, he mentioned a platform should be a compelling internal product. So in other words, it should be treated like any other product where the platform team should understand the needs of their customers, the teams that are using the platform, and then they should gather the feedback, build just enough to be able to get more feedback, measure that feedback, and then learn. A classic build, measure, learn loop to make sure that the platform that is being built is the right platform, is going to fit the team's needs, and it isn't taking the model of build it and then they will come and then nobody comes because it doesn't meet the needs of the teams. It's really just, this is the heart of having platform as a product, making sure you have a product mindset applied to your platform. One good way I've seen to do this is really through very close collaboration, at least at the beginning. So I've seen where a product team and a platform team come together and actually do a value stream map. So actually try to map out the time it takes to go from a development team having an idea to it being deployed into production, all the steps in between. And by doing something that looks like this, the teams collaborating together can look at, are there steps in the process that are unnecessary and could be eliminated altogether? Are there some steps in that process that take time, unnecessary amounts of time, or are being blocked where that constraint could be eased? And by the teams collaborating together, it's possible to look at how to make deploying to production faster and smoother so that both platform team and application teams understand that process and understand and empathize with each other's requirements. Another thing I've seen done really well is for the platform team itself to have a mission statement and a public roadmap so that other teams understand what the platform team is there for, what they're trying to achieve, and how they're going about it. So I Googled some kind of common mission statements, and I found this one, which I liked actually, from American Express. I like the fact that it's very customer centric and says they want to become essential to their customers by providing differentiated products and services to help them achieve their aspirations. And I really like that customer centric kind of focus, which could be applied to a platform team. A key question to ask yourself is, can your platform team articulate its vision, its mission statement? And can other teams within the organization also articulate that? Do other teams understand what the platform team is trying to achieve? Okay, so we've covered what a platform is. We've talked about some common patterns, and we've looked at some suggestions on ways to improve how the platform can work within the organization. So there's one more area I wanted to cover, and that is boundaries. Where does the platform start and end? Now, again, this is all a question, a little bit of it depends. It might depend on what your mission statement is and the type of platform patterns that you have established. But one of the best references I've seen to help guide how you go about this is this book, Team Topologies. So this was a book that came out in 2018 from Matthew Skelton and Manuel Pace. It's a fantastic book, and if you can get your teams within your organization to read it, it offers a good common vocabulary between teams so that people can understand their roles and responsibilities, and it can help to advocate for frictionless boundaries between teams. Now, I'm not going to cover it in too much detail, but I just want to pull out a few key pieces that I think are really useful in this space. So first of all, within the book, they outline 4 team types and 3 interaction modes. And this is a way to help think about your organization. This might look familiar to you, and you may already be set up like this, or this may not be exactly how your organization looks. But really, the focus is about having stream-aligned teams that are able to kind of own every step of the process that goes from idea to production. And then they are enabled by having a platform team that provides self-service, and then having potentially subsystem teams and enabling teams that are everyone focused in the same direction of trying to get flow out of the business. Now, on the interaction modes, they talk about 3. There's collaboration, and then there's kind of a move towards offering things as a service with like ongoing lightweight collaboration that can continue over time. The book also has very good recommendations on how to apply a team-first mindset and guidance on having small, long-lived teams. So there's a lot of advice in here, but I'm just going to pull out just a few pieces that I think are really, really important. One is about restricting team responsibilities to match team cognitive load. Basically, what you've got is, we all know that in the current kind of climate of software delivery is complicated. There are lots and lots of things to consider. But if you can define your team boundaries where the team cognitive load can kind of match, what you're trying to do is avoid having one particular team, one application team, or one platform team being overloaded with too many responsibilities and just too many things to think about. So trying to match up the boundaries of the team to the boundaries of the work and what they can handle is a good way to think about whether you might need to create a separate enabling team if you want a team to be going out there and doing advocacy of the platform, or maybe a separate subsystem team if you have a particular database that everybody is using and it's very complicated. You might want a separate team, but the way to look at it is making sure cognitive load is balanced. Another great feature that they mention in the book is about then defining the APIs that these teams have, and this definition can be who owns which parts of the code base, making sure there's clear documentation that everybody understands, and making sure that the experience between teams working together is as seamless as it can be. It's also important that these team APIs continue to evolve because teams' needs change, team members change. It's important that this kind of way of defining APIs is kept up to date, is kept relevant so that teams understand how they're working together. And lastly, team interaction is really important. I've been asked in the past whether this rise of platform engineering that we're seeing is actually going back to dev and ops being separate. And I wholeheartedly say this is not the case, but it is important to make sure that by the platform team aiming to offer things as self-service, that isn't the end of where they interact with their platform users. The platform team should be aiming to continuously understand user needs, continuously interacting, kind of this lightweight collaboration model to make sure that the platform evolves in line with what their platform users actually need. So, to summarize, I've described what a platform could look like and how it needs to really fit your organization. I've covered some patterns for how to treat your platform as a product, having a vision, collaborating with your customers, and understanding their needs. And finally, I've talked just briefly about boundaries of platform and teams within your organization so that you can keep an eye on cognitive load and make sure not one team is overloaded, and to try to keep a focus on having clear APIs between teams to drive frictionless interaction and to make sure that everybody's pulling in the same direction. I've pulled out just some reading materials that I referenced in my talk, and I will be around on Slack. So if you have any questions that you'd like to ask, then please feel free to ping me on Slack or via Twitter or LinkedIn. And I'd just like to say thank you very much for listening.
The motivation for doing this talk, Is Your Platform Ready for AI, is of course what's been happening over the last few months with AI in general. The Open AI, Chat GPT, GPT-4 have exploded on the scene, and other tools as well. And it's really fundamentally changing many of our lives, especially those of us in IT. So I thought it would be interesting to look at what impact AI has on our platforms, where we run applications and how we run applications, and what things I think perhaps will be happening with AI, and how do we, what kind of platforms are prepared for AI, or maybe perhaps better prepared for AI. So I wanted to start with a look at some of the core features that I think are worth consideration for what I'm calling AI-ready platforms, and also look at some of the impact on software development as part of this. So this view here that I'm showing is of abstraction layers, and I'll show you what the abstraction layers are in a moment. But with everything that we do, software in our systems, they're all built on massive numbers of abstraction layers. And starting out with, say the zeros and ones that that drive computers, all the way up to AI and the incredible things that are happening with AI, with software, computing zeros and ones, and everything in between. But these abstraction layers, from a platform perspective, I broke up into 6 layers. So starting from the bottom, hardware. That was one of the first things to get abstracted away, and this happened around 2000, where virtualization came in, and we essentially replaced physical hardware with virtual implementations. So physical servers with virtual servers, and more virtualization. And I was around when this happened, and it was interesting to watch. I had at that time a fair amount of experience with physical computers, like working in the computer room type of thing, as well as just having being given computers for, let's say, the team that I'm working on. We were allocated servers for development, servers for stage, servers for production, those types of things. There was some grumbling when this first happened. People were worried about performance and so on, but pretty quickly everybody got over it, and we just moved on. So the hardware was abstracted away. But we still had the challenges of deploying applications to these virtual machines, because for all intents and purposes, they look like real machines. And and the challenge there for deploying applications was there's variations in the deployment targets. The variations in the operating system versions, variations in libraries, variations in the configuration of servers, and it just made the deployment process more complicated. So pretty quickly what came on the scene was containers, which was a brilliant invention because the containers isolate the things that are running within the container from the environment that the container is running itself. So from the perspective of, say, the application code that's running within a container, it had a consistent environment that was precisely defined with exactly the right versions of software that that the application depended on, and we moved on. But then we started running lots of containers, and people started looking for ways to manage those containers. And pretty quickly after that, along comes Kubernetes, which was a massive improvement, where it provides an abstraction layer for managing containers across a wide span of underlying infrastructure capacity. So much CPU capacity, so much memory capacity, storage capacity, networking, all those things. This was just a genius invention for managing applications. And in fact, I kind of consider the platform architectural evolution to be in three epochs. There's the epoch of pre-Kubernetes. How did we manage our infrastructure and run things in our infrastructure before Kubernetes? Then there's Kubernetes, the Kubernetes epoch. How do we do things in Kubernetes? And we're firmly into that. We're years into this Kubernetes epoch right now. And then the third one is post-Kubernetes, and we're starting to enter that. And what I mean by that is that Kubernetes itself is abstracted away, and more solutions like this are starting to show up, platform types of solutions. Now, another abstraction layer, or set of abstraction layers that applications are dependent on, of course, are databases and other services. So databases for storing and retrieving our data, and other services like message buses for moving our data in a distributed system environment. And even there, what's starting to happen is that these things are being abstracted away as well. And this is kind of the serverless way of doing things. That is, we're abstracting away complexity to simplify deploying, running, scaling, isolating failures, those types of things from the application code, and just making it much less complex to do this. And this is where the AI part comes in, is that with these lower complexity environments, when we start to partner humans with their AI coding assistants, you just get that much more power, that much more efficiency in the overall process, because the actual process of developing applications has been simplified considerably as well. So our landscape is starting to change, and I think AI is going to accelerate that. So what are some of the benefits of this type of an approach? Well, I think by having these high abstraction platforms, we're getting to the point where it's providing a way for us to reduce the complexity of the code that we have to develop to create applications. And what I mean, again, by that is things like simplifying and the things that developers have to do when they're executing or implementing code. Another example here is that because of this kind of reduced complexity and simplification, it makes things like this even easier. Here's an example that I did recently with GPT-4, where I essentially trained it on some code. So I entered a prompt where I said, the following Java source code is for shopping cart entity. This is basically a microservice. And at the very end, I said, please respond with okay that you understand. And it came back and said, okay. And then I said, here's another source file that's for a view of the data that was created by the shopping cart entity. And this is an event-driven type of an application. It's using an approach called CQRS, which is Command Query Responsibility Segregation, where one piece of the code is handling the writes, the creation of data, and another piece of code is handling the querying and the reading piece of data. And this is what I'm setting up here. Then I gave it a third source file, and I said, now this is the source file for a stock order entity, a stock order microservice. And then finally, I asked it, please create a view for the stock order entity. And the GPT-4 wrote the code for me. Again, this process is simplified because this code is simplified. It's not complex. It doesn't have a lot of things that it has to do to talk to databases, talk to message buses, things like that. And it just kind of accelerates the entire process even more than it was already accelerated by having a simplified environment. So this app that I'm developing is kind of I'm a developer advocate, and I get to write fun demo apps. And this one is an app that generates lots of orders in a kind of an e-commerce type of a demo. And it's a reasonably interesting application. It's composed of 13 microservices, and it's all event-driven and those types of things. But it's built using simple components. I talked about two, entities and views. There's a third component called actions. But if you look at this diagram, those are the three shapes that are on this diagram, and those represent pieces of software that are written in Java, in this case, to build this system. So it's a simple system to build, simplified because it's on a high abstraction platform, which is significantly bootstrapped and accelerated by using AI coding assistance. So what are the challenges with adopting AI? And I think the biggest thing is getting people to change. As I mentioned, I'm a developer advocate, and I've been doing this for quite a while now, about 7 years. And I've seen when I try and help people, a big part of my job is training people on new technologies, how to use new technologies, new approaches to do things. And I can see that reluctance in a lot of people they're carrying a lot of baggage, basically. And it's hard for us to let go of things that we know deeply and understand well and go into brand new territories. And this is definitely a brand new territory, moving into doing things on, exotic new platforms using exotic new tools like AI. But we have to have as a skill set this ability to be prepared to change, to let go of things that we know and learn new things and how to do it. Along those lines, there's this great video by Brett Victor. It's called The Future of Programming. He did this video in 2013, so it's 10 years old, but it's very relevant to this topic of being open to learning. And this is the focus of his talk. In fact, the way he did this talk is he acted as if he was a developer in 1973, talking about what computing would be like in 2013. He dressed as a developer, even had a pocket protector, and he had an overhead projector. It's an absolutely brilliant talk, so I highly recommend it. There's a QR code for it. But what about the future of these AI-assisted platforms and the impact on software development? Well, I think this is what's really important. Our platforms have to evolve, and I think they will be evolving very quickly into these higher abstraction platforms. And what I mean by that is abstracting even higher levels than where many of us are at, say, with Kubernetes. Of course, many people aren't even at the Kubernetes level yet, but you have these highly abstract platforms. I've been using one myself for over a year now, and they're out there, and there's more appearing all the time. So this is more than serverless; it's everythingless. And what I mean by that is, they say serverless. Well, there's still servers. Of course, there's still servers, but as a developer for operations, we don't have to deal with those things. For databases, we don't have to deal with those things. They're abstracted away. Of course, we're still persisting data. Message brokers, they're still there. We have to still do messaging. I'm talking about, in my case, event-driven systems. And what this allows us to do is really focus on feature-focused development. And when you really think about it, every one of us in IT, we're here to pump out features. The goal of the entire organization, all of us, is to assist in the development of applications that create features that we put into production to enable users of our systems to do things with them that help the people that are paying us to build these systems make money. That's essentially it. And I think that a thing to consider is that the further you are away from the direct involvement with feature-focused development, the more likely some of these big changes that are coming are going to impact you. I'm not saying that I don't think anybody's immune to the changes that are coming. Everybody in IT, I think we're going to be impacted. But the further you are away from feature-focused development, the more likely you're going to be in for some really big changes. And another thing I think, and this is just something that I've been thinking about, is that things like considering AI prompts as a new source code. We're all excited about using AI to generate code, but maybe the new source code is the actual prompts themselves, and maybe there's prompt languages that will come out, things like that. So I don't know. I think that a lot of things are going to be happening here. They're already happening very quickly, but in terms of affecting how our platforms work, how we use our platforms, what kind of platforms we have, and so on, I think things are moving fast. I want to leave you with two things. If there's this quote, the literate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. I think this is a critical skill. And then the other one is that I also, this was more recent, AI will not replace you, but people using AI will. So thank you so much for listening to this talk. By the way, the platform that I was talking about that I've been using for a while that has this high abstraction is called Calyx.io. But thank you again for your time, and I really appreciate it.
Hello, I'm Amir Abadir. I'm a product lead in ING's technologies platform. I'm a product engineer at heart with a great passion for creating products that bring value to our consumers. My primary focus now in ING is to enhance our developer experience on the technology platform through journey automation, easier solution assembly and integration, and streamlining of processes for developers to build solutions on top of our platform. In this presentation, I will share with you our experience in building ING technology platform, including accomplishments, challenges, and strategies for achieving a better developer experience. 3 years ago, we recognized the necessity of developing a technology platform that could serve as a foundation for creating and managing solutions and business applications. Our primary objective was to provide our users with the capability to concentrate on their core objectives and effortlessly operate applications without worrying about the underlying technology. In doing so, our developer community could build on top of the platform and align it with their unique propositions, leveraging the benefits of products and service reusability. This approach results in a shorter time to market, consistent high-quality products and services, increased productivity, and reduced costs associated with maintaining our services. Our main promise to our consumers and developer community was to empower the developer community to reach the customers ever faster and ever more meaningfully. We have had great accomplishments in our promise building the technology platform. Our consumers now have access to a variety of services, including foundational services like SDKs, gateway, service mesh, and standardized pipelines, as well as experience services such as our UDS system or Unified Design System, which is our system that includes all the tools, guidelines, and reusable front-end components that ensures a consistent user experience in the end. Additionally, we also have the business services such as authentication, notification, or engagement services. Our foundational services currently support over 1,500 running applications, web applications, mobile applications, and service applications. We provide support for more than 1,000 running APIs on our mesh, and we process millions of authentication and notification transactions on a monthly basis. We provide support to our developer community's 15,000 DevOps engineers while catering to the needs of over 30 million of our beloved customers in more than 10 countries. Despite our numerous accomplishments in building the technology platform, we have encountered some challenges or setbacks. The very success we have achieved has brought to light new issues that were not problematic before scaling up our technology platform. While we were able to improve our time to market significantly through the reuse of hundreds of components in our catalog, we encountered challenges with the complexity of integrating these services together and the amount of time spent on the manual and repetitive configuration. Engineers don't know where to start, what to do next, who to talk to when they are integrating a service, which team is providing which part of the platform. It resulted in an incoherent experience because the whole complexity of integration offset all or most of the benefits of reusing components that are actually available for people to use. That resulted in high lead time. It resulted in engineers not knowing what is needed, and engineers doing things that are actually they don't enjoy the most. Ultimately, we became slow, impacting our innovation. It took us sometimes 6 to 7 months to have a simple application deployed on production and running with all the configurations that are needed, like gateway configurations, network configurations, and so on. And this is very simple code that could actually take maybe a few hours to implement. But with all restrictions that are in place and all the controls that need to be met to go to production, the whole process was tedious and slow. At this point, we came to the realization that we must prioritize our consumers, which are in this case our developers, their experience and how they engage with our platform. Instead of providing a collection of individual products and services, we present a comprehensive platform. That is how it should be, where the experience as whole is paramount. This is the whole experience of our developers is what is most important, rather than from our view as of a platform provider, looking at it as a bunch of collected services and products. It's a whole experience from our consumers trying to stitch all these products and services together. This is what we were actually not focusing on. Our success is subject then to the overall experience of the platform rather than the products that were being developed in isolation. For this, we started focusing again on some of our tools, main tools, and we started focusing again on some of our main principles and how to shape this for a better developer experience. We started with trying to focus more on our pipelines, extending these pipelines, making them rich pipelines, which then should be tailored and standardized for the various common types of resources that developers are trying to build, encompassing everything from the build process to the deployment process for different kinds of resources, such as web applications or APIs, trying to have them deployed. And then one of the main things in our new strategy is much more focus on automation. Engineers are not required to manually configure services and products. Instead, they can leverage on the pipeline and our command line interface or CLI to self-configure these services they require in a consistent manner, using the shift-left approach, where we want to focus on configuration as code instead of disconnected portals that we are trying to configure things consistently. So now imagine this. If a developer trying to build a backend service application, they would identify or define their backend service in a YAML file. They have it stored in the repo, and then it gets pushed through the pipeline to our configuration manager. Our configuration manager is highly influenced by the Kubernetes API. This configuration manager receives all the incoming requests for configuration changes, does all the authentication and authorization necessary for it to actually check if this configuration is allowed. So we have our OPA, or the Open Agent policy. And then this is where all the checks are done. Is this configuration allowed? Is this team allowed to request this configuration? And all the other checks that different resource providers would like to have in place. Then, if everything is in check, the configuration manager would have this placed into our Kafka event bus. And then this is where the magic happens, where all the different controllers of our different resources would then process this request accordingly as per what is actually needed. And then you can imagine that we have the namespaces created, our VMs provisioned, or our CHP instances already automatically configured for our users. And then this is where actually it happens on behalf of our users. Users, they don't need to do this anymore. So that is the whole automation. It's highly focused with all the triggers to be in place, and then with all the next steps for our users to be done next. Then we have our console, or this is the management cockpit, where developers are able to effortlessly monitor and manage their applications. What is the status of the applications? What is the status of all the dependencies of this application that actually makes it run? And then on top of the console, we also have our wizards, which allow the developers to avoid building everything from scratch. Think of these as simple stepped approach, where we take the developers through the intention of trying to see what they would like to build. These are optimized paths that actually further enhance the engineering experience, and the end of these wizards would be the bunch of YAMLs that the user need to have stored in the repo. Usually this is much beneficial at the first time they are trying to build something, and then if they would like to change, they would refer to their YAMLs and change all their configuration over there with a kickstart from the wizards to scaffold some of their code already. Then we have integration patterns, where it facilitates the collaboration between different platforms. So we have our technology platform, we also have our infra platform, we have our engineering platform, where we identify teams, what are the roles of the teams, what are the membership in these teams. This is the base of understanding what who is allowed to do what. And then with these different platforms, we need a kind of integration pattern. So we need some collaboration, we need some automation consistency across these platforms, so that they enable to have automated resources in the end span for our users. So this collaboration allows for the swift configuration of the resources and the spin-off and setup of environments within minutes. And then we have the portal that brings together the engineering resources. So this portal, we have the home part, which is the promotion part, where actually they can find all the tools, they can find all the support for the community, they can find feedback, they can find updates and news, they can track all their issues under support and so on. We have some marketplaces or the catalog, where we want to show all the services and products that we have in our platform and encourage reuse, so that eventually we make use of the reuse of these components and not reinvent all the wheel. In addition to having a faster time to market, it leads to consistency of these services in the end. Yeah, so the portal, we have the home, the marketplace, and the console, which we already discussed. This is the management cockpit. But then the whole portal, the aim of the portal is that it brings together the engineering different resources and tools, providing an extensive support throughout the entire life cycle of the solutions. This support spans from discovery to design phase, through development, and all the way to the distribution of our software and components. Our goals in the end were very specific. This is where we identified some of the matrix, or the trailing matrix that would eventually identify our success in improvement of the developer experience. So we wanted to focus on, or trying to achieve,
achieving a reduced lead time of creating and deploying new applications in, say, less than 15 minutes. We wanted to eliminate manual and inconsistent ways of configuring services and products, such as emails, tickets, and portals. All that was very confusing to our developers, and it was actually leading to a much broken engineering journey. We wanted as much as possible to eliminate this manual and inconsistent ways of doing things. We want to provide a unified developer experience that does not entail yet another portal that was created by another team, and eventually it would add to the complexity of the experience. We wanted to strive to provide a more focused experience on journeys and the platform as a product instead of a bunch of services. Rather would be a platform as a product, as how our developers or our consumers actually see it. Improve the overall documentation, training, feedback, management, and support would also assist us in this platform as a product mindset. And then, by achieving all these goals, we are better positioned to deliver our initial promise of a shorter time to market, increased productivity, and lower cost to serve. Thank you.
Hello, and welcome to my PlatformCon 2023 presentation on FinOps platform products. My name is Ajay Shankhamat. I head up the platform engineering team at ThoughtWorks North America. So let's first talk about what are we going to discuss today. This is not going to be a presentation on FinOps, nor is it going to be a presentation about platforms. Instead, what I want to talk to you today is about why should we be using platforms for solving the FinOps problems that we see on a day-to-day basis. And we'll talk about what does it entail too. It's going to be a use case-based approach. So we'll show you some use cases where we have actually seen this problem, so it becomes easier to understand why the platform approach should be there. If you're not familiar with the concept of FinOps, please check out the great O'Reilly book by JR and Mike, or you can check out finops.org too, which has got a lot of information that might be useful to you. So let's first talk about what problem are we trying to solve. We know that the cloud usage has exploded over the past few years. Significant amount of spending in IT is happening in the cloud. We also know that majority of the people are actually using cloud. There are very few people who don't use cloud these days who are digital natives. And without optimization, we know that it is a pretty bad idea to continue using the cloud as is, because you have significant amounts of wastage happening through that. This is the context of the fact that majority of your software investments are also happening on the cloud. So it should not be a surprise, the fact that more than $500 billion is going to be our cloud migration services market by 2027 or so. But the most alarming piece of data that you would see here is the fact that if you talk to the majority of the business executives who actually are involved in this, they believe that about 66% of them believe that cloud has not really given them the savings that they've been looking for. I mean, you might turn around and ask, like, wasn't cloud always supposed to be a move from CapEx to OpEx? Isn't this something that supposed to just move the money and make your business better by improving your revenues? Yes, that's absolutely true. But the question is, does it matter? If you tell your customers about some of those things, are they really going to be not wanting to save money? So saving money or optimizing your cloud investments is a huge thing for pretty much everybody using this. Now, let's talk about the FinOps problem and where does the platform comes in. Just like solving any other problem, the approach that you would be taking is first start with a specific environment, look at it, understand what kind of issues are there in that. Try and get more data by doing a deeper analysis and try and understand, like, do we know exactly what might be going on within that space? Then you can always try and build the solutions. However you build the solutions doesn't matter. You end up doing some level of automation, some level of manual activities, but you end up building some kind of an automation to optimize this. Once you do that, then you move into this phase of your BAU, and you want to try and make sure that whatever you optimized becomes the standard way of operating things. So within the FinOps community, the way we talk about this is that there is this inform, optimize, operate cycle that really tells you all the things that we just spoke about. And that's interesting because platforms are fairly prevalent in that, especially in the inform area. So if you look at the inform space where you're really trying to increase your visibility of the problems and try and make sure that you know exactly what the problems are, commercial off-the-shelf platforms are a lot. So this is available today. But if you look at the optimized space, there is like minimal platform inroads in that space. You can really find what the problems are. There's platforms for it, but to solve the problems, it's still up to you as an organization to try and fix it. So whose problem is it to solve it? Is it a finance problem? We typically look at FinOps in a more traditional way as a finance problem for all the obvious reasons. But if you really look at it from the point of view of how product management teams are setting the roadmap for their products and their life cycle of the products, don't they really want to know about the cost of their solutions? So could it be a product problem? But in reality, what we see is that it's mostly the technologists who actually make the decisions on using the right kind of cloud services. So it could be their problem too. So in order to solve this problem, what this really tells us is that it is something that all three parties have to have some involvement or the other. So now let's talk about why do we need to solve this problem. So this is where we really start going back to the concepts that we looked at earlier. Getting the data, finding the problems, and then solving the problems, right? So at the level of looking at collecting the data, the kind of data that we are really talking about here are things like what's the cloud utilization? What's the kind of finance data? What's your business data? What's the observability data coming from your system? So all that kind of information is extremely critical for you to figure out what the problems are. But once you do that, you really start thinking about what are your automation priorities? How are you actually going to automate it so that you can solve this problem better? And the first problem that you see here is the fact that the data that is collected, the priority of the data that's collected, and the kind of ease at which we are collecting the data is not typically an organization's automation priorities. They are always automating things like your anomaly detection, your usage reports, your compliance reports, and things like that. But those really does not map with the exact kind of data that is available. What makes it even more interesting is that if you think about, if you do some kind of a value analysis of the kind of problems that would provide you the biggest ROI, you see that the remediation priorities, things like, you must have heard of thinking about tagging all your resources, making sure that you have a culture of FinOps so that everybody takes responsibility for what they should be doing and the right decision to make, or things like right-sizing your resources. Those things are your remediation priorities, and those typically don't match up with your automation priorities either. And to make matters worse, if you really look at your overall maturity of your product and overall maturity of your FinOps approach, the kind of things that you should be thinking about are things like unit cost economics, right? Because this is a concept where you know exactly what a particular application is using up from a cloud resource point of view so that you have a better idea of whether you should be doing that spend or not. But that's one example. Other things are, again, things like budgeting and the decision making and all that. The priority of those things are not aligned either. So this data is actually directly from FinOps Foundation, finops.org. You can check out data.finops.org to see a lot more detailed analysis of some of this information. And we have also found this from a lot of our internal experiments and working with a lot of our clients. So let's look at some of the heat map of the most common customer problems, right? So this is when we have actually worked with many clients to solve these problems. We found that there are 5 classes of issues that customers see. The number one, like we talked about, the data-related one. The second one is more of an organizational alignment issue. The third one is like, how are you setting up your pipelines, your DevOps processes, your overall CI/CD and things like that, and what are you actually doing with that? Then you have your overall platform operating model also as one of the challenges there. then the sustainability aspects is becoming much more prevalent these days, where you really start thinking about, can we actually do something that is more environmentally friendly, more sustainable, as opposed to can we just use the cloud the best in the most cost-effective way possible? So all of these things are anchored in the FinOps core principles. So FinOps has six core principles, and it's all anchored in that. And we use sort of proven platform operating principles and the practice capabilities to make sure that these things are understood. So if you look at all of that, what you find is that these things, what we just saw earlier, sort of maps into a much more detailed set of challenges that we see from our clients. I don't want to go into all the details around it, but I just wanted to show you as to what those things are. So what you're really talking about is like things like, within the data space, things like, what are the, specific cloud costs that will increase over time. We all know that cloud costs increase over time because your usage increases. So it's not easy to see what's happening. So figuring out correlation there, the awareness of your reports, right? And then things like, are the reporting simple enough for everybody to understand that? Are we getting the reports at the right time? Then you're really also thinking about what are the types of costs that are involved in it. So all these things really tells you a lot about what are the kind of issues that clients see when they start solving this problem. The other thing is from the point of view of your organizational alignment point of view. Are you aligned as an organization? Or do you have the right kind of culture with respect to if you are using a DevOps culture, making sure that your developers are empowered, your engineers are effective to produce what they need? Do you have the right kind of team structures, things like that? On the pipeline side of things, we have, again, lots of challenges that we see with respect to standardized reporting, as well as the right kind of chargebacks. Are you actually having the right kind of compliance built into every step of the way? Then when you really look at your platform operating model, you can see that there are challenges with respect to self-managing your resources, as well as doing the right sizing and making sure that your product, whatever product that you're building within the space, has got the right level of maturity in there. Then we talked about the concept of sustainability, where we really talk about things like green ops and trying to make sure that your emissions are mapped properly and all that. So the reason I showed you all of this is just to give you a feel for what are those 5 areas, what are the kind of challenges that customers typically see within these 5 areas. Now, let's get into the actual platform implementation of this. So you see that anytime you build a platform, there are some core platform capabilities that you need to have. So let's talk about this as number one is probably cognitive load. We hear a lot about that these days with respect to how can we make your developers' life easier by making sure that they don't have to worry about the things that they shouldn't be worrying about. Then the overall efficiency of your process. Then are you agile enough, right? I mean, so with that, what we mean is, are you really trying to make sure that whether your organization can tap into the requirements of the business, in a fast enough manner. The 2 other capabilities that you're always going to be thinking about when you're building a platform are replaceability and composability. Replaceability from the point of view of the fact that you have a lot of additional integrations that you would be building as part of a system like this. So how easy is it for you to replace some of those components? Then you also have to think about from a composability point of view. The shape of your platform as you see today will not be the shape of your platform tomorrow. So you might be integrating you might be composing your system using different components. So are you able to do all of that? So this is essentially, as you can see, it sort of maps into various details as you might actually have to look into for making sure that these capabilities are available. So with that in mind, let's look at a blueprint of a FinOps platform. So let's assume that the fundamental piece of there is a set of cloud services that you get from some kind of a cloud service provider. Great. The next step in the process is your cloud migration analysis accelerator. So these are the set of tools that we talked about earlier when we talked about the Inform part of our FinOps lifecycle, where you can really use some of the platforms, some of the tools that's out there to tell you what the problems are in a much more detailed manner than what a cloud service provider would tell you. In addition to that, you will also have some kind of an observability platform in your organization. So you want to make sure that observability capabilities are available and integrated well with your cloud service provider data. Now, once you do that, the next thing to look for is what are those essential capabilities that you should have when you're building the FinOps platform. From our point of view, there are 5 different categories. What we call as the core capabilities, then metrics related, alerting and notifications policies, and automated governance. So within each of these space, you can see that the actual capabilities that needs to be built are things that will solve the problems that we talked about earlier. So you can see that a platform as a whole sort of comes together when you really start making sure that you have a composable set of capabilities that you can really plug and play into this overall ecosystem. But not to forget the fact that FinOps is ultimately an organizational issue, like we talked about. So if you talk about it from an organizational point of view, are there cultural aggregators that you can codify? And the answer to that is absolutely yes. So that has to be an essential component of how you build a FinOps platform. With that in mind, you also have to make sure that your system has to be like API friendly. It has to be API first way of building it. And this is extremely important because this is what really determines whether your data is going to be real time, where your actionable insights are going to be real time or fast enough. So that is the other component of it. So as you go through your FinOps platform product journey, what we recommend is a step-by-step evolution of the process. This is no different from building any other platform products. If building a FinOps platform product is not going to be any different. So you start with your core business problems. We talked about what those business problems are. And then you start doing some sort of a value-based prioritization of these capabilities. Then once you do that, you know what you should be prioritizing. Then start mapping that into the remediation priorities. So you remember the slide that we saw earlier where your remediation priorities and automation priorities were not matching up. This is the place you really start mapping that. And ultimately try and make everything data driven. If your data tells you something, believe that, right? Because that's exactly what you should be doing to get the biggest bang for the buck. And then we talked a little bit about the APIs earlier. So we are really trying to make sure that anything that you build is programmatically controlled so that you have better chance of improving the adoption of this platform. And that is exactly how you really get to that ultimate point where you're really going to have your platform product ready. So if you have more questions, definitely reach out to me. And you might also want to check out a couple of offerings that we have from ThoughtWorks on the FinOps platforms, as well as how to improve the engineering effectiveness. Because ultimately, this problem really ties back into how your engineers can be more effective, should be more effective to make sure that your organization as a whole is delivering more. And I'm sure you are quite familiar with some of the work done by my colleague and chief scientist of ThoughtWorks, Martin Fowler. So check out Martin's blogs for some really interesting articles in the space. Thank you. Goodbye.
Welcome everyone and happy PlatformCon day.
And welcome to our session from Cloud Cost to FinOps. In the next 15 minutes, we'll be walking you through what our business does, what our team does, and what is our use case for FinOps, as well as the journey we embarked to get there. We'll then finish it off with the impact this had on our business. Hello, I'm Suraj Narvade, Senior Infrastructure Engineer at RVU.
And hello, I'm Georgia, a lead engineer at RVU. RVU is a UK-based group, part of Red Ventures, of online brands that work to empower consumers by helping them compare home services like your energy and broadband provider, insurance for your car or for your home, and other financial products like mortgages and credit cards. We have a list of different brands: usage.com, confused.com, money.co.uk, Mojo, and Tempcover.
And now let us introduce Georgia and my team. Name of our team is Airship. You can think of us like a snazzier cloud platform team, the cute red panda as our mascot. We primarily focus on just the London-based brands like uswitch.com and money.co.uk. We enable our engineers to deliver services quickly, reliably, and securely. We manage platform infrastructure. We provide tools and solutions for all of our teams. We operate on Kubernetes clusters and on AWS.
And now that our team and brand are a bit clearer, let us walk you through our business case. Firstly, we wanted to simplify our stack and ownership model. We have grown so much as a business, acquired multiple brands, and saw our teams changing as a result. Our stack got progressively more complex, as well as some part of it becoming obsolete or with no defined owners. The second business case we're trying to address was around market conditions. Challenges in the market conditions for one of our brands and in general meant a slightly change of priorities, and we started evaluating how to better utilize our cloud resources and if there was anything we could do to reduce wastage from a financial perspective. Even though this was not a primary objective, our view as a business has a net zero goal by 2024. As such, we also looked at our cloud usage to understand what we could do to improve on this front. Previously, we were more focused on cloud cost. The Airship team had already explored a cost dashboard capability in the past, but it did not yield many results. And that was mostly because all of the cloud cost responsibility was falling onto our team, rather than be shared across all of the product and engineering teams. So now we will walk you through our journey from our previous cloud ops model to a model that promotes shared responsibility for an organization's cloud computing infrastructure and costs, also known as the FinOps model.
We understood that writing down our goals was going to be essential for this next attempt to succeed. We wanted a capability that would empower engineers, head of departments, and the finance team to easily track and attribute brand cost as well as the platform cost, so we could share that responsibility across. We wanted a capability that would easily accessible and actionable. We wanted a capability that would provide both fine-grained and long-term data availability. It should be self-served, as everyone should be able to use the platform and make the decision and actions of the back of that without depending on our team.
Once the business goals were clear, we started assessing the problem from a more technical point of view. Should we build our own solution? Should we implement an open source project, or should we rely on an enterprise solution? Will one solution really satisfy all our requirements, or do we need more than one solution? Do we have anything we need from a data perspective? And also, how much time do we have? Actually, we didn't have much time, just 6 weeks top.
Once the technical assessment was done, we noticed that one of the major detractors to meet one of our goals was the lack of tags for our AWS resources and labels for our Kubernetes resources. This is important because it was the only way we could easily attribute an application and its resources and their cost to the correct team all the way through the correct brand. So we got to label and tag all the things, starting from the resources that together would make up around 85% of our bill, which is Kubernetes and RDS databases, as we could not have ambition to tag everything under the sun in less than 6 weeks. Once mostly everything was tagged and labeled, we moved on to the next step of technical assessment process. In this process, we had various proof of concepts, and we came up with this architectural diagram to best cater for all our user personas. Firstly, the platform operator, which is us. We choose the open source version of KubeCost as a way to gather information for cluster cost and out of cluster cost. Our second persona was engineering tech leads, who will get fine-grained information for cost and utilization on a weekly basis. But this was not enough to satisfy all the requirement of other personas like our head of department and the finance team. For them, the information presented was too fine-grained and too technical. They needed something which is on quarter by quarter basis that could identify the spend at a brand level and ideally stored in a BigQuery. So we decided to extend the solution and leverage Argo workflows in order to export a simplified version of data for long-term storage in BigQuery and provide a view of the whole business which they can easily access via Looker Studio.
And just like that, in 4 weeks, we came up with a solution. We left 1 week over the Christmas period in order to gather enough data, and the MVP was out the first week after the Christmas holiday. As mentioned previously, we use Kubernetes clusters as a platform for our application. In the first month after the launch of the MVP, the size of our cluster decreased by 33%. Not magically or automatically, but because our teams had a very clear and actionable benchmark to understand how to better utilize their resources. And ultimately, a smaller cluster meant a smaller bill.
As overall cluster size went down, cost for our compute resources also went down by 15.4%.
Moreover, our idle cost across our clusters went down by 20%. In case you're not aware of what idle cost is, cloud idle cost refers to the expense incurred for keeping cloud resources active but not being utilized. Reducing wastage is one of the main factors for improving as well on the emissions of your platform.
By building something easily actionable and self-serve, we had improved the visibility on our entire platform estate for any further improvement. We reduced and keep reducing our cloud spend by a projected 40% year on year.
And as a result, we have a much more efficient platform going forward, and we reduced our cloud and compute wastage, putting us on the right track for net zero. We would like to leave you with just a final word. This should not be a one-off exercise. We had a business need that forced us into looking at our cloud spend, but we did not just stop there.
By investing on a self-serve platform capability, you can really enable your engineering team to own every aspect of application, including underlying cost. Thank you.
Thank you.
Hello, my name is Alex Cruzkov, and I'm here to talk about the power of collaboration and why every platform engineer should engage in open source contributions. So before we start, a bit about myself. So hi, I'm Alex. I'm a data platform engineer at Wix.com. I worked in several companies, mostly in platform DevOps or system roles. I'm passionate about providing the architectures that will hold for high throughput and will last for years, yet minimizing the in-company knowledge and providing self-service platform for its users. Lately, I began contributing to the Apache Airflow product. For whoever who don't know, it's a big thing in the data engineering world. I've contributed to the core product and for the third-party integrations, which called providers. And I'm here today, want to share some of my lesson learned and some impressions that I had during my own contributions. So you probably integrated some open source product into your code, and the process looked a bit like playing with Legos, right? So you create a CI/CD platform for it. You tried this, you tried that. Nothing really works the way you want it to work, and you have like a bit of fighting throughout the process. When you eventually succeed, you write documentations on how to work with this product. You fix some integrations. You create monitoring and stuff like this. All of your journey with working with these products are making you an expert in this specific open source product, framework, or whatever. It makes you the source of knowledge. So internally, people approach to you. And what I'm trying to say is that you have the expertise and you already have all of the knowledge that you need to contribute to open source products. So don't feel that you don't have it. But before we'll talk about what contributions give to you, let's define what are our contributions. So the most obvious thing is code contributions. So you can contribute actual code, fix bugs, add features, and stuff like this. But contributions are everything that makes the product go forward. So attending tech talks, talking in conferences, arranging and having meetups, or writing blog posts, sharing your knowledge and your expertise are also contributions. And feel free, and I do so, because it's really, really important. Also, writing new documentations and fixing existing documentations are also sort of contributions, which are really, really important for the onboarding of new people, or for troubleshooting. Now the next point about it's a bit might be a bit different between the projects, but in most of the projects that I've encountered, you can help with pull request reviews. So you can actually review someone else's code and offload the current maintainer's job in providing best code in there. Also, a point that is getting missed, one of the most important contributions that you can do is to give support, either on Slack channels or workspaces, GitHub issues, or GitHub discussions. Providing and helping the other people is helping with triaging and advancing the product forward. So let's talk on what's in it for you. So why I think that you should contribute to open source, and why I think that everyone should do so. So if you choose the code contributor path, it makes you a better engineer. While you work on your existing company, you often take a lot of stuff as granted. So you are working on a specific cloud provider. You're working with existing monitoring stack. You are working with specific infrastructure, or you made decisions that are now need to last. Well, open source projects don't have this privilege. They need to make their solution as generic as possible, and when you develop it, you need to make sure that it will work in every flow available. You cannot cut corners, because you don't know who's your reviewer gonna be. You don't know what quality people expecting to. It makes you to provide, generally speaking, a better production grade code, and it makes your skills sharpen. You don't need to hassle with the YAMLs, but you actually develop the feature itself. And also, as J.K. Rowling said, you can't be a good writer without being a devoted reader. While you start contributing code, it will force you to actually read the existing code, and make sure, and while reading the existing code, it will make you a better engineer. It will deepen your understanding, and will make you to understand better and the product itself. So you think you're doing good local work, local development and CI/CD, so you might think this again, because in your company, you are used to developing to the same people. You often have like 50, 100, or 300 people as your developers, but you have direct contact with them, meaning that if somebody tells that something is not working for them, you can ping them on Slack, you can talk with them, you can go to their PC and understand why it's not working. But again, open source don't have this privilege. So they cannot cover known bugs or flaws in your ecosystem with documentation that are specific to you. In open source, they build already tests, either by function layer or for integration, SDK, like various SDKs or whatever tests there are. They're already written. So I can guarantee you that if you will take a look at what the open source project can give you, you will get something from it. So you will probably didn't think about something or have some idea on how to create a Dockerized test. Also, contributing to open source project can give you personal gains. So it might push you to practice more public speaking, increasing your personal brand and getting your name out there, which is really, really important. if you like, it makes your communication skills better, because if you're submitting a PR or helping a person, you don't know who you're facing with, so you need to explain on all your intentions better. As communication is a muscle, so it makes you practice in it. Getting your pull request merged and accepted is helping you, is giving you a huge confidence boost. So because you work with this product, having something of yours like merged into the product itself, it's like having a huge I'm worthy stamp, and it really gives you a confidence boost. Also, contributing and participating in open source communities can help your career grow. So whether it's an internal career ladder, so it will help you to climb it, or help you with interviewing to other places. So a contributor is something that is really highly valued in our community. It also gets you familiar with great people, whether it's the inventors of the platform itself, or the people around it, people that are going to or speak in conferences. Getting your social circle bigger, it's always helpful. Also, if you will be a contributor to an open source product, you will have an impact on the project itself. So how many times have you fought with a specific missing feature and you had to make in-house tailoring, or fight because with the ecosystem because something doesn't really work or integrate well? So by being a contributor, you can prioritize features or add new features that you actually need, and somebody else might even implement it because the community might be big. So you imagine the power in this. You just add something that you need, that somebody else just do it for you. It's amazing. Also, while being a contributor, you will gain awareness of the project's roadmap. So if you will know when a specific bug is going to get fixed, you will know about future features that might get added, and it will really help you in making sure that your roadmap that gives business value to the company will help it materialize as well. Also, by being a contributor to an open source will get you better support for the existing committers, because this is just the human nature. People are keen to help the people they already know, and by being known in the community, people will want to help you better. So this is a point that you will gain as well. And note for the managers out there, so please free time for your employees for open source contributions. Not only you will gain a happier employee, you will also gain important knowledge back to the company. So you will get an expert about the product, somebody who knows the entire all of the bits and bytes of the framework, and it just will be amazing for your company as well. Getting control over the project roadmap will allow you to focus only on business value. So as I mentioned, you will be able to understand when a specific feature will be added and maybe postpone or your plans, or to adjust them accordingly. Also, contributing to having a contributor in your team will help you to attract top talents to your team as well, because most often than not, the top talents also want to contribute back. So having a hub inside of your company might help you to attract these people. Some final notes. So if you have already deployed a production if you already deployed an open source product into your production pipeline, I think that you can already start contributing. You have already all the knowledge that needs to be in order to start this. If you're waiting for a sign for starting contributing or to participate in open source contribution, let this presentation be a sign for you. Just start doing it. If you don't know where to start, you can join some discussion on GitHub, helping people, support on Slack or helping to add some new features. If you don't know how to start with coding, you can check the contribution guidelines for every repo, and look at issues that tagged with good first issues if there exist. Also, don't be afraid to ask questions. So if you want to start contributing and you don't know how, first thing that you can do is to go to Slack and ask the people for a question like, how can I start to contribute? People are nice and often keen to help, so don't be afraid to ask any questions. I hope that this presentation helped you with understanding the powers of open source communities and how being a contributor can really help you. And just start doing so. So yeah, thank you. I was Alex.
Hello, my name is Andrew Kirkpatrick, and today we're going to talk about how you can centralize legacy auth at the Ingress Gateway. So software applications used to have fairly simple concepts of authentication and authorization. The user logs in, and then is typically assigned a role from a handful that are available, such as, say, administrator, moderator, editor, and so forth. But as applications grow into larger monoliths or distributed systems based on service-oriented architecture, that typically results in more complex requirements for more granular roles and more specific permissions to, say, different groups of users or for specific resources. So eventually, you end up with authentication and authorization logic and data all over the place. So one possible solution to this is to migrate some or all of your authentication and authorization logic and data into some kind of centralized service. And we'll be covering how you can integrate that centralized service into an ingress or API gateway or proxy. So some of the things we're going to talk about today. So why wouldn't you just use an off-the-shelf product? How can you identify and categorize the different authentication types that are in use? What identity and authorization information would you and should you send downstream to your services? Where in this flow would you handle authorization? And how can you actually set up a standalone auth service next to your gateway? So why wouldn't you just use something off the shelf? In a lot of cases, some of the products that you might bring in either assume that you're working on a greenfield or a brand new project, so no pre-existing users or authentication types, meaning you can simply bolt it on in front, and then you use their data store to store and manage your users. However, in most cases, you're probably going to have an existing or possibly legacy project, in which case you've got to consider how easy is it going to be able to add this product into your existing tech stack, whether that be integrated into your code base, bolted onto your existing infrastructure. How would you actually go about introducing an authentication type to your users, your customers? On that basis, how would you deprecate some of the existing authentication types that you're currently using in order to eventually move towards this new authentication type? And the identity and authorization data that you're storing, how backwards compatible is it with some of the newer concepts in this authentication type you're introducing? For example, JWT grants. Additionally, and very importantly, how would you actually migrate or synchronize the identity data that you currently have with this new product? So if you're going to copy and synchronize it across, how easy is it actually to add into the new system? And also, how easy is it to extract it from your current system? If you're going to copy it across, can you just do it all in one go? Or if you're going to try and keep it in some kind of active synchronization, how real-time is that synchronization going to be? How often does your user access and their permissions change in order to keep that synchronization up to date? And how dangerous actually is it if it gets out of sync? From a security perspective, people getting accidentally logged out, having the incorrect permissions at the wrong time. So how would you identify and categorize what kind of authentication types are in use? So there's many different authentication types, right? Here are just some of the common ones, like based on the HTTP authorization header, authentication you might have in cookies, various API keys, and so forth. So is there some kind of way that you can actually work out, if you're using multiple of these, which authentication type is in use, say, based on what path is being accessed, domain or subdomain information, or any information contained within some of the HTTP headers that are being sent. For each authentication type, does it always actually represent the same kind of identity? For example, is it always a user, or is it some kind of other concept in your domain? And how is auth actually configured? For example, if it's within a framework, is it configured in code, configuration files? Is it database lookups? Could be from a variety of sources. On top of that, you could have multiple different authentication types within the same code base, say within a larger monolith, or you could possibly have different authentication types in different services. On top of that, you could have the same authentication type used across your entire platform, but actually implemented in different technology stacks and different languages. So how would you go about figuring out a programmatic way to combine these? So one way is to try and do it in some kind of logical fashion. So can you actually associate different types of authentication based on, for example, if you're trying to go to an admin endpoint, is that based on the domain or subdomain you're using? Or if, say, someone's trying to visit an older version of your API, does that start with a different prefix, use different content negotiation? Some way that you can kind of eliminate some of the types that are used for different types of requests. Alternatively, if that's not possible, one way you could do it is have it in some kind of logical order and try all of them every single time. So say, here are all of the types that I expect to see. Let me try and figure out if it's any one of these ones that I expect to see, and if not, then we assume that they can't authenticate. So if you're handling authentication at ingress, what kind of information would you be able to load up to send to these downstream services? So you're handling these different authentication types. What does the actual underlying data look like? Say, if you're trying to authenticate a user, what does a user look like in your current data store? Can you represent the different data that you're loading for these different authentication types into some kind of similar structure? Say, if all of them represent users, is it relatively easy to represent these users in, say, a JSON object? So most ingress gateways can add headers that have returned from the auth service, and they will attach that to the response that is forwarded to the downstream service. And for example, you could return this JSON object to the ingress gateway from the auth service, and then it gets encoded in a header that then gets passed down. So an example of how that might look like, so we say take HTTP basic authentication. So we have a username and password. The gateway forwards that request to the auth service, which then looks it up in, say, a SQL database. The auth service then builds a JSON object out of that, representing our user in this case. It gets encoded into a header and then attached to the request that is then forwarded to whichever downstream service can then use it to additionally identify the user if they so require. Something to consider, though, especially if you're dealing with larger, more complex legacy systems, is that each authentication type might not necessarily represent the same thing or have the same concepts. Say, for example, you might have some older API operations act on behalf of an entire company, irrespective of user. In some cases, you might have users that look completely different, like some might not have certain properties missing or might have different concepts represented differently. So just try and consider, how can you represent all of these in some kind of common format that all of your different downstream services will be able to understand. For example, say with some kind of common library. So where in this flow would you actually handle authorization? So in a lot of cases, it makes sense to centralize, say, the authentication data in this place, but not necessarily move all of the authorization logic into this central service. So a typical auth response is typically true or false, like I'm either going to allow or deny someone to proceed. So in that case, think of authentication as purely just the identity. Who are they? And then authorization as based on who are they, what am I going to allow them to do? Are they allowed to access or modify or delete this particular resource? And the most basic kind of representation of that is the user logged in or not? So say if a user is trying to update their password, fundamentally the most basic authorization is you can only do that if you have any identity at all, regardless of roles or permissions. So in terms of how that would work on a very broad scope is, say if you had someone trying to access administration endpoints, if you know they're trying to go to an admin endpoint, you can simply check if they have, say, a top level role admin, and then go, okay, I'm not going to actually even forward these requests down to any of the admin endpoints or an admin service because I know that this user doesn't have the particular role required for that. So I'm going to reject and deny this request essentially at the ingress gateway via the auth service. However, as a more complex kind of example, eventually you might get more granular roles, for example, roles for specific resources. And then on top of that, you might end up with permissions for, say, specific resources for specific users, such as an access control list. So say in this example, it might not make sense to move the authorization logic for what an individual user can do to specific documents out of the document service, but it probably makes sense to move the roles and access control list data into the central auth service. So you then have one place where it's loaded, which you can then optimize with, say, caching strategies, and then essentially attach that to the request and forward that for the document service to then decide. So the data is centralized, but you can still retain some of that authorization logic in a decentralized nature. So it can continue to check roles and ACLs as it would previously, if that assists in kind of simplifying some of the migration while trying to take advantage of some of the centralization. So how would you actually set up a standalone auth service next to your gateway? So most ingress gateways or proxies today that are in common use will usually allow you to specify some kind of external auth service that communicates via HTTP or gRPC. Here are some of the more common examples you might see that offer, say, a middleware or plugin that's able to accommodate this. Obviously, there are many more products on the market, but here are just some common examples. An example of how this flow might work. So a request comes into the gateway, is typically forwarded onto the external auth service, usually without the body. So the auth service determines whether it should deny or allow the request based on information in, say, the headers, path, or other request information. Typically, this will then, say, allow the request through, and header modification will either remove and strip some of the headers, or more commonly, it will add some headers, for example, containing identity or authorization logic, as covered in the previous example. An example of how this might work in, say, something like emissary ingress, you set up a Kubernetes custom resource definition that basically specifies, I would like to use an external auth service at this location, and then you set basic configuration options such as what is the timeout, what HTTP status do I want you to return based on auth denied, and what kind of headers to handle. So to summarize everything we've talked about, you can use almost any kind of authentication that you're already using within your system. That just kind of depends on the complexity of porting it over and what software development resources you have available. To try and kind of reduce the amount of checks or lookups you're making to speed up auth and reduce the load on, say, data stores such as the database, try and determine what kind of authentication types you're using for different paths, domain, or header combinations. You can then pass the identity or authorization information that you've loaded up onto your downstream services. And it's worth considering how you can kind of best represent that information in a kind of common and consistent manner. You can then handle none, some, or all of your authorization in this central auth service, depending on what suits your use case and what makes sense from a kind of practical standpoint. And then something to also briefly touch on is if you're going to move towards using a central auth service, worth considering what your service level objectives and indicators are around reliability and uptime for this service to ensure that it's highly available, because that will now stand in the critical path of requests to different parts of your platform. A brief bit of information about me. I work for StackAdapt, which is a programmatic advertising platform. We're always hiring, so if you're interested in tackling engineering challenges at scale, please feel free to visit our careers page. So thank you very much for listening. Hopefully this gives you some ideas as to how you might be able to centralize legacy auth in some of your projects. The slides should be available online, and if you have any questions, please feel free to reach out. Thank you again, and I hope you have a wonderful rest of your conference.
Hello, everyone. I'm Asim Razak, and I'm really excited to be presenting here at PlatformCon. In this presentation, we'll be talking about how to get FinOps right without destroying agility. Unless you've been living in a cave, you've probably come across this term called FinOps, especially if you have some significant workloads in public cloud, since in that scenario, you really have to make the economics work out for you. So before we dive into the details, a little bit about my background. I'm the co-founder and CEO of Euroscale, a company that has a product for cloud cost management, and it is trusted by some of the best engineering teams in the world, including Hulu, Zoom, Okta, and Klarna. And prior to that, I was the head of platform engineering at PayPal and eBay, where my teams were responsible for all the core infrastructure that did logins or payments. Needless to say that it was quite exciting and nerve-wracking at the same time. And before that, I held several positions in terms of engineering leadership at early stage, mid stage, late stage startups, primarily focused on this software infrastructure layer, also known as the internal development platform or platform. And so that's sort of been my bread and butter and what I've focused on throughout my career. So in platform engineering, we all know that we're responsible for making sure that the platform itself is reliable, performant, and secure. I mean, certainly those are key KPIs. And we're also making sure that the teams at the edges, application teams, services teams that we are enabling are also are able to build their products reliably, performant, and secure. But there is this fourth KPI that has entered into the equation when it especially comes to public cloud, which is a shift from CapEx to OpEx. CapEx meaning you own the infrastructure, you don't have to worry about a monthly bill, and OpEx obviously is increasingly subscription-based. And so cost is this new requirement. And whether you like it or not, you either have to deal with it now or you have to deal with it in the near future, because that is where all of this stuff is headed. And so it really becomes about how do you start making the right trade-offs, because the health of the business, the health of your company, the health of the organization can be impacted quite significantly if this is not correctly reeled in. And so challenge that we see a lot of times in this scenario is that FinOps and CI/CD/developer productivity, they are poised for a face-off, right? So the key points here we'll go through from the top and we go clockwise here is that finance has become a very critical stakeholder, because if you got a public cloud bill that is significant, that team is trying to figure out where is the money going, who do they attribute it to, how do they think about profitability, how do they think about margins, and again, back to that financial health of the company. And usually because of lack of a framework and product and process, they're sifting through invoices, they're sifting through billing data, and working with old data and grokking and getting a sense of what's going on from that. Then it's about trade-offs, right? So the platform team has been focused on developer productivity and just release velocity, but there has to be this trade-off and alignment in making sure that the economic efficiency is key, because not only do you have to deliver all the tools and capabilities for teams to build their software faster and the other three KPIs, but also more economically efficiently. And a lot of times dev teams and application teams, they don't think about cost upfront, but there has to be this shift left where there are ramifications as a result of the architecture that you're using that need to be thought through. I mean, you've heard about security shifting left and some of the other things shifting left. I mean, this is not different when it comes to cloud cost economics, that it has to start shifting left, and upstream, you need to be thinking about the economic ramifications of your decisions. And then finally, because of lack of frameworks and information and process or education, the application teams, platform teams, and the finance teams, they have a lot of friction because they're all trying to do the right thing when it comes to their perspective and context, but they just get pitched against each other because the platform team is pushing towards focusing on developer productivity. The application team is trying to get their feature and set of features out fast, and the finance team is just pulling their hair out, trying to figure out why everything is costing so much, and that are we headed towards a bankruptcy situation or not. And so in a lot of companies that have significant workloads in public cloud, where it is increasingly becoming the second biggest line item after payroll, there is this phenomenon called bill shock, right? Which is there comes a time where there's a month where you receive a bill which is significantly higher than the prior bill, and you don't really see any fundamental change in the business or how you're operating, but you're scratching your head trying to figure out why is this thing 50%, 100%, 150% higher. And this leads to this thing called CSI crime scene investigation, which is where the finance team comes and asks a bunch of questions of platform engineering or application teams, trying to figure out why did we spend so much money, what happened, who's responsible. And then eventually, through all the back and forth and spreadsheet sifting, you realize there is some team that ended up spending a ton more than I guess they were supposed to. And that team then starts doing an investigation, realizing in some scenarios that they spun up a bunch of machines in anticipation for some increase in user requests or load, and that they forgot to spin them down when for a day or 2 or 3 maybe that load basically stabilized. And so there's all this back and forth, and you still have this information in the back view mirror. And then in the future, similar stuff happens because it's not easy to keep tabs on millions of cloud resources that are moving around and on an ongoing basis. The manual process is constantly going to break down and not work. So the point here is that FinOps and engineering, they need a common language, they need a common framework. This new entrant needs to have something where there is that collaboration, because engineering is speaking engineers, FinOps is speaking their own language around COGS and margins and profitability and things of that nature. And engineers kind of feel like, well, how do I become a cloud cost economist in my spare time? So you have to have the right tools where that can analyze the data. You have to have transparency, and you need to have those combined shared metrics, right? So things like, first of all, starting to understand where the money is going, right? Are we going to look at things at an application level, at a service level? What is the key metric for the organization that you focus on? So it might be the transaction, the cost of number of transactions per second. It could be a number of logins per second. I mean, whatever KPI makes sense for your business, I think it's important to have that common KPI. And then you connect back all of the infrastructure, application services back to that KPI, and try to make sure that you are being efficient. Then you can allocate budgets. You can help teams forecast where the money is headed, just so they can stay within those bounds and those guardrails. So I think those KPIs, that notion of budgets and forecasting, and having that framework is very, very important. So there is that environment of collaboration. And so building a culture of cloud cost ownership is very important. As everybody knows, that habits and culture are what really define the success or failure of an organization. And so I usually refer to this book called Drive by Daniel Pink, in which he talks about this concept of intrinsic motivation and extrinsic motivation. Extrinsic motivation is something where there is something like you'll get a salary increase, or you'll get a bonus, or you get a promotion if you do something, right? And the thing is that extrinsic motivation can work to a certain level, but it cannot motivate people on an ongoing basis. So this intrinsic motivation is important, and the 3 key pillars of that are autonomy, purpose, and mastery, right? So if we apply this to FinOps or cloud cost economics, then autonomy would mean that you're enabling teams, right? So you're letting teams know and help them understand what their piece of the puzzle is, how much it's costing them to run a service or an application, and what is the budget that they should be focused on. And once that is set, it's up to the team how they make decisions and decide how they're going to keep it within those parameters and within those guardrails. So nobody wants to be micromanaged. Nobody likes a stick. Nobody likes threats, right? And nobody likes random requests that don't make a ton of sense, right? So autonomy is important. The second one is purpose, and purpose is back to context, right? Why are we doing this? Why are we focused on cost, right? When we're saying, on the other hand, we have to deploy stuff fast and we got to migrate everything into cloud, or the competitor is going to kill us if you don't do X, Y, Z in terms of capabilities. So the context here needs to be set. As we spoke about, I mean, there is a higher level KPI. It's the financial health of the business. What does that mean? That means that we're spending a ton of money in cloud. We're not making as much money in terms of our revenue, so the profits are really low. We might have to do layoffs down the road, and especially in this macroeconomic environment, being very fiscally conservative and efficient is very important. So you got to set that context for those teams as to why the ask is there for them to be fiscally and financially efficient. And the third one is to motivate teams around mastery, right? So skill is important. And the skill of not only being an engineer that builds software that scales in terms of performance and reliability and is secure, it also is a skill that is extremely valuable, that you're able to run economically efficient software. It makes you a better engineer. It makes you more valuable to the company. It increases your ability to be more marketable, right? So I think those three ingredients in your own context need to be there, and you need to connect those dots for your teams. And realize that cloud cost ownership is a journey. It's not a one and done, do it one time and then you're good to go, right? But it starts, number one, with visibility, right? You can't really improve anything that you can't measure. So understand, what are you measuring? What's your context, right? Are you, again, looking at things at an application level? Maybe they connect back to products, they connect back to business units. And I think within that, you have to make sure you have a product or a framework that's helping you give that visibility on an ongoing basis, that it doesn't become a huge exercise every month to try to gain that visibility. And from there flow number 2 and 3, which is how do you make sure that your costs are predictable? Because nobody likes surprises, right? You're trying to avoid surprises, because the CFO office and the budget owners, I mean, they have all these models, right? And if things are just haywire and then moving randomly, then it's very hard to keep to those models, and then there are financial ramifications of that. So if you can help teams forecast where the money is going, so they can take action ahead of time, they can respond to things instead of reacting to stuff that's happened in the past, that's key and critical. And then the final step is, then you can have continuous optimization, right? Once you understand what's going on, once you understand what the larger picture is, then you can take steps that can make those trade-offs around how do you run things more efficiently, how do you optimize things, how do you right-size certain workloads, how do you schedule just so certain machines are not running at night versus daytime. I think those are all decisions that one can make. And you have to build a culture of FinOps agility. I mean, I use that term very deliberately, because a lot of times something like FinOps can be looked upon as you are going against agility. But if you really, like anything, have it embedded within the culture, you have the metrics, you have the products, you have the frameworks that really allow you to have this and be an embedded part of how you operate, then a lot of great stuff can happen. So again, you have to evangelize this. You have to make sure that people understand the importance of financial accountability, just the way they understand the importance of accountability when it comes to security and reliability and performance. You have to understand how your larger team is really focused on FinOps. What does that mean to you? What are those metrics, and how do you get better at it over a period of time? You have to pay attention to these architectures that can be extremely expensive. So what are trade-offs you can make? And you have to always make trade-offs, right? In order to have a good decision, there's nothing in life that is one-dimensional. So you have to really, once you have all of this information and this data, to work with the stakeholders to say, look, we can run this at a lower cost, but here is the hit on performance. Are you okay with that, right? And in some scenarios, that might be a perfectly viable solution. In other scenarios, it might not be a viable solution. So you have to be strategic about it, and then evangelize this, right? So figure out who are the people who care about it the most, and they can be evangelists of this fiscal responsibility and this fiscal efficiency, because that's how you're going to build this culture. And you have to build this through a place of inspiration, not what I call a place of perspiration, which is like just beat people down and say, well, you got to do this, right? So come from a place of inspiration, how this helps people be better engineers. It helps the stock of the company for a public company, or it helps the general health, financial health of the company. You can be more competitive if you really reel this in and are really focused on it. So, if you want to reach out to me, ask any questions, you can do that on alwaysengineer.org. I have a podcast with the same name. And in fact, I did a great podcast with Luca Galante, who runs the community here at Platform Engineering. So do check that out. There are other podcasts there as well. And I really look forward to hearing from you and getting your feedback. Thank you for listening, and I appreciate your time.
Hi everybody, my name is Chris. I'm the VP of Engineering and co-founder of a company called Syntasso, where we work with our clients to help them treat their platforms as a product. And we're also behind Kratix, the open source framework that enables platform engineering teams to build their platform their way. Now today, I'm going to speak a little bit about Backstage and why Backstage alone does not make for a great platform. Now, we're all here today at PlatformCon, hopefully here to learn about the latest and greatest technologies and patterns and thought leadership in the platform space. And we're doing this because we want to offer a better experience to our users, the application developers, and various other users of our internal platforms. Now, simply put, a platform is a set of self-serve products that serve or enable other product and services teams within organizations to move more quickly. In the past few years, there's been an explosion in the platform engineering space. We've seen tools emerge, we've seen patterns emerge, we've seen thought leadership emerge, and we're seeing more and more platform teams form within organizations. We're seeing investment in platform engineering teams go up over time. It's really great to see. And the reason we're doing that is because organizations are all chasing that platform dream. Everyone's looking at ways to reduce costs. If there's a pattern or a service within an organization that can be consolidated and not kind of reproduced across many application teams, that's a great opportunity for a platform team to take that service on board and run it in one single place to serve back to users. It's an example of how costs can be reduced. All organizations today are looking to increase their speed. We're all trying to move quicker, innovate quicker, get products to market quicker, so we can outmaneuver our competition. Everyone in the tech space these days is looking to go faster. And we're all trying to reduce risk. I'm sure we've all heard the horror stories of companies releasing unpatched software into production, unsecure software into production that can be exploited and companies can be taken down. These days, we all need to reduce our risk, and platform teams are a great way of doing that. If security patterns can be properly encoded into workflows provided by platform teams, it means there's one less thing for application developers to think about, and the security organizations within companies can be sure that their kind of security risks are being taken care of. Now, unfortunately, the pragmatic reality of being in a platform engineering team does kick in. It's not all rainbows and unicorns in terms of the platform dream. I'm sure everybody here will be very well aware of the amount of learning curves there are in the platform engineering space. We're all learning day to day. We're all learning things ranging from public cloud to on-premise cloud, VMware. We're looking at learning Terraform, we're learning Chef, we're learning Ansible, we're learning Bash, we're learning Golang, we're learning Ruby, and that's before we even bring Kubernetes and all of the various kind of operator patterns and Helm technologies, and literally the list goes on and on and on in terms of learning curves in that platform engineering space. It's fun, but unfortunately that learning comes at the cost of productivity sometimes. Now, on top of that, platform engineering teams are also trying to keep their platforms running. They're trying to keep the services that they offer up to date with the latest security patches, with the latest features, because ultimately we're trying to keep the users of our platform happy. So we need to get the features into their hands so they can go off and build what they need to serve their customers. On top of that, we've got security patches. Everything needs to be secure all of the time these days. Platform engineering teams are having to worry about the workflows of keeping things up to date and the automation of all of that stuff. Another example of a learning curve there. Now, on top of workflows and technologies, we also have to keep our stakeholders happy. Our stakeholders are not just the application developers using the platform. We also have stakeholders such as billing and the accounts teams who want to make sure that all of the public cloud usage is properly tracked and so it can be charged back. We have audit teams who demand that certain audit boxes are checked before software makes it into production in certain sectors. Again, just all examples of cognitive load that platform engineering teams have to take on board that prevent really rapid progress in this space. On top of all of that, obviously, there's going to be a skills gap because it's next to impossible to hire platform engineering team members that have all the skills that we've just gone through. There's a real demand for a real small set of resources right now in the industry. So there we have it, all examples of cognitive load that the platform engineering teams are having to take on. All examples of things that get in the way of platform engineering teams moving quickly. And ultimately, the result of all of that is that we're not solving our customers' needs, and not solving your customers' problems really sucks. It effectively leads us to having low job satisfaction. So what do we do? Well, we're engineers, so we all look for silver bullets. We look for those tools, those technologies, those design patterns that we can bring in that solve many problems all at once. In the platform engineering space, we've seen silver bullets come and go in the shape of, for example, Cloud Foundry. It's a great platform as a service technology. It really, on its day, could help application developers push and get code into productions really quickly, but it came at a cost. It was big, it was cumbersome, the learning curve was absolutely huge. It was very, very difficult to customize. We've seen silver bullets come along, such as Kubernetes. Again, everybody on Earth now runs Kubernetes in one shape or another, but it doesn't come without its costs. We could do a whole platform team talk on Kubernetes alone and some of the costs that come along with it. It's not a silver bullet. It's a great tool for building platforms, not necessarily a great abstraction to offer your developers to enable them to go quickly. Another example of a silver bullet that's come along recently is Backstage. Now, Backstage is a great user experience for platform teams to offer to their users. It's come out of Backstage in the last few years, and it offers a real powerful framework for you to declaratively create your UX for your platform. So you can offer that real consistent experience to the users of your platform. Now, the Backstage dream is you spin it up, you put it into production, you point your users at it, and off they go, and they have a real great platform experience. But unfortunately, the Backstage reality is also real. You have to figure out how to architect it, how to deploy it. Do you run Postgres to store its state? Do you run Redis as a caching layer? Do you run the in-memory caching layer that it ships with? You have to figure out how to deploy its front end and its back end. On top of that, you have to secure it. You have to keep it up to date. And that's before we even get to the customization side of Backstage. To customize it, you have to learn React, you have to learn JavaScript, HTML. Again, yet more learning curves that your platform engineering teams have to take on. On top of that as well, if you don't get your design patterns right, you can really blur the abstractions about which area of your platform is responsible for which job. Again, all examples of yet more cognitive load that your platform teams have to consider. So yes, although Backstage can come along and solve a certain set of problems in the UX space, it doesn't come for free. It comes with a huge learning curve, and it can be powerful if you consider that learning curve correctly. And it is powerful. At Syntasso, we're huge fans of Backstage, and we've built some open source integrations into Kratix that we'll get into a little bit later. It's an immensely powerful platform, and you shouldn't discount it. Now, a really good example of an architecture for Backstage is kind of shown here. So Backstage itself ships with a tremendous amount of plugins that allow you to adapt your front-end Backstage views of the world to your back-end platform concerns. It has a really powerful plugin architecture. So you might have plugins that help you orchestrate your public-private cloud from your Backstage. You might have direct plugins to help you drive Terraform from Backstage. You can build custom plugins that allow you to customize Backstage to drive your internal systems. It's super powerful. But if you're not careful, you can end up with a very leaky abstraction in terms of your platform. You can end up with your Backstage having far too much knowledge of how your Terraform is supposed to run. You might have far too much knowledge in there in terms of your public cloud. Backstage isn't great, for example, at keeping everything super secure in terms of credentials. So you might have a security kind of hole kind of in there if you're not very careful. The point here is you need to consider your abstractions very, very carefully in your platform.
I'm not sure I understand.
You need to make, sorry, Siri's going off. So we all have to consider the abstractions of our platform very, very carefully. We need to make sure the right area of the platform is responsible for its responsibility. So in terms of Backstage, it should be responsible for the view aspect of the UX of the system. In terms of the kind of controlling the back-end system and orchestrating that back-end system, there's probably a better technology out there that allows you to kind of drive that. Be very careful about pulling too much platform responsibility into Backstage. Else, your cost of development kind of increase. You might find yourself writing Backstage plugins when all you want to do is kind of change a subtle workflow and how your Terraform is deployed. All of this leads to high cost of change. For example, if you decided you wanted to throw Backstage away and bring in a better technology, I'm sure it doesn't take too much of a mental leap to kind of imagine the costs there if your Backstage has too much knowledge about how your platform runs. Equally, you may choose to keep things very, very separate. And in that case, drift might happen. If you continue to invest in your platform abstractions and you make your platform abstractions the canonical kind of source of truth in terms of how your platform works, and you don't keep your Backstage up to date with those new workflows, you'll find that your Backstage drifts away from your platform. And all of this will reduce in drop in terms of adoption. And this is not good. This leads to shadow IT. It leads to kind of underinvestment in your platform engineering teams. It'll lead to unhappy developers. Not great patterns to see in your org. But what does good look like? You should absolutely use Backstage. I'm not here to bash Backstage at all. I'm here to communicate that you should pick the right tool for the job and make sure that that job's responsibility is clear. So in terms of Backstage, a great model looks like where Backstage is hooked declaratively into a platform abstraction that can drive Backstage on your behalf. So Backstage has a great declarative model. If you can have a platform that can declare the state for your Backstage, you can keep the two in sync via your platform abstractions. And Backstage is not unique here. This talk isn't really about why Backstage is not great for platform building. This talk is about choosing your dependencies carefully, being very, very clear with your architectural decisions. Consider your pros and cons, and always keep in mind that platform dream, because your platform dream can be real if you select the right technologies for the job and you really architect to enable those technologies to do the thing that they were designed to do. Your platform experience can be very, very powerful, and you can keep your users very happy. So consider your investment. Always, always bear your users in mind. Select technologies that are going to help your users, not help your CV. Always consider your organizational speed. We're all trying to go fast here. We're all trying to keep our costs down. We're all trying to reduce risk. So pick the right technology for the job that was designed for the job that it's doing. And if you do all of these things, naturally, you'll start to keep your team's cognitive load down. Now, Kratix, a framework that I touched on very, very earlier in the talk, is a framework that allows you to build your platform your way. Now, Kratix is a great example of a technology that can sit at that platform layer and help you orchestrate your Backstage view. So Kratix has built-in plugins that will enable you to drive your Backstage UI as you load capabilities into your platform using the Kratix concept of a promise. So by using Kratix, you get a lot of your Backstage UX declarative for free. You can check out Kratix at kratix.io. There's quick starts on there that will allow you to get up and running quickly, and you can see the Backstage integration in action over there. So thank you for listening.
Hi everyone, thank you so much for joining my talk, and this talk will be about technical documentation. How can I write them better and why should I care? And when I say I of course also mean you. But first of all, hi, my name is Hila Fish. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. I help organize conferences in Israel where I live, DevOps Days Tel Aviv and StatsCraft Monitoring Conference. I can say a lot of things about myself, but I only have 15 minutes to cover this massive topic, so let's get right to it. So I believe that anyone can and should write technical documents because, for example, in the middle of the night when I have a production incident to handle and I don't know what to do because this is something that my team member implemented or something like that, then I need a run book to help me understand what's going on and what are the use cases and what should I check. So if I have a helpful run book, trust me, I don't care if the English in that run book is fabulous or a broken one. As long as the run book is helpful and concise and clear, this is all I care about. So knowledge is what matters here. So that's why you should always write technical documentation to share your knowledge that you have. So what can be considered as technical documents? In my experience and in my opinion, not only system logical design, but also on-call runbooks, as I just mentioned, code readmes, onboarding documents, project planning documentation, and also Slack pin messages. If you write something that is helpful and conveys knowledge, then it could also be considered as technical documentation. And you don't have to do everything in this list. As long as you do some or a few or something, it will be very, very helpful for you and your people and the people that you work with. So this is where I usually ask the people at the audience to raise their hands if they ever said this sentence before or heard it before, that your code is self-documented. So a lot of people say that, hey, just read the code and understand what it's about, or the code tells a story, right? It's not the case. It never is the case. You need to document your code, intentions, reasoning, a lot of things, document your systems in order to really understand what's going on and history and stuff like that. So let's understand why even write technical documents. So first of all, to reduce your work volume. And then you can say, hey, reduce, if I sit down and write documentation, it wastes time and not really reduce my work volume. So think about it this way. I, as a DevOps, get approached by a lot of people, QA, dev, etc. And they ask me a lot of questions that are repetitive, like how to troubleshoot pods in Kubernetes or stuff related to internal stuff at work. So I, in my previous job, gathered all the repetitive questions and I created a tips and tricks by DevOps document. I passed it along with a Zoom meeting to go over it. And then after I released it, from 7 or 8 times a day that I was approached, it got reduced to 1 or 2 times a day. So this is awesome. You can do this. You can detect other things that you can do in order to reduce your work volume in the long run and stuff like that. And also it will help you communicate things to your managers, the extent of your work. If you document it, then they understood what's going on and what did you do. Convey that you're a team member, a team player, sorry, and really a team player and not just something that you write in your CV. Also, technical documentation is good for self-service enablement, like onboarding documents. Then you can onboard yourself and you don't rely on your buddy. Increase the velocity. So, for example, I migrated our code base in my previous job from Bitbucket Cloud to a self-hosted GitLab, and I created a document to help the developers to adopt GitLab faster because they didn't know anything about GitLab before. So anything that could help the velocity to increase it, like the document with troubleshooting and even Slack bots that help with Q&As, stuff like that, could help with self-service enablement and to increase the velocity. Eliminate production incidents quicker, as I mentioned at the beginning. If I have runbooks to rely on and to help me solve some issues, then it will be awesome. It will not only help solve the issue, but also decrease mean time to resolution and help the company meet their SLAs, which is very important. Avoid single point of failure or a bottleneck, which is you, because you tell me, do you really want to go on vacation and still be available for work calls? Or do you want to go on vacation with a clear head, right? Job security is dead. Everyone needs to acknowledge that and share the knowledge as much as possible. It will also help make things clear for you or the future you, because once you structure things and write them down in a clear manner, it will organize it in your mind as well. It will help with visibility of the things that you do. It will attract focus to the things that you do at work, which in turn will help you progress your career. And it will help you understand why we're doing things in a certain way. Like I can cover in a document, why did I set certificates here? Or why is this model complex? Or why did I choose to do things as X instead of following clean code practices like do not repeat yourself and KISS? So with documentation, we can defend the decisions that we are taking and to communicate them to others. It will also help develop your business mindset and make you a better engineer, because always asking why will result in you striving for the best solution or implementation. And why do we usually ask whys? When we think about things and we need to structure them, and exactly stuff that happens when we sit down and write documentation for our systems or for our code. So let's cover here now how to write technical documents without being a technical writer, right? Because we are engineers, we didn't learn the aspects of that. So let's see how we can do it in a simple way without being a technical writer. So first of all, we need to know your audience. Based on your audience, you will know what needs to be covered and to which extent. So whether we write documentation for internal use, like system design, or external use, like an API documentation, for example. So we cover different things based on the audience that reads the documentation. So for internal use, maintainers of systems or code, for example, we need to cover things that you worked on while working on them, because we remember things better when they are fresh in our minds. Things that bugged you. For example, I created a document for the GitLab migration that I did, and I covered how to open a GitLab ticket for their support in a way that will avoid ping pong between me and them. And it saves them time, and I save not only time, but also valuable, how would I say that? It bugs you, right? It just bugs you. So if you can do and prevent people from getting bugged, that's awesome. And also things that aren't clear or straightforward, like in that GitLab migration that I did, I used a certain DB version, which is not the default one. Why did I do that? I need to document it in order for people to not only understand why I did what I did, but also not to revert it because they thought it was a mistake or something like that. For a document for external use, like for users or consumers, you need to write about the things that you are writing about, like what it is about, possible use cases and quick start, any quirks, issues, and things to consider while using this X, and examples like simple and complex examples that will help your user adopt whatever you're writing about. The next phase of writing a technical document is to decide or abide upon a documentation type that you have at work. So either you use documents in knowledge base like Confluence, or you adopted a docs as code, which means that you interact with documents in your IDE, and docs are fully integrated into the dev toolchain. So either you can move to docs as code, as I recommend, or you have to abide and stay with documents in knowledge base. Just go with whatever is possible. And these are some general content guidelines in either knowledge base or documents in docs as code. So first of all, you should have table of contents in your document that you write about, in the document that you write. And why is that? Because this is the user flow. User search for something, so that's why you have to have meaningful titles and subheadings to help them find stuff that they need in a very or close to accurate kind of thing. Once they find something, they scan a document to see if this is what really they search for. If so, awesome, they got the result. If not, then they will navigate to a different link. So you should also put links to other documents that could be helpful for the user. Highlights. Use bold as much as possible to highlight things that you think that are important. And as for colors, this is a bit controversial because some people have accessibility issues, color blindness, and stuff like that. But in my experience, I did find out that it helps. People see more clearly if it's in red, something to be aware of, except if it's in red, except and not just bold, right? So that's that. In terms of words and sentences, make sure you use short words and more sentences rather than longer words and fewer sentences, because that way you will help people skim over the document much more quickly. And please, please, please use simple English, okay? Don't try to be Shakespeare. Just write simple American English that non-English speakers can easily understand. In terms of docs as code and why you should move to use that, is it is Markdown, so it's awesome and very simple to use, because you can still use table of contents and highlights and even colors. It is plain text, so it is human readable. It is easy to write in diff, and it is platform agnostic, so you can incorporate it wherever you want. The documents folder is in the same code repo, so it is integrated in the dev toolchain and no need to leave the IDE. And you can do a PR review to make sure that the document is in high quality and the document even exists. And if not, the PR will fail to merge because the people didn't add a documentation. And you can do even CI/CD for documents to make sure there are no broken links and linters, and to do certain validations. You can do it with Docosaurus, which is a tool. You can do it with Swim, and I'm sure that there are a lot of tools that you can use in order to achieve that. The next phase for writing a technical document is to remember your audience. Okay, so first of all, we thought about we understood that there is a user flow that we need to consider and take into consideration. Now we need to have this user flow in mind, in and between sections, and make sure that the document order is written in a way that is from the most used things to the rarely used. So GitLab, for example, how to upgrade, they release a lot of versions, so probably people will upgrade, the team will upgrade more than create new integrations. So this is one example, but just have the user flow in mind to help them skim over the document as quickly as possible. Concept versus tasks. This is very, very important. You need to really think about what your audience wants. If they want to know something, aka concepts, then you need to write about information, background, explanations, reasoning, intentions, or the whole works. But if they want to do something, aka tasks, not concepts, I don't know if I said at the beginning concepts, I don't remember, but to know concepts, to do tasks, then the document should basically be a how-to document. So don't confuse the two, okay? If someone wants to do something, at this moment, they don't care about the information or the background to whatever led to this system. So just have links and help the users achieve whatever they want to achieve and send them back to their tasks as soon as possible, and just have links to other information that could be useful for them. And last but not least, share the document that you write with others, have feedback, okay? And why is that? Because sometimes you write things and you know a lot about the system that you're writing about, but other people don't, and then they will read it and maybe more questions will pop up, or they'll say, hey, I don't understand quite what you meant here. Can you please elaborate or write it in a different way? So feedback is very, very important to help understand if your document is very clear and concise and helpful for your readers. And don't try to read this slide, okay? This is only a slide to take a picture of, and this is intended for you, the people that wants to write in a higher quality English. So if you do want to perfect your English, then here are some writing tips from a colleague of mine, which is a technical writer. And this is how you can make your document in a higher quality state, English-wise, structure-wise, etc. So basically, this is it. And even if you're not a technical writer, have this golden rule in mind that you need to provide readers with the information they need and send them back to their task as soon as possible. The documentation that you write should be clear, simple, and to the point. And tip for managers, in order to make sure that the documentation is written and is part of your day-to-day, make it an integral part of a task, aka the task's definition of done is when documentation was added, and then and only then the people can close their tickets. So I hope that now you can say that your code is well documented. Thank you so much, and if you want, you can follow me on LinkedIn, Twitter, and I share more on this topic and other DevOps topics. Thank you.
Hi everyone, my name is Vilas, and I'm going to be talking about how to invest in developer experience with a goal to reduce barriers for continuous delivery. I'll start with a little bit about myself. For the last decade or so, my focus has been on improving developer productivity. So I focus on enabling developers using continuous integration, continuous delivery, pipelines, providing them with tools to improve the quality of their delivery. I've also practiced chaos engineering for the last 10 years or so. And my current passion is around performance testing and analysis and learning more about cloud costs, optimization, how to use those tools well. So before I go ahead, I want to provide a statement and then we'll delve more into that statement. DevX is not DevOps. I want to make sure that we look at this from a perspective of what DevX really is. DevX, in my opinion, enables DevOps. So that begs the question, what is DevOps? And then we'll talk more about the definition of DevX as well. So for me, DevOps is a set of practices. It is a set of principles. It provides you with a set of rules that allows you to push forward value to your customer as soon as possible in the safest way possible. It's not the name of a team. It's not the name of an organization that does the deployment for somebody else. It is about using CI/CD as it is truly meant to be, continuous integration and enable. This means that the developing teams own not just the build, the test, but also the deployment as well as the monitoring in production to learn from it. So really the cycle is you develop, you test, release, which means the value is now flowing all the way to the customer, and then you repeat the entire process. So in a way, DevOps is about flow in the system, and it's about the value stream. How do you enable that for a given product, and how does the development team enable themselves to do that? So what is developer experience? Developer experience is all about allowing the developer to feel joy as they contribute their code into this process. It's about enabling them so that at no point they feel that there is any friction. So it's about removing that friction and giving them tools to check in code quickly, to build quickly, to have rapid pipelines that get to production, but at the same time providing them with good feedback that they can act on that can potentially help their customer. So DevX is automation, tools. It should be simple and easy to use for any developer, as self-service as possible. So you do not have to file tickets, wait a bit for someone else to help you, etc. It allows developers to make changes with confidence. And if they run into issues, they can debug fairly easily. So before I jump into what DevX looks like for today, let's talk a little bit about the history. Evolution of software delivery from the 2000s to now. I'm going to very quickly talk to you about what it was in the 2000s. So delivery in the 2000s, early 2000s or to late 2000s was a longer release cadence. When I first joined and started working for my first company, it was about a 6 to 12 month release cadence. And sometimes we would ship software on CDs and it would be tarballs and things like that. There used to be a 2-month QA and certification cycle. So very over the wall siloed approaches, very waterfall, very few agile adoptions. Many companies started adopting more and more agile methodologies towards the end of the decade. And by the time AWS came out, which is about 2006, 2007, that's when people started realizing, hey, we can actually use cloud, but there's barely any cloud adoption large scale. So DevX in the 2000s was limited as well. Developer experience was about, there would be a team called core services, which would provide common libraries. It would say, hey, if you need something that is common, we will write it and we will provide it for all the teams that need to use it. There were good IDEs, right? Eclipse, Visual Studio, popular ones come to mind. There were build and test systems which were written, which used to run as part of the continuous integration service. So Maven was a popular build system. Hudson, which now is known as Jenkins, was a continuous integration server. This was DevX. This meant that delivery was not as fast as we needed it to be for the 2020s. So today, delivery is demanded as often as possible with high quality. What does that mean? It means daily, hourly release cadences. The expectation is for the development team to be doing full cycle development, which means they write the code, they contribute the tests, make sure that it is valid in terms of the acceptance criteria provided by the product managers. They release it and they monitor the traffic for any issues in partnership with SREs. And if there is any learnings, they will fill that right in and the code cycle continues. It's all about optimizing the value stream for the product. And there is heavily cloud native deployment. So what kind of investments in DevX would give us that kind of improvement in delivery? I'm going to focus on 3 different aspects of the dev lifecycle. One is onboarding, when the dev comes in and starts working at a new team or a new company. The second is their day-to-day. And the third is when they indulge in large-scale refactoring or modernization projects. Let's focus on onboarding first. Currently, most companies have a process that goes as set up your computer, get training on the code base, get access to the right kind of cloud solutions, and then write your code, check out the code, write your code, compile it, and then eventually you check in something that is a contribution to the company's code base. This process can sometimes take longer than 3 months. In some companies, it can take up to 6 months, depending on the training and the access and things like that. A lot of tickets going back and forth, lots of back and forth in terms of what code base you can contribute to, etc. Let's imagine what investments can change this. An automated workstation setup, along with sensible defaults and rapid prototyping tools that come in baked into the laptop, tend to be make things easier. Imagine if a developer could just open their laptop the first day and they could find all the software that they need already on the laptop, along with all of the instructions to use it. Right? So streamlined self-training modules. And most companies do this, which is an onboarding buddy. The proposal that an investment can be made in is to actually have an onboarding buddy share responsibilities for the first week, so that at the end of the first week, they can release small changes to prod. Doesn't have to be a huge sensitive change. It can be something as small as a bug fix. It could be something that could be a small change that does not affect customer flow. So ideally, we could get this down to 1 week, right? Where we could have a computer setup. And this is something that is possible, and we have done this in the past. You set up, you train on your own pace in the first couple of days, you check out code, you commit your first change within the first week, and it's released as soon as it's committed into the merge train. Let's move on to day-to-day. So now that the developer is onboarded, they are now contributing day-to-day. And during the day-to-day, they are building, they are refreshing their setup, and they want to make sure that the pipelines are running optimally. So investments that DevX teams would make in is to make sure that the CI/CD tooling availability is high. At any point, if the CI/CD pipeline isn't working or is not resourced well, then you cannot push innovation quickly to production. Your customers might be waiting for something that is not delivered on time. If there is an issue, they may not see the fix as quickly as possible. Code to test to deploy, ideally within 60 minutes. That's 1 hour. Performance testing and tuning within the pipeline, and observability across every single stage of the pipeline, from test to stage to production and beyond. This is all of the investments we need. In short, this is the picture, right? We plan along with the product owners, the team then codes it. There's verification, profiling, which is performance testing, maybe resiliency testing, chaos engineering, deployment to to, like blue, green, red, black, whatever the environments are. Production monitoring then finds issues, which are then coded back into the fixes for which are coded back in. And this cycle continues. This is the day-to-day. Let's focus on refactoring. Refactoring is crucial when there is either a large piece of the code base that is sensitive and needs to be broken up into smaller pieces, or it needs to be rewritten for different factors, or it needs to be updated in order to reflect the newest and best technologies. And this can be a very hard job for any dev to do. They will depend on the setup that's provided in order to make sure that they can trust their own changes, which means the investments in DevX have to be in quality gating and guardrails. They need to have top-notch debugging tools. They need to have great security and compliance checks, because you do not want to introduce new vulnerabilities while you're trying to fix things. You need to have solid code coverage thresholds so that you can stop if there is any issues with unit testing. And you need to have code visibility so you can understand the complexity, map it out visually so that you can learn more and then contribute back. These are investments in refactoring. So we talked about 3 of these areas. Let's talk a little bit about, if we made these investments, would there be a return? What is the return on investment? So let's take a theoretical scenario. Let's say we have about 50 developers in the company. For onboarding, we talked about we could save onboarding from 3 months to about a week. That's about 10 or so weeks per developer of onboarding savings. A daily savings because of shortened pipelines, reduced time to debug. So let's imagine your pipeline goes on 50%, from 30 minutes to 15 minutes. Your debugging time goes from half an hour to 5 minutes. Your changes no longer require multiple JIRAs and approvals. On average, let's say it saves an hour per dev. For about 200 productive days in a year, that's about 200 hours of savings annually. And the intangible thing is rapid innovation and feedback is enabled. Let's take these rough numbers. If we do take these rough numbers, if we assume 50 devs, for 50 devs to onboard, if we onboard them within a week as compared to 3 months, we can save $2 million as a one-time saving. If there are 50 devs that are saving an hour every single day in debugging and fixing things, we are saving $1 million annually. And if we assume, this is obviously assumption that the dev rate is about $100 per hour, so about $4K a week. These are not numbers that are marked in stone. It could vary for different scenarios, and the assumptions could vary as well. But there's an example of what it could look like if you were to work like this. So the big takeaways from this discussion is that DevOps by itself cannot be achieved unless there are good investments made in DevX, which means the developer experience, the developer joy is what the investments have to be in. And that means providing great tooling, providing top-notch automation, and removing any kind of friction within the developer process. Enablement is what ensures the effectiveness within engineering. If the developers are not enabled, they will find a way, but that way will not be repeatable, nor would it benefit others. And finally, we talked about 3 stages of the dev lifecycle, specifically onboarding, day-to-day, and then refactoring. But in reality, all stages of the dev lifecycle need DevX, all the way from onboarding to offboarding. But in order for us to do that, it's important for us to understand what does it mean, what is the return on investment, and what I showed was one example of that calculation. That's all I have for this group. If you have any other questions, please reach out to me via social media, or we can talk over the Platform Engineering Slack. Thank you so much for your time. Take care. Bye.
Hello everyone, and welcome to PlatformCon 2023. I'm Niels Principal Engineer at Humanitech. I'm presenting today a more cultural talk about testing your platform setups. I've been working in software testing for more than 25 years, and I had the pleasure to build Humanitech's platform orchestrator together with my colleagues. I'd like to start with a quote by Brian Finster from his talk, Building an Effective Delivery Platform, given at PlatformCon last year. He's essentially saying, treat your platform as a product. And describing in his talk how to apply a modern or agile software development process and principles to building your platform as a product. And this includes like analyzing the current state, like how are you running your platform today, or how achieve developers basically that their changes get released. Then interviewing all the stakeholders, defining first user stories, and then building prototypes and iterating on them. He's also touching on much more topics, and I can highly recommend watching his talk, actually. But it kind of makes it obvious to me that building your platform as a product with this setup, it makes a lot of sense to also apply modern software testing principles. So how do we actually ensure a qualitative development and release of your platform? Classically, as a QA expert, I would start with defining a test strategy. Let's describe this not in an ESTQB certified testing terms, as I'm expecting here to not only talk to QA expert, but maybe rather in a way everyone understands. So a testing strategy should include something like what to test, so what's in scope and what's actually out of scope for your platform to be verified. Then how to test things, like on which levels, like should I test this on API level, should I test this on UI level, or maybe on infrastructure level? How is the testing documented? And then also what kind of frameworks do I want to use for testing my platform setup? And then when to test basically in the software development lifecycle. So here usually comes in handy a testing pyramid where you define like this would be covered in my unit test, and then on top I would build some sort of integration tests, and then on top of that there would come like maybe API end-to-end test, UI tests, things like that. And then I would also define responsibilities. So who is taking care of what? And this highly depends on your team structure and how you want to approach the whole topic of testing. Like in some teams, it makes sense to have testing embedded as a role into your development teams, for example. In other teams, it makes more sense to have a more dedicated team or more dedicated personnel to deal with verification and release of changes, for example. Creating a test strategy is great and a good thing to do, but what's more essential is defining testable user stories. Let's get a little bit more concrete about that. So here I defined an example user story in behavior-driven development format. So it's readable, it's clear, and it basically states, given as a developer, I can add an environment variable to my application. When I deploy my configuration changes, then I expect my running application to have access to that environment variable. That sounds pretty simple and straightforward, but let's map this onto an example of a reference architecture of an internal developer platform. So here we see an example of a reference architecture built on top of AWS. These sort of reference architectures, they are also part of a couple of other talks here at PlatformCon, and they have been essentially created in cooperation with McKinsey and Humanitech to provide some good examples on how a platform setup could look like from the architecture perspective. So when we try to map our user story here, then we would basically see that the the developer would add the environment variable to the workload specification. And in this case, this would be done with score.dev. This is also a project from Humanitech, open source. After this environment variable has been added and the code has been reviewed and merged to the main branch, then a CI pipeline would be triggered. In this case, it would be GitHub Actions, right? And then towards the end of the of this pipeline, an artifact, a deployable artifact, would be created, including this new environment variable. This artifact would be pushed to an Amazon Elastic Container Registry, where it then becomes available for deployment. So the platform orchestrator would have an automatic deployment rule, for example, which would pick up this new container image and then make sure that it's getting deployed to the right cluster, where, for example, the development environment of this application is living in. So when building an automated test for this kind of scenario, I would include verifications for the following steps. So, for example, is the GitHub action actually triggered, right? So this can be the question if there is like some, like, for example, if you're using templating, like repository templates, which could be available in a service catalog, and you and this whole project would be created from a template, then I want to make sure that it actually includes the correct pipeline trigger, right? So in GitHub, for example, you need to make sure that GitHub actions are actually enabled and that they are actually be triggerable. So that could be a potential error case, and I would build in a verification in an automated test for this, for example. And then I would check, was the push to the ECR successful? Is my image actually available there? Right, so I would use my automated test to check directly in Amazon in the ECR and check if my container image with the tag I passed on is actually available, or maybe even if the tag has the right format you have provided. And then I would talk to the Platform Orchestrator API to check if the deployment was successful. And finally, I would build an automated test to check basically inside the EKS cluster to see if the deployment is up and running, if the app is available, so if the pods are up and running, and then I would also verify that the environment variable is available inside the container. That's nice in theory, but how do you actually build an automated test doing like this, doing these sort of things? Let's talk a bit about lessons learned at Humanitech. At Humanitech, we provide essentially building blocks for your internal developer platform, like the platform orchestrator, like score.dev, and also resource drivers. And as a QA engineer working at Humanitech, it became quite clear to me, or also the rest of the team, that automating these kind of user stories for an IDP setup is more than building your usual UI and API tests. So we essentially needed to be more flexible with our testing frameworks, which should allow us to integrate with things like the GitHub API, so we can check if a pipeline was correctly triggered. We needed to be able to involve cloud provider SDKs for AWS. So, for example, we've built this part in Python, and we're using the Boto3 library provided by AKS. And then we could easily check if an image has arrived in an ECR, for example. And then we needed to involve the Humanitech API to check if the deployment was successful. And we also needed to talk to the Kubernetes API to be able to check on deployments and on pods. So this was quite an interesting and challenging task. And we decided to use a testing framework called the Robot Framework. Let's talk a little bit what this is about. It's essentially a very flexible framework. You can do your usual API testing and UI testing with this. There's plenty of libraries available to integrate with Robot Framework. For example, like doing playwright tests on the UI can be done through Robot Framework. But there can be also, like, many other integrations can be done. It's quite readable. the test format, as it's basically keyword driven. So you define keywords, and then those keywords get executed and do certain tasks for you. So this is really nice for the rest of the team, as the tests basically provide also a thorough documentation on what's happening and what is this test supposed to be doing. And especially in a platform setup, this makes a lot of sense because there's so many stakeholders involved, and not everyone has a full picture of what's supposed to happen. So these tests serve as a great source of documentation as well. And then on top of that, Robot Framework makes it also very easy to build your own integration. So we decided to actually build a wrapper around the Kubernetes API ourselves, and it's also available as an open source project, and it's called the Cube library. And with this kind of wrapper, we can basically do all sorts of assertion of tests. Basically, it provides us with a lot of possibilities. We can, I don't know, get the cluster role, or get check on the health check of the Kubernetes cluster. All these sort of things are basically exposed and available inside the Cube library. And the nice thing is that we get also good documentation with this, essentially. Yeah, so much about our testing approach. So thank you very much. And I would like to quickly remind you about the key takeaways I think are worth keeping in mind. So please think about how to test your platform setups. It's an important topic. I highly encourage you to involve professional testers or QA experts on this. Like we know how to test software and how to deliver products, and your platform should not be that different. And then one of the key takeaways we learned at Humanitech is basically doing a good decision on your testing framework for automation, which allows you essentially to cover all aspects of your platform. Thanks a lot, and have a nice day.
Hi everybody, my name is Manasa. I'm currently working as a principal application engineer at Discover. I appreciate this opportunity, and I'm excited to share my experience and learnings as a platform engineer in the Platform Conference 2023. As at Discover, I'm part of the platform enablement team, providing developers and other stakeholders with tools and resources and infrastructure to build applications and services on top of our modern software platform. Before this, I was a full stack application developer where I was coding applications in Java, React, Node.js, and was on the consumer side of using AWS and GCP based platforms. So in this talk, I'll share my learnings from this journey of transitioning from application developer to platform engineer, and why a renewed perspective is needed when you move from being the consumer of the platform to enabler of the platform that you're building. I have grouped my learnings into broad categories, forming the 6-point agenda that you see here, and I'll start my discussion with patterns. As software developer, I'm used to finding reusable patterns to commonly occurring software design problems. But from platform context, I found that platform patterns needed to be adapted or applied in a different way than in traditional software development context. Let's see how. Let's take an example of observer pattern. Observer pattern defines one-to-many dependency between objects. So if one object changes the state, all its dependents are notified and updated automatically. The implementation details may differ from Java and Node.js, but the basic concept of the observer pattern remains the same in both languages. So if you are a Node.js developer and I am a Java developer, the observer pattern works for you and me the same way. But that might not be the case when you're building the platforms. Yes, platform patterns are useful, but they often need to be adapted or applied in a different way. I observed that there are 3 primary reasons why patterns are not found to be uniform across all platform implementations. The first one is the contextual difference. Platform enablement may require designing APIs and interfaces that are flexible and extensible, while also maintaining backward compatibility with existing systems. So this may require a different approach to applying patterns in a traditional context. Then there are diversity of use cases, situations where we have microservices based platform incorporating legacy monolithic services that have not been designed to work with microservices. So this can create challenges establishing a uniform pattern. Then within the larger ecosystem of third-party applications and services, patterns that work well in isolation may not be suitable for integrating with other systems or applications. So as a platform engineer, I observed that one team's implementation of a pattern might not always work for other team even if I implement it the same way. So let's take sidecar platform pattern for example. There are multiple ways to implement this. So you can implement the sidecar by deploying it as a separate container alongside the main application container, or you can implement it as a separate process within the main app container, or you can use the functionality implemented as a library and integrate it with the main app code, or you can have it act as a reverse proxy, handling incoming requests and forwarding them to the main app container. And then there is an approach where sidecar can be deployed as a daemon set, which ensures a copy of sidecar runs in each node in the cluster. So to implement that correct sidecar pattern, the needs and the requirements of the system it will be used in should be considered very closely. My second observation is with respect to the code. If we take a general components of an application code, you would have a business logic, user interface, data access, testing, error handling, deployment, and packaging. All this code is stored within a single repo in a GitHub, and scope is restricted to a single service. In contrast, when we see the components of the platform code, it is much more complicated. You have core services configurations, middleware configuration, security, deployment, monitoring, integration, and all of these components and configurations usually follow the infrastructure as code and use Helm or Terraform to automate the provisioning and management of infrastructure such as servers, networks, and storage. So at the end of the day, it is still code for application and configuration code for platform infrastructure. Everything is stored in GitHub. But there is one key important aspect between the two codes. The application code is usually bounded by limited scope. It has fewer dependencies and it is less constrained by standards and has contained change management. The platform code, on the other hand, is an amalgamation of complexity and complex code bases. So obviously the complexity of the code base increases and the customizations may also be necessary. Maintaining the code can become challenging, especially when dealing with complex dependencies. So a very common miss with infrastructure of as code is that we tend to put the code quality in the backseat and focus on automating the infrastructure rollouts. Overall, while maintaining the platform code, it requires a more holistic approach that takes into account of interdependence of its components. That is why it is very important to have this clear understanding of the platform architecture and dependencies, as well as to have this rigorous testing and deployment process to ensure that the changes are made in a safe and controlled manner. Next is the debugging, one of my pet peeves. The biggest pet peeve in platform engineering context that I have till date is debugging. It's not that there are no tools to debug platform like Terraform and CloudFormation have inbuilt tools, but even this can be challenging because it involves managing the underlying infrastructure and which is complex and distributed. So if you see the debugging process that I have put out on the slide here, it seems more manual on the platform side. And this is general process for even for application codes. Probably your debugging session could skip few steps or have additional steps. But what I understood debugging the platform issues is often more complex than debugging application code because of two main reasons. One, interdependence of platforms components, And two, the need to collaborate with other teams to identify and fix the root cause of the issue. All this makes the entire process time taking. When I worked for a small startup company, we adopted a policy of you do it and you own it. So I knew the application architecture and the platform that I deployed end to end. Now I work for a much bigger organization where executing the same policy is just not feasible. So we need to understand that the processes that once worked for us may not work for us here. The next is choices. How do we decide? Where do we start? When it comes to platform choices, there are several options to consider depending on your use case and needs, of course. So if you talk about cloud-based platforms, you have AWS, Azure, GCP, container platforms, Docker and Kubernetes are famous there. And development platforms involves many application services written in different languages, version control systems, and coming to the data platforms, you have Hadoop, Spark, Cassandra, Oracle DB, and RDS. So ultimately, the choice of the platform should depend on your specific needs and requirements, budget, team expertise, and strategic goals. But extreme care should be taken not to build platforms by stitching immature technologies together. That is the biggest mistake one can do. When it comes to platform choices, I drilled it down to 6 key things. The first lesson is to understand the needs like scale of your project, tech stack, budget, and your team expertise. We then need to consider the broader ecosystem of tools and services that surround it. And then it's better to avoid dependency on a single platform, vendor lock-in, and choose platforms that use open standards and offer easy migration paths. And have strong security measures in place, such as encryption and regular security audits. It is also important to choose or build platforms that are future-proof, meaning they should be able to adapt to changing technologies and market trends. This is usually the trickiest part. And when budgeting, don't fail to include factors such as licensing fees, infrastructure costs, support costs, and also the potential for cost savings through automation and efficiency improvements. The next is marketing. Why do we have to market? So while building applications, we often work with product team to guide us through the requirements of app and build it as per their ask. This is not a new thing. It is usually the norm. But there is an exciting aspect about working with platforms. This is the marketing and selling aspect of what we build. Yes, internally developed platforms and improved enablement processes offer known benefits to organizations like increased productivity, faster time to market, and improved consistency. But marketing the solution we build brings awareness and generates enthusiasm for the solution, which can increase the adoption rates. It can help showcase the unique features and benefits that the new platform provides. It can demonstrate the return on investment and help decision makers understand the long-term benefits of this solution. There is no suggested pattern or method to sell these platforms internally, but it usually depends on the rapport you have with the other teams. Good documentation, and lunch and learn sessions can also help. Now we must launch our platform. Application rollouts to production is a comparative thing, and it's pretty much straightforward. But we need to be a bit smart to launch our platform enablement processes or IDPs. So, unlike the application or service launches, platforms typically launch with a moment in time. To ensure sustained success, continuous feedback loop is necessary to forge a long-term partnership between platform team and developers and any other consumers that use our platform. When trying to forge this partnership, we need to find different teams with varied pace to deploy their services. We tend to find few teams who would want to quickly launch their product and are willing to cut corners if needed. These are our pressured partners. Few other teams are very cautious of rolling out unless they see proof of reliability, availability, SLOs, SLAs of the platform. So these are our overcautious partners. For launching the platform for the first time, the key is to find those fitting partners, the Goldilocks partners, who are neither in great hurry to deploy the services nor are too slow to proceed. These partners bring enough visibility to be recognizable. They are agile enough to ship quickly and are savvy enough to provide the feedback needed to ensure a great launch. Apart from this, like any product, good documentation, support, prompt bug fixing, and stability contribute to the quick adoption of the platform by teams. Oh, was this too long? No problem. So let me quickly summarize the key points of my learnings for you. For platform enablement, before we blindly implement known patterns or copy the patterns from other team, focus on the user. The success of the platform ultimately depends on its users. Design for scale. Platform should be designed to accommodate growth and scale both in terms of users and features. Emphasize the modularity. Keep in mind that the components and features should be easily added and removed as needed. And you should provide easy integration, enable customization so that users can have the experience to tailor their specific needs and preferences as they need, and ensure security. Security should never be take a back seat. It should be a priority, and implement robust security measures to protect user data and prevent unauthorized access. Platforms can benefit from fostering community of users and contributors, like inner sourcing, who can share knowledge, provide support, and help improve the platform over time. And also have a mindset of continuous improvement, so that platform should be designed with a mindset of continuous improvement, with processes and feedback mechanisms in place to gather user feedback, identify areas for improvement, and implement the changes and updates over time. Always keep in mind that even if you have the same use case as any other company, first ensure that the platform pattern or platform solution caters to your company's needs and requirements. This is because even if the choices listed out for that company or for any other company or fits for everyone, it may still not be the right choice for you. Hope this was informational for you. Thank you for your time.
Hi guys, my name is Serge Spadarets, and today we'll describe you how to do the platform engineering in practice. My path in my career is started as a typical engineering leader. I was a developer, then technical leader and architect, and after switched to engineering manager. So managed team size went from 10 to 20. After director of engineering and VP global head of engineering. This to show you that I worked with and created different platforms, working from the very development point of view to engineering leader, but also worked with finance, sales, products to deliver this properly, because it should be overseen from all the points of view to be effective. I created different platforms and I'm still very technical. I'm a contributor to Terraform, JavaScript, and Chrome itself. So, we're speaking about platform engineering. Why we even speaking about this? Always start with why. So, problems we had were 95% of availability, 20 days per year we were down. If customers had problems, meaningful time to recovery if our service was down was 1 day. So it's unacceptable even from logical point of view. Amount of vendors was more than 100. Cost was crazy because of that. No security checks and rollouts of security fixes was done per team. Every team had a bit different stack, and pro deployments were once per month because mainly absence of proper and effective CI/CD and all the other goodness. What different parts of organization asked? Yeah, so finance, of course, wanted more better cost efficiency in engineering and operations. Product more asked for faster time to market of experimentation. Security was simply asking, guys, we want to roll out security fixes fast, but also detect security problems early in the delivery pipeline. Simple, but not so simple to do this at scale. There was different requests for the common architecture, and all this had to be combined in solution done for the organization and customers. So first idea was perfect. Let's apply DevOps, which is a great practice. Yeah. If you go to ChatGPT and ask it how to apply DevOps, you will have similar answer which you have from your experience. It should be done per organization. It requires specific approaches to be done effectively and properly in every organization. So go figure. Organizational structure, you have good guidance like team topologies and other books, but you need to find the way. Okay, so platform engineering was promised and to resolve both these problems, to apply DevOps principles and practices in our organization, right? And help with the proper engineering and operation structure, team structure. Okay, so how? Let me share you the tools and approaches which I used in during last 10 years with my teams and which showed very well from practice. So first, everyone, when you start with the platform, make sure that you start delivering value as soon as possible. For that, make sure that you have one place everyone can find you, some particular site, and provide there something like version documentation. Use DocuSaur, Markdown documentation generator, anything. Make sure that you provide quick start for developers, how to download some application, how to use some guidance, how to apply analytics, how to apply different parts of events, and yada, 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 yada. Simple, effective, everyone can find you in one place. After, you of course will use something like Backstage. Backstage is an open source developer portal solution which allows you to put all your APIs, documentation, and other for your internal customers who are your developers in one place. Perfect. So first stage, make sure that you have this starting point, which is simple developer portal. Start delivering the value. You need to start picking some pilot team which will start taking this, delivering value, and speaking about you, right? Typically, in my practice, it is some product team or a few of them which created reusable solution. You add in a few operations, a few security guys to work with them, and they start delivering a first version of platform. Don't call it platform, it's still childhood. Use internal names, and then start switching to the next step. Next steps. Remember, platforms is not only about Kubernetes or APIs. It's also about front-end, about team structure. So as I said, it should be resolved at the complex to be organically solving your problems. For example, for front-end, for front-end, make sure that you're creating the common layer, which is also platform, which is UI framework, reusable components, and use, for example, storybooks. So storybooks allows you to put all your, it's an open source solution which allows you to provide all your components in one place, describe for the teams how to download them, how to use them, how to provide actually CSS solutions, override some metadata, do some actions, show the variations of your components for different countries. Anything you'd like, put this in Storybook, deliver to your customers. It should be also versioned similar as you see here. Perfect. So this is second part. Of course, pack your solution into your React app, Vue app. Make sure that customers can download your web application. Start growing your front-end platform. This is another part. Third part, of course, think about microservices and all the backend parts which is there about the databases and other pieces. So first of all, decide which main programming languages, approaches you would use across organization. Let me show you what I say. We, for example, used JHipster. Make sure that you decide, is it Java, is it Python, or depending on what skills you have inside the organization, what hiring is good for you, and speak with your architects, staffs, and others. JHipster is a good example, which when you run Hipster and you're saying, I want to create a simple application, it asks you, do you want for example, monolithic application where it's combination of front end and back end? And I would say yes. It asks me what type of authentication I want to use. You will need to resolve this for your application. It asks which type of database, same as exact type, is it MariaDB, MySQL, or other. Caching, it will come to caching yet. The persistent caching, I, for example, love Redis here. Hibernate and Maven Gradle build system, it will ask also just which CI/CD to use. Everything like that. The more, the better you pack in your reusable templates. So let me show you. I created application like that. Here it is, my app. And I have a reusable application which delivers my web React application because I chose to do it, and my Java Spring Boot. Sure, here it's up and running. Let's take a look. Yeah, simple application running on my local machine, and now I want to say here it really works. I'm not bullshitting you, so remember me. Here. Perfect. Database works, everything works, I can use it, and it works locally. Now I want to deliver this to my fellow users in my company. How do I do it? So you can, remember I told you about a Backstage. Go to Backstage, it's again open source and simple. Add a new template, here it is, and inside of this template, simply put this particular application which I described to you. Take a look, I just put it there. The same web app, the same Java, simply put it there. And make sure that you're changing it to be a template. So add it with your CI/CD templates, with your infrastructure as code, with your security policies. Everything what's needed should be packed there. Why? Then inside of your Backstage, so take a look. This is Backstage, which is running on my machine. Then of course it can be delivered. So you will be able to allow anyone in your organization to reuse your templates which already have impact typical microservices, typical CI/CD, typical security solutions, checks, anything, and you will grow in this solution this time. So let's take a look. I created simple Hipster application. I want to create an app using it, right? So let me just show you how it works. I want to use, for example, GitHub, right? I will use my own GitHub because why not, right? Inside of organization, it will be your own. And let's start creating. We'll see if it works. Typically it is, yeah. So similar experience you will have for your guys in your organization. They know exactly where to find this developer portal, right? They know exactly that they can reuse your application templates. They know that your application templates provide CI/CD, security checks, and other goodness, which is the golden pass across organization. They will do exactly as I do now. This will enable you to grow with your platform. So let's take a look what really happens there. Meanwhile, let me open just my GitHub. Let's see to the latest. Sorry, it's slow. Repositories. Still creating. Here, my app. It really created the repository. It's still writing, but I'll show you. It really creating the repository. It starts writing the file there exactly as we said in the template, right? So this will be the goodness, because literally it will allow you to deliver all this up with all this goodness. You can pack there also the developer experience goodness like Git hooks, which can run some tests in your which you require in your organization, security values, Infrastructure as code, so you can use, for example, AWS S3, EKS, Kubernetes, and other goodness, right? Unfortunately, it takes too long, so maybe I'll just stop it at some point. Okay. Yay! Registering, hopefully. Done. Perfect. So let me just see what happens. Here is actually it created. Well done. So I didn't bullshit you, and it's really a real project which is just committed, created from my template. And the best part, yeah. Remember, I packed the Git hooks, and from initial commit, what it starts doing, it starts deploying to AWS because I said so, and literally it will start by doing npm install, set up node, install dependency, and publish to AWS. So let me show that really the application which I just showed you, running locally will be running the same remotely. Done. So take a look. Of course, I did this a bit earlier because it takes 5-6 minutes. So this is application running on AWS S3 and the backend running on AWS EKS Kubernetes, right? Perfect. You can do all this, and after every team can start using your solution and taking your new versions. So that's the power of the platform, and at this point you will be adolescents for a part of stage of the evolution of your platform, because you will have your developer portal, you will have Git, CI, CD, testing, and infrastructure goodness packed there, and your platform team will start growing. So here it will be around a few teams, ops, security, and you will have 5-7 customers, teams inside of your application, inside of your organization. After that, you need to do tons of work, literally tons, right? You need to provide common artifacts and container solutions, environments, observability, upgradability that everyone can take new versions. So how to do this? I created, based on my experience and with input from other guys who contributed, awesome platform engineering. It's a list of tools which you can use for all the goodness in the platform. What do you do for Kubernetes? What do you do for service mesh? What do you do there? So all this experience of 10 years, nobody paid for this. It's also open source. I try to actually more keep this to open source solution. So reuse it and feel free to contribute to that. At that point, when you add in all this, you will have observability, you will have upgradability that every time you add in your platform, your customers can get this. Your platform team will start organically grow and have front-end parts, back-end parts, and other parts. So it will be growing up to a few hundred people. That's what's happening. So let me summarize everything that I spoke about. What we achieved when we did then we went platform engineering and the approach which I described. So it was 50 apps, 100 microservices, 20 plus micro frontend. So this is technically speaking, but more important, our meaningful time to recovery when actually our service went down was up to 4 hours. So it was improvement in more than 6 times. Availability went from 20 days down per year to 5 minutes per year. So amazing. Time to market from once per month pro deployments to daily. Security checks, it was perfect because when all this was platform based, security fix we were able to deliver with our platform. So typically it was taken up to 1 hour when it was crazy. It was the crazy supply chain fix. We rolled out once in 3 hours in between all these 100 microservices. It's possible when you have a platform. And other metrics, the NPS score, time to onboarding went up as well. So we delivered what we promised for different parts of organizations. And what tips I can give you from experience? Important, super important. Pilot team is your evangelist. Make sure that you're picking them very right. Treat platform as a product from the very beginning. Internal teams are your customers. Make sure you have a PM, you think about the developer experience as I showed you, and grow and deliver the value constantly. For UI adoption, make sure that you work with UX. For infrastructure, developer and operations, security SecOps is your actually best partners in crime. Cooperate with leadership. They must enable top-down, provide you top-down support for bottom-up enablement. This is working from all the pieces. If you read Phoenix Project and the second book, yes, it's a unicorn project. It's all only works from both sides. It cannot be from one. And jackpot platform strategy. This is from me to you. Every 3 times we found a way to deliver this platform, not only to internal customer developers, but for external customers. So first we tested dev solutions internally, and then also developers from customers could use the same by themselves. Believe me or not, it makes everyone happy. So it gives money for company, it gives you the goodness of platform engineering and development and purpose in this life. So guys, I love traveling, yeah, and I trust that if you don't be afraid to do the first step. So a great journey of 1,000 miles begins with a single step. So now go actually start building your amazing platform, right? Make sure that you contribute to platform engineering tooling list, which I showed you. Feel free to jump and connect on LinkedIn. Thank you very much, guys. Have a nice one.
Hi, my name is André Leal. I'm the head of software development framework team from IT architectures department.
And I'm Nuno Guedes, Cloud Compute Lead from our Cloud Center of Excellence. And we're both from Millennium BCP. For those of you who don't know, Millennium BCP is the largest privately owned bank in Portugal. And I think we're here to show you guys some cool stuff. Isn't it right, André?
Yeah, let's go.
Yeah.
So, what we have to tell you about our journey from 8 days to 8 minutes regarding our application lifecycle management and deployments. What do we have to tell us?
Well, I think that 8 days to 8 minutes is pretty bold, isn't it, Andrea? It's a big difference, right? How do we support that?
Mainly, we identify our pain points on our process, and we try to automate things, and mainly getting things done automatically instead of using manual triggers or.
Cool. Do you want to tell us a bit more about that?
Yeah. Basically, we identified some issues or some pain points on our development workspace creation based on the dependencies between teams. Can you explain a little bit what that means, this dependency?
Sure. I mean, if we take into account the way we did it before this tool set, you can all imagine that we had, for instance, when starting up a new project, a new development project, we needed to ask for a Git repo, for pipelines, for infrastructure configuration, for security configuration. Multiple teams, 5-6 teams needed to be involved, right?
Different roadmaps, different sprints, different processes, right? So how did we solve it? Basically, we tried to, and we automated all this stuff. Okay, we created based on our service catalog, we created a new form where teams can ask for new microservices. And
did you say form? I mean, it's point and click.
Yeah, that's it. The teams, the developer just types some info regarding the service, cool. And based on that, we generate a special thing, an application definition file that will drive from the scaffolding, that will drive all the automation regarding scaffolding, creation of Git repo pipelines, automation on builds and deployments and so on.
Cool. Okay. So you mean that now we don't have that issue where everything is similar but not the same. Now 2 pipelines for the same thing are the same. They're not just lookalikes.
Right. And that was a pain point we had before, because different pipelines give us generates governance regarding, and we need to maintain and evolve the pipelines. And with this approach, we centralize all based on the it's like a dynamic pipeline, right? The pipeline is intelligent to understand the needs of the service and generate and compile and build and test based on the information, and generate artifacts based on the information from the application definition file.
I mean, that's pretty cool for sure. But I see that we identified another problem that I think that's related with that one, which is then customization. Because I imagine that even if you run the same pipeline and you point it at different environments, you need, well, different connection strings, different service URLs, and so on.
Yeah, but based on automation, we can delegate that for systems that already solve that issue for us. We used our we converted our application definition file, our service definition file, to standard and open application model that could be interpreted by the infrastructure to generate resources and different kind of things. So regarding the architecture of this initiative, all starts on the service catalog. We are using the backstage from the Spotify to list services, applications, and domains. There, developers can search for specific microservices, see the OpenAPI contracts or other contracts for service exposed. They can search, find it there. But we give another step, and we created our service request workspace creation request there. Okay, we created a new model for scaffolding there. What it will trigger? It will trigger pipelines and processes that will create Git repositories, boards in Azure DevOps. We will create pipelines associated to the service. We will scaffold the code regarding the service based on the service definition file, based on the technologies described there, and the commit code to the Git repo. Then all depends on the branching model to trigger deployments and magic on the infrastructure.
Magic is always cool. So here we are, just to see that we are following down the path to having the application up and running. Here we're at a point where the developer chose what he wanted, and pipelines did things, and now we have all of the artifacts in Azure DevOps created, right?
That's right. Now just depends on the developer to start coding and interacting with the pipeline, triggering it using our branching model.
Cool. And after so imagine the developer does a PR, and that is going to be released into an environment. For instance, it's going to QA, for instance.
Right.
Then we'll convert that into something the infrastructure understands, right?
Right. Using a GitOps approach, we get our definition file, we convert to an OEM specification and deliver it on Git to be interpreted by the control plane on the infrastructure.
And then Git and the file from Git in OEM syntax can then be interpreted by kubevela in a Kubernetes cluster. And kubevela basically understands that this application has these dependencies, for instance, the database, cache, whatever, and passes those infrastructure requests to Crossplane, so that Crossplane can then instantiate the backing infrastructure resource, like the database, for instance, and in that case, pass on the connection string back to kubevela, and then kubevela does its thing and spins up the application with the right configuration. End-to-end, full automation.
So let's take a look regarding how we trigger the process of creating a new service. This is the Millennium BCP service catalog. As we said, we use the backstage as our base product, and we extended with a new model to scaffolding and create a development workspace. today the developer just need to get to this form. We have some requirements regarding the organization of components or services on our ecosystem. So developer needs to select the business domain where a service must be created, and the business, not just the business domain, but the application where the service, the microservice must belong. Okay, gonna select previous created applications, and I'm going to create a PlatformCon service. Okay, demo service. A short description of the service. Okay, description. And now the cool stuff. This is how we organize services inside our ecosystem regarding the topology, what kind of microservices we have. I'm going to select the first category of microservices, the process, our process APIs. Now I can choose one of our persistency types. I'm going to choose none just because I want to expose a none. So we submitted the request for workspace creation, and now after the automated process, we already have a new Git repository for the PlatformCon service we requested before. Here we can find a new repository with our folder structure, our standard folder structure, and code has been scaffolding and committed here for the new service based on the service definition file generated on service catalog. That file is here, okay, and we can find the specification we typed on the service catalog. Now, another thing, a new pipeline has been generated too, and this pipeline will be driven by the service definition file to build and deploy services on environments. Now, let's make some different thing. Let's change our specification of application to add a new dependency regarding the persistency. So I'm going to change this service definition saying I want a dependency on a single store database. What should happen behind the scenes? The deployment process must ensure a new database for this service.
So after the service definition file has been updated and a pipeline has converted it to an OAM definition file, this is what we end up with. So as you can see, we have a core OAM dev definition, in this case for our PlatformCon service, and in this file we are specifying multiple components for our application. So one component is of type M3DF, which is our internal type for our code framework. Then we can also see things like an observability trait, where we already define the observability requirements for this application. We can also see an identity component where we define things like roles, users, how the application ends up being registered so that it has an identity and can communicate with other applications. And then, as we can see, there's also that database that we manually added to the service definition file. So what now? This file that you see here, being properly validated, will be pushed using GitOps to a cluster. If I do something like this, you can see that the file has been picked up by this cluster and by kubevela running in this cluster, and kubevela has done its thing and ensured that that application is ready. What does this mean? Well, for one, we have a pod running with the application code, and as you remember, there's a dependency on a database. So what happened to that? Well, we can see that there now exists a database PlatformCon service, and that database, we can take a look at it, has been defined as single store family and SKU small. And what exactly is this that we're looking at? Well, this is taken care of by Crossplane. And how? Well, we have some compositions defined in Crossplane. So we have a composition that takes care of managing databases. We have one for the observability trait that we saw in the OAM file, and others that support this story of spinning up resources.
So guys, hope you enjoyed this presentation. Please feel free to ping us if you want. You can find us via email or join us in LinkedIn.
Thanks a lot, guys. See you soon.
Bye-bye.
Several years ago, my colleagues and I set out to answer a simple question. What distinguishes highly productive engineering teams from the rest? Why is it that some teams deliver value at lightning speed and have happy developers, while other teams struggle or languish in frustration? Why is it that some teams have that discernible magical energy of creativity, while for others, work feels like a drudgery? What is it that these highly productive teams do differently, and how can all teams and organizations become more like them? Past research studies have attempted to decode the science behind high-performing organizations through a top-down view, surfacing organizational capabilities that correlate to business performance. They've uncovered things like the importance of using version control, continuous delivery tools, as well as cultural characteristics such as psychological safety. But none of these studies have examined productivity through the lens of the people who actually do the work. That is, the developers, the people who are actually in the trenches building and shipping software every day. What were the differences in their work and in their teams that they observed, and which of these things matter most? This, we believed, was the missing answer that would provide the true keys to creating highly productive teams. To answer this question, my colleagues and I set off to conduct one of the largest research investigations of developer productivity to date. Over the course of 18 months, we collected and analyzed data from over 300 teams across over 100 organizations. To determine what factors predicted highly productive teams, we created composite measures of individual team and organizational productivity, as well as performance. We measured productivity and performance from all different levels of organizations. For example, when assessing the productivity of a team, we would capture ratings from the individual contributors as well as the manager and that manager's manager as well. Then, by leveraging existing literature as well as factors emerging from our own research, we examined hundreds of different factors to uncover which things actually drove productivity and which did not. The results we found were surprising. One hypothesis we had was that the experience level and pedigree of developers on a team would be primary determinants of that team's productivity. If only everyone could just hire engineers with the same pedigree as those that Google hires, then we could all become technology titans like Google, right? Wrong. We found, in fact, that experience level and pedigree of developers on a team did not predict its productivity or performance whatsoever. We found varying levels of productivity across teams of all different experience levels and backgrounds. Another assumption we had was that teams that worked with more modern programming languages and frameworks would be able to achieve outsized levels of productivity compared to the other teams. Once again, we were wrong. we found that productivity varied drastically across teams using the latest programming languages and frameworks, just as they did for teams that used less modern tools. As we continued our investigation, we slowly began to notice a pattern emerge. We began to see that the factors correlated to productivity were not necessarily a function of the individuals on the team or the specific technologies they used. But rather, there were many specific aspects of developers' surroundings and environment that seemed to have the greatest impact on productivity. The teams that were more productive had tools that were easy to use, CI/CD pipe. The teams that were more productive had highly effective environments. In other words, they had development environments that were easy to load and navigate. They had tools that were seamless and collaboration across teams that didn't hold them back or block their progress in their work. In contrast, teams that were not as productive always In contrast, teams that were not as productive had constant interruptions and disruptions that got in their way from doing their best work. As these types of factors emerged, it became clear that there was a bigger idea emerging here, an idea that encapsulated all of these factors, which were the keys to creating highly productive teams. This idea represented an enormous opportunity for leaders and organizations to improve the quality of their lives. This idea represented an enormous opportunity for leaders and organizations to improve the quality of lives of their developers and unlock greater productivity as a result. As you may have already guessed, we named this idea developer experience. Developer experience is about the lived experiences of developers, the sum of all the factors which affect their experience as they do their day-to-day work, whether it be their tools, team processes, or culture. Developer experience is how developers feel about their work, what they think of it, and how they value it. This may sound a bit fuzzy, and it did to us as well. So in a subsequent study, we broke developer experience down to a concrete set of factors. And for the first time, we were able to fully understand how important it is for all organizations. Our research shows that companies with better developer experience not only outperform their competition in terms of productivity and their ability to innovate faster, but also in terms of business performance. Today, every company is a software company, and developers are their lifeblood. Developer experience is the key to developer success and therefore business success. The best part about developer experience is that every team and organization has the power to improve it, and by doing so, increase their own productivity and performance. Earlier this year, myself, along with Dr. Nicole Forsgren, the creator of Dora, and Dr. Margaret Ann Story, one of the lead authors of Space, published a new framework that distills developer experience into 3 core dimensions. Although developer is complex and nuanced, teams and organizations can take steps toward improvement by focusing on just these 3 key areas. Flow state. Feedback loops refers to the speed and quality of responses to actions performed. These are things like CI and build. These include things like the time it takes to build code or test code, or the time it takes to wait for peers to review your code or provide feedback on your work. Cognitive load refers to the amount of mental processing required for a developer to perform a task. This includes the difficulty of learning a new concept or understanding documentation. It also relates to the inherent difficulty of performing a complex task. Lastly, flow state refers to the concept of getting into the flow or being in the zone. This isn't just about being able to focus without interruptions. This also has to do with working on things that are fulfilling and stimulating as well. Taken together, these dimensions encapsulate the full range of friction encountered by developers that we found in our prior research. And this provides a practical framework for understanding developer experience in your own organizations. To measure developer experience, it's important to capture both the perceptions and workflows of developers across those three dimensions of developer experience we just covered. It's so important to measure both the perceptions and workflows because neither of those dimensions alone can capture the full picture. In addition to measuring the individual factors, the detailed specific areas within each dimension, it's also important to keep an eye on the bigger picture by measuring KPIs or North Star metrics. We recommend measuring all these things using surveys, then augmenting them with system data when situations arise where you want to cross-check or dial in deeper. For more information on developer experience and how to measure it, please check out our paper published in ACMQ. Thank you so much for listening to this talk.
Hello everyone and welcome to this presentation today. I'm Vilas Buscha. I'm a platform engineer at Moz, and Moz is a spend management solution that enables companies to manage all of their spending easily and transparently by offering credit cards, digital invoice management, and automated accounting. Today we will cover the best practices for modularizing a Terraform project. More specifically, we will discuss about Terraform state, Terraform modules, environments, and a few tips on using Terraform effectively. So first, let's start with remote state with versioning and locking. So by default, Terraform state is stored locally in a file named Terraform state. When working with Terraform in a team, using a local file makes Terraform usage complicated because each user must make sure that they always have the latest state before running Terraform. Furthermore, what if two or more engineers execute Terraform apply or Terraform plan at the same time? This creates a significant problem where Terraform state can become corrupt, leading to data loss or conflicts. To resolve these challenges and ensure smooth collaboration among team members working on the same infrastructure, we use remote state. This means that although everyone works on their local machines, the Terraform state is stored in a shared central location, allowing everyone on the team to access and work with the same version of infrastructure. So Terraform supports storing state in Terraform Cloud, in Amazon, Azure Cloud, Google Cloud Storage, etc. So remote state is implemented by a backend or Terraform Cloud, both of which you can configure in your configurations rules module. So first we need a bucket. I'm not going to go in details on this, but make sure that you have a bucket created. Then add the backend Terraform configuration and make sure to specify your awesome bucket name. After that, run Terraform init. Terraform detects that you already have a state file locally and prompts you to copy it to the new cloud storage bucket. Then just follow the instructions from the command line. So to sum up, by storing state files in a central location, it becomes easier to track changes to the Terraform configuration and prevent concurrent access to the state file, which can lead to conflicts and data loss. Additionally, this approach makes it easier for multiple team members to collaborate on the same infrastructure. So now let's continue to another step called modules. So modules are a key feature on Terraform. A Terraform module is a collection of Terraform configuration file that can be used to provision a particular set of resources. So modules are designed to be modular and reusable, allowing you to create code that can be easily shared across projects. Each module can contain one or more resources depending on the needs of your project. So now, why do we use modules? First, modules are designed to be modular, making it easy to reuse code across different projects. Then simplicity. So modules provide a simple and easy to understand way to provision infrastructure resources using code. And then consistency. Modules allow you to create consistent infrastructure across different environments, ensuring that your resources are provisioned in the same way you intended. In the other words, it helps us follow dry code principles by organizing, encapsulating, and reusing code. But in the end, let's do not forget that modularizing configuration is needed only when we use repeatable configuration in our projects. So modularize at will. Now, I wanted to share two approaches I came across working with Terraform. And one is dividing everything into modules. I don't know how to call this approach, but let's explain it first. So we have IAM module, we have storage, and I don't know, network pops up, whatever it really makes sense for our infrastructure. In IAM, we store everything related to permission for the whole project. With storage, the same. So we have some sort of services grouping. Let's call it services grouping. The other one is solution-specific grouping. I call it like that because for me, it makes sense that I define solution-specific resources or configuration in a module. For example, we have web server cluster, and we configure everything related to that there. I don't know, IAM permission, network, whatever really makes sense, or data storage, or yeah, whatever really you use in your infrastructure that would make sense to kind of merge all the resources needed for that specific solution. In our team, we started going from the first approach to the second approach because it really made sense for us to have this clear code when looking or when like creating new features or anything like that. So now let's continue talking about defining environments for our infrastructure. What options do we have and which one we chose as a team considering the consequences. So to manage multiple environments, it's important to organize the Terraform code in a structured and maintainable way. There are two primary methods to separate between environments: directories and workspaces. So directories involve organizing your Terraform configuration files into separate directories for each environment. For example, staging, production, or development. Each environment directory contains its own Terraform code, including configuration files, modules, state files, etc. This method provides a clear separation of code for each environment, making it easier to manage and maintain. On the other hand, workspaces involve using a single set of configuration files, but with multiple workspaces within those files. I'm not going to go in detail on this, but like each workspace corresponds to a different environment, such as staging, production, or development. Both directories and workspaces have their pros and cons, and which method to use really depends on your specific use case. However, generally speaking, directories are a more flexible and scalable approach as they provide a clear separation of code for each environment. In our case, we use directory-separated environments because it really made sense for us to test changes between different environments. And of course, we know that we actually have a lot of duplication code between staging and production, but in our case, this is a very clean and isolated, separated way between these environments. And of course, we use separate files for each environment. So in the end, just to give a very generic example on using module, here, let's define a module, let's say VPC, Security Command Center, or database, and we use one of these modules in one of our environments, let's say production and staging. So for example, using Security Command Center in our staging or production environment, we can define it like this, right? We define the module, the source of the module, and whatever environment we are currently using. In our case, it's staging and production, and we're reusing this module in here. Then just define the variables as well. whatever the module is intended to accept. Now, let's continue with a few tips that I really find them useful. First, we use pre-commit hooks or add a step in your build script for formatting your Terraform code. And this makes it very easy to not really care about if the Terraform formatting is correct or not, or anything like that. So even before committing your code or in your pipeline, adding a step that actually runs Terraform format and pushes a commit to your source code is actually very, very useful. Or the next one, I would say use loops like count or for each to optimize repetitive resource creation. This is, for example, creating multiple service accounts or subnet within just one block of resource code. You can find a lot of examples out there for this. And last, I would highly recommend to have an amazing README file that explains your infrastructure as code. By explaining, I mean the code conventions, the infrastructure structure, what really makes sense, and the whole idea behind like why and how your team decided to do what's intended to do. And this will really save a lot of time for engineers who start working on your infrastructure. And in the end, everything is learned with practice in different projects. And thank you for joining me today. And I hope that you find these best practices useful in your own Terraform projects. Thank you. Bye-bye.
Hello everyone, and welcome to this talk on how to accelerate the adoption of your internal platform, which I believe is a topic lots of teams struggle with. In this session, I'll share some focus areas or principles that will help you accelerate adoption. Under each group, we will explore a set of techniques that you can try. And at the end, I'll go over 2 case studies of dedicated modernization squads. But first, let me introduce myself. My name is Javier Turegano. I'm one of the co-organizers of the DevOps Represent community, which supports folks from underrepresented groups in technology that want to learn more about DevOps. My talk today is based on my experience over the years working in internal developer platforms of 2 forward-thinking companies, Slack and REA Group. At Slack, we created our internal developer platform called Bedrock, while at REA, we created a set of internal building blocks under the platform name of Collab. You've probably already noticed one of the key measurements of the success of any product is adoption. There is no point in creating an internal platform if your users don't end up using it. What's the point? And you won't be achieving any significant ROI on your platform work. But it's not uncommon to see the adoption of internal tools or platforms stagnate and come to a halt. It may well be that they fail to cross the chasm or to get to the late majority groups of the technology adoption lifecycle, but they end up failing their objectives. There are a myriad of reasons why your platform may not see the adoption that you would like to see. These may include things like not being fit for purpose, focusing on the wrong type of user, not solving the right problems, or even being too difficult to use. In many cases, you will hear comments from your target groups that will say, "We're too busy to adopt yet another thing," or "We'll get to it when we deal with a few more fires." Let's see how we can address those problems and foster adoption so you can roll over the adoption curve like our friend Sonic in this slide. Let's go. Our first area of focus is to understand the needs of our users and stakeholders. There's no point in building a platform or a set of tools that are not solving the problems of your users. In this case, the engineers in your organization. The key here is to apply product thinking to your platform. In addition, if your platform solves a lot of your users' problems by default, we can call batteries included, this will be a strong selling point that will boost adoption. For example, if your platform meets your organizational compliance, security, and performance requirements by default, then your users don't have to worry too much about those areas, and they can focus on solving user problems. Let's jump into some techniques under this area. The first one is to hire or borrow product-oriented folks. These are people that are specialists in product, like a product manager, or a UX specialist, or even a developer advocate that can complement the strengths that you have in your engineering team. It is very important to also work together with your early adopters. When you're creating your platform, you work with one or two teams and you start solving their problems, you will be sure that you are solving real problems and not creating a platform in a vacuum. It can be a great addition to your platform team to add product engineers to it, because they will bring the mindset and the expertise of the area that you're trying to solve for. Another great technique is to establish a user advisory group. This is a group of folks from your platform team and for your product teams that get together on regular basis and discuss about the features, bugs, and the coming roadmap of your platform. Another great one is to have a feedback channel in Slack. That way, anyone can pop up in there and share their thoughts on the platform at any given point. Another powerful technique is to conduct user experience interviews. At Slack, we will sit with our developers and ask them a very simple question. Can you show us how to add one line of code to your service and then release it to production? This exercise was mind-blowing. You may think that you know everything about how people are using your platform, but until you see it in action, you are not going to be sure that you cover all the use cases. So totally recommend it. The next technique is to make sure that you are factoring adoption and usage analytics as part of your product. At any point in time, you should be able to answer the question, yes, but who is using the platform? What about feature X? Was that worth developing? Is anyone using that? And you should be able to track the adoption of your platform over time, as shown in this graph here. Let's move to the next focus area. Our second focus area, or principle, concentrates in providing a great user experience. A compelling platform will attract more users to it, and if they like the experience, then they will tell other engineers, generating the desired snowball effect that will help you greatly with adoption. Some techniques under this principle are applying UX research and design techniques, which can greatly help you with creating a beautiful user experience in your product. Run frequent user surveys, which is a great way to keep a feedback loop with your users. In those, I would recommend capturing NPS, Net Promoter Score, and we will talk more about it later. Streamline your feature request process and reserve capacity. And finally, run customer love sprints. This is the idea of dedicating some time from your team, maybe a sprint or a couple of weeks or whatever you want, to focus on those features that are going to be the lighters and going to create an amazing experience for users, but maybe they don't fit in your roadmap or they're not getting the attention that they deserve. As I mentioned, NPS or Net Promoter Score is a great way to track over time if people are happy to tell their colleagues to use your platform. We use this metric at Slack and at REA, and we will make sure that we will include it in our frequent surveys. That way you can know how your users that vary over time are feeling about your platform. The other thing I wanted to share with you is this capture of the containers roadmap from AWS. This is a public product, but it has a complete repository where you can request features, and it's all public, and then people can vote on them. What is stopping you from having something similar inside your platform? And let's move to the next principle. Our next principle indicates that documentation and onboarding should be a delight. Make sure that your product has great documentation that helps users to get started quickly and also to figure out how to use those more complicated functions that may not be part of the day-to-day. A critical phase for that is during the early interactions with your platform, so you need to make sure the onboarding process is great and smooth. Here are some techniques that we can use for that. The first one can be to hire or borrow, if your business has one, a tech writer that can help you write beautiful documentation or even upskill your team in the art of writing documentation. You can experiment with different formats for your documentation. One that we tried is videos. They are great, they are more full experience, but also they are more difficult to edit. I would recommend to run bootcamps and especially to make those bootcamps part of your engineering onboarding process. So whenever a new engineer joins your organization, they will go through how to use your platform and will know from day one that day exists and how it works. Another great way to free up time from your platform team is to provide self-paced training materials, which we had great success also at REA and Slack. This is the Hello Bedrock repository that you could clone, download to your laptop, and then do a full exercise on how to use the platform without having to go to any of the engineers. Then if you have doubts or anything is not working, you can ask in the support channel. This was a great start for engineers, and any time that we will add a new feature, we'll go into this repository. And now let's move on to the next principle. And it's great to see that you're still following along. I know this is a long talk. So our next focus area is to provide reliable and user-friendly support. It's nothing worse than feeling that you are alone when you don't know how to make a product work or when there are issues that need attention, but nobody's there to help. Your support channels should be easy to find and provide a great experience to your users. A lot of times, the users can get captivated by your ability to care about them when dealing with support. Let's move on to the techniques that follow into this category. So, have a dedicated support channel in Slack is normally a very easy way to do it. Maybe in the physical world, you will have a help desk in your office that works too. Provide white glove support. Some users will need more from your platform engineers. They will need to kind of get someone embedded and someone that can help them along the journey. So make sure that you identify those key users and provide that extra support. Provide clarity on the response time for support and the availability. There's nothing worse than like screaming to the void and not hearing back. It's great when you know, well, we heard you, we recorded your request, we'll come back to you tomorrow, if that's the best that you can do. And finally, tune your documentation and FAQs based on the requests received. And that way you will be able to deflect some of those requests from your channel into the FAQs and get users to hold themselves quicker. And now let's jump to the next principle. This may be a controversial one between your engineers, but it's time to flex out your internal marketing muscle, which is our fifth focus area. As with any other product, regardless if it is internal or focusing on external users, you want to promote and sell your platform. It's important that you invest in making sure that they know about your platform and what benefits it provides. By sharing what is coming down the road, you can build up excitement, but it may well also avoid them wasting time building tools or features that are already in the platform roadmap. Well, let's see some of the things we can do related to marketing. I will probably start with creating an identity for your platform or for your tools. A name and a logo are fundamental. You can create very cool swag of your platform. There can be stickers or teaser or anything that gets your engineers excited and to identify with your platform. The next option is to create a marketing site for your platform. This may be a little bit different to your documentation. in the idea that it will go over all the benefits and all the good things and use cases of how to use your platform. Which brings the next point, which is publicize case studies of adoption and usage. It's really great to hear from other users instead of your platform engineers when something has worked or not, and how they are using it and how they've been adopting it. Finally, you could even promote new features within your product, just letting people know that a new thing is available when they're browsing or using the tool. Let's go over some of the examples of what I just said. The first one was about creating that identity and a logo. You can see that there was a lot of work put into creating the Bedrock and Collab logos and to create that identity for the platform. The next slide shows a marketing site for your platform, which goes over the different Bedrock features. This was implemented finally in a different way, but the idea still holds, which is to make it easier for people to find and understand what your platform does. And this case study, even if it is not an internal one, was a case study created by BuildKite about the migration REA group did to it. It's a great example of how you could, even internally, showcase how users are migrating or starting to adopt your platform. And we are reaching the last principle, so let's dig into it. While the previous principles and focus areas related to how to create and support your product, this final area deals with how to boost adoption via the creation of your own dedicated modernization squad. You can also picture this team as your own internal professional services. Similar to how commercial products and companies benefit from providing professional services, you can employ similar techniques internally in your organization. The idea is to have a group of internal consultants that provide hands-on support to your users to migrate into your platform. They will work closely with the new users and make sure that when the work is done, not only the migration work is completed, but also that the new users are able to operate with ease in the platform. You can picture this team as an enabling team in the team topologies terminology. You use those as pictured in this slide. Now, let's see some techniques in this area. First question is always, how can we fund those types of teams? And I will say, go and talk to your finance team. You may get surprised. Sometimes you can fund those teams with the savings from being able to migrate licenses or to be able to use a different product, but also with the time saved from the teams not having to do the adoption themselves, because it will be expedited by experts. I will say that if you have technical program managers or similar type of folks in your organization, you should try to get one to work with you in this type of migrations. They are great at mobilizing the organization. They are great at working across different squads and teams and to exercise that change and track how things are progressing. So they are an invaluable resource for your modernization squad. As operating model for that team, I would recommend embedding. That means that the engineers will go and spend some time inside those teams that they are supporting as if they were part of the team. That will create the trust and accelerate the adoption of the platform. Finally, there are many steps to do in one of these types of migrations or modernizations, and employing techniques like value stream mapping, you can figure out what are the bottlenecks, and then you can attack those by using tools, automation, documentation, whatever is required to reduce the time for adoption. Finally, I would recommend promoting new features within your product. Oh, that's not from this slide, sorry. I'll remove it later. So the final area that I want to talk about is mandate. As you can see, I have not included as one of the principles, but it's definitely one thing that you can use to hold and boost the adoption of your platform. Beware, there are a lot of problems with mandated platforms, and probably you're going to figure out that it's probably one that you want to avoid if you can. Finally, let's jump into the case studies for dedicated modernization teams or squads. I have two of those. The first one, while REA, we'll call it the Wally team. It was a modernization squad. The situation was that the adoption of a new CI/CD platform, in this case Buildkite, was slow. We were seeing that teams will not have the time or expertise to move. After the time they spent helping teams, all services in the 60 plus squads at REA were migrated to Buildkite. Their mandate or their objectives were expanded to many other tools and practices because we found that this pattern of expediting modernization was very effective. The other example or case study is the SRE India team at Slack. They were responsible of supporting a set of teams inside Slack, and they have already migrated all of them into the platform. So we saw a very good opportunity for these fine folks to jump and support other teams. By doing so, we accelerated the adoption of the platform in some areas where probably would have been almost impossible for the product team itself to jump into this modernization. That was a great outcome, and finally the team was repurposed and moved on to a different area. And that's everything. I hope that you enjoyed this session and that you pick up a few techniques and principles that you can use to expedite your modernization. My name is Javier Turegano, and you can contact me in LinkedIn and Twitter or through that QR code. Thank you very much. Bye.
Welcome to our presentation about building a platform organization. In this talk, we will take you through our journey in discovering the value of platformization and how we started the implementation and continue to learn. My name is Bas Fecter, and I work as a platform engineer in the Central Platform Organization at Dutch Railways. First of all, I'd like to share that many of the ideas we now have are built upon things we have learned from PlatformCon 2022. So thank you to all the speakers of last year for inspiring us. We hope to give something back now as we build upon these ideas.
My name is Onno Wiebos, and I work as a product owner in the Central Platform Organization. Dutch Railways is the principal passenger railway operator in the Netherlands. We transport over 1 million passengers every day across 400 stations in the country. We have lots of IT. More than 100 development teams work on 400 applications every day. They develop software for planning systems and software for our trains, and also customer-facing software such as travel information and payment systems. To illustrate how digital our organization is, let's zoom into our bike systems. These systems are also very digital today. For instance, the bike locks of our rental bikes must be opened and closed with a public transport card. It not only delivers comfort to our customers and avoid key loss, but it also gives opportunities for innovation, like returning a bike at another location, all to serve a very well door-to-door experience for our travelers. The picture at the right shows our newest bike store location at Amsterdam with 9,000 parking places. Our IT, software and platforms needs to be always on and at scale to deliver a very well experience to our travelers in their journey. Our Central Platform Organization serves all these IT initiatives with IT platforms. We deliver workplaces and platforms for software development and everything team needs for doing their job and bring it to production, like tools for pipelines, test automation, and collaboration. Our ambition is to deliver one integrated development platform for all of the development teams in our organization. Dutch Railways wants to serve an end-to-end journey to our travelers. We, as a Central Platform Organization, want to bring this experience to our development teams. We need to serve our platform capabilities as one platform. We will illustrate our approach. What developer teams do on a high abstraction level is always the same. They develop the software, they promote it, and they want to run it in production. Developers work on a developer workplace, and the software lands at the platform in the public or private cloud. We begin by identifying the capabilities that need to be developed. We call these our steps in the development journey. On a high level, These are the steps were identified. The detailed image wasn't suitable for this presentation. Why is this model so important for us? We found out that it is pretty difficult to transform all of our existing platform capabilities together towards a new single platform as a service ambition. Different platform teams are successful in what they are doing, and the change towards one integrated platform costs time. Time they cannot spend on their successful capabilities they already have in place and are serving to the teams. So designing that target platform ambition and get a focus on it is pretty hard. It's big, even when you split it up into different stages. On the other hand, we do see that people in the platform teams are very willing to collaborate on specific items.
So, we need a senior narrative. And people love stories. So this is Mark. Mark is not a developer, he's our new functional cluster lead DevOps and QA. But not in this story. In this story, he represents all our software developers. And yes, that includes testers. Mark wants to build an application and he wants to run it in production. Not just any application, but the most important application in the company. Mark likes to think big. So he sets off on his journey, and you could call it a developer's journey. Getting into production requires many tools, connections, and adhering strict security standards. Suddenly, production has the feel of a huge fortress. This is where platformization comes in. How can we help our developers? We should not only follow the same paths, but we should pave them. So we bring the knights together, not on political issues. No, our knights, platform teams, want to talk business. They want to talk technology. That's the language that empowers them most. So we bring people together around technology. And every 3 months we sit around a square table and look at the opportunities and obstacles. This is what they want to do. This is how we work. But let's see how deep the rabbit hole goes. And don't let these slides fool you. There's a story behind each one of them. Remember the fortress, the knights? How can they deliver when they have hundreds of tools to build, deploy, and support? If we really want to help, we have to choose first. And we already have too many choices. We don't need choices. We need to ensure consistency and high quality in our platform products. It's important that we give our developers clear guidelines, a well-defined set of tools. This helps them focus on what's important, building high-quality products, without spending unnecessary time on tool choices, implementation, and connecting tools, platform, and landing zones before they can use it and add value with it. Adopting a tool should be as easy as picking up a screwdriver. The outlines of the tech stacks are defined by our architecture department. They have identified 6 tech stacks. Basically, each tech stack is its own developer journey. We took the outline from architecture and filled in all the stages with skills and tools. These aren't new tools, they're tools that are already widely used by our product teams. Some of these tools are already standard. For other capabilities, it's not so clear. Or the capability has no supporting tool. Some examples of tech stacks are Java, but not limited to the Java programming language, low-code, and data science. Examples of underlying capabilities in the above stages are code review, version control, and secret scanning. The tools vary from Slack to Azure DevOps to Playwright. These tech stacks can only deliver value if they meet the needs of the developers, with whom we connect through our various channels. One of them is our DevOps and QA functional cluster. Remember that place? The place where engineers come together in communities to connect, learn, and collaborate on products. As a platform organization, we need to play an active role in this. So can all tools be mapped on these tech stacks? No, because not all tools are specific to a development language, but rather to a landing zone. So besides this list, we have 5 landing zone types: private cloud and public cloud. Solutions like AKS. Examples of tools are Chekhov, TerraTest, and Argo CD. Together, they form the ultimate developer journey, including dev and ops. Will this make everyone happy? No. Still, there's so much more to tell about this, but there's no time. Someone famous once said, there's a difference between knowing the way and walking the way. We didn't start from scratch with this approach. Things grow, things evolve. Like any good story, a few years ago the testers were organized in a central department with more than 150 testers and 15 test managers. This test competence center helped the testers to connect, learn, and work together. There was a centralized team of experts working to support the testers in performance testing, test automation, and security testing. We soon realized that we couldn't support the entire organization with just 5 experts. So we developed Frameworks in a Box, a ready-to-use performance and test automation framework fully configured, complete with tutorials, workshops, and servers to work on. This helped, but again we ran into scaling problems. We still ran into support issues, where we were still spending too much time on implementation issues. So this had to be solved. And to do that, we adopted the well-known principle of paved roads, as mentioned by Netflix, and also known as the Golden Path. They both follow the same principle. As a visionary once said, "Where we're going, we don't need roads." And he may be right, but until then, paved roads. By providing a predetermined, optimized path, the platform organization can ensure that product teams are able to quickly and efficiently leverage tools and technologies available, without having to worry about the underlying architecture. It's a pre-architected tool solution that is fully integrated with the IT ecosystem or tech stacks. This approach can help reduce complexity and improve efficiency. In this context, paved roads can be seen as a way to provide a consistent and cohesive set of tools and technologies that can be easily leveraged by product teams. By removing the burden of configuration and implementation, the platform organization can enable product teams to focus on building software that meets the needs of end users. The paved road essentially focuses on a predetermined tooling solution, and by implementing this across a tech stack on the developer journey as a whole, teams can follow a fully supported path to production. Standardization, the word alone will make some go mad, but usually the best people are. It is often seen as something very annoying and not suitable for an agile environment, but we all know it is necessary to deliver high quality, secure, and fast products. Of course, standardization is nothing more than an agreement, and if the situation demands it, teams are free to deviate from the paved road. The only difference is, in this case, you are obliged to make sense, and you'll have to overcome some hurdles, like complying with corporate standards, such as security. We started with the paved roads of test automation, integrating with the tech stack and landing zone. This was quickly followed by performance testing, which has its own challenges, where we had to provide a load solution for each landing zone. Now we are seeing solutions pop up from pre-configured pipelines to ready-to-go landing zones to security solutions in the pipeline. Now it's not all roses. There are still many challenges: alignment on architecture, terminology, communication, prioritization, tool selection, and tool lifecycle. What we have gained from the developer journey, the tech stacks, and the paved road is a shared understanding of where we need to go. As said, connecting people through technology. Shared interest and knowledge is key to creating a collaborative environment where individuals can build relationships, share information, and work toward a common goal. By connecting people, we break down the silos that often exist within teams and enable individuals to connect and collaborate across teams and departments. By creating a sense of community and belonging, we help our platform organization function as a cohesive whole with fewer team silos. In addition, connecting people always allows us to tap into a wider pool of talent and experience and create a culture of continuous learning and development. So whether you're looking to improve collaboration within your organization or build stronger relationships with customers and partners, connecting people through shared interest and knowledge is the way forward. By putting people at the heart of our strategy, we created a more connected, engaged, and productive workforce and drive greater business success.
This is a story about bottlenecks in our platforms. Thinking in platforms as products helped us to build better platforms. The program that implements Zero Trust network architecture asks us for assistance. Can you come up with 6 product teams for a pilot to connect the developer endpoints to our infrastructure? What connectivity do they need? And can you facilitate the pilot? Since endpoint connectivity hits all of our platform products, this was a big chance for improvement. It was hard to answer this question. In software development, we typically answer such questions based on our test set. It tells us how the product is intended to be used. For platforms, there should be no difference. Our test engineers supported us with a test approach. We took to the developer journey as a starting point for clustering and writing down the test cases that describe the intended use. Describing the connectivity was step 2. This way, we described how our paved roads from an integral perspective should work. And during pilot phase, we discovered the gaps in our paved roads. The benefits? We can deliver better quality to the teams. This is not only cost efficient, but also supports knowledge sharing over the teams, making teams more flexible and self-service. And for the program, we were able to reduce the pilot period. We did similar things for further development of our container stack and also introduced test automation to it. Not only improved the quality of the stack, but also reduced the feedback loop for further development of the platform. The second story is about using opportunities that just happen. Remember last year, the Log4j major security vulnerability? It was an opportunity to extend the capabilities of our platform. Software development teams needed quick insight into software parts of their products, the so-called Software Bill of Materials or SBOM. Based on that information, they could fix their software. The security specialists in our organization directly created software to inspect the code repos for this vulnerability. Later, we developed this so-called SBOM service as an extension to our platform and also consolidated other capabilities like container registries to it. We now serve this capability to the central specialists in our organization. The second step is to further develop it as a paved road solution and bring it to the teams. Creating both a centralized and a decentralized solution has the advantage of offering the same view on the vulnerabilities at different levels. This paved road solution gives the more security-minded teams the tools to mitigate vulnerabilities proactively, while the other teams can be hinted by our security specialists. We will extend this solution with awareness workshops and other capabilities for secure software development. A nice example of how we connected people in different teams around technology. Thank you very much for listening to our stories. I hope you have enjoyed.
Everyone, thank you for joining in. I am Ravi Rajan. I'm a platform engineer at OLX, and today I'll talk about some of the learnings that we got when we provisioned and managed about 150 odd on-demand environments on a single Kubernetes cluster. It has been quite a journey for us, and along our journey we have hit some of the bottlenecks, and I would present you the ways we have tried to solve those. So without further ado, let's get started. So to set up a context, at OLX Autos, we are running our own IDP, which we have developed from scratch, and we like to call it Orion. Just like all other IDPs out there in the market, Orion also have a feature of on-demand environments, with the help of which you can create an entire Autos environment, and each of those environment would house around 180 microservices. And as of now, Orion manages about 150 plus concurrent environment, 16K pods and 13K, around 13K plus Helm releases. And all of these environments are on a single EKS cluster. So what I have done is I have divided this talk into 3 sections, or I would like to say the lessons that we learned. In the first section, I would talk about how we identified and fixed single point of failures for all of our environments. As I've said that all of these environments are running on a single Kubernetes cluster. So there are some tools that are shared amongst all of those environments. So we'll see how it got in our way and how we solve those common issues. Next section will talk about how we expedited the overall environment provisioning time. Since one of the use case of dynamic environment was to have it integrated into our CI system, so we wanted the overall pipeline execution time to be at minimal. So yeah, I will talk about that. And the last one is how we optimize the overall cost of an environment. So it is a no-brainer that we have used spot instances for this use case, but bringing in the spot instances have also bring in some challenges along the way. So I will talk about those challenges in that section as well. We'll explore about the first section first, which is eliminating your weak links. So as we scaled in terms of number of environments, we started noticing a weird issue wherein some of our workload was getting in crash loopback state for some reason. And this workload would typically include Prometheus operator, Ingress controller, and API gateway. So you could imagine that these are critical to every single environment, and these were shared among all of the environments. So any outage in any of those can affect your performance and performance of all of your environment. So to understand this issue, let me refresh your memory about Kubernetes controller, how it works in general. So every Kubernetes controller use informers to apply a list watch on one or more Kubernetes resource, right? So this is the image which I have took from Nginx controllers documentation to how a controller works. So it would remain much same for all the controllers as well. So informer would initiate your list watch to one or more KTS resource, and along as soon as you create, update, or delete any of those resources, you would register a handler along with that as well, which generally would enqueue all of those action along with those element into a worker queue. And at last, which is this controller, this is actually a reconciler in which you implement your business logic to how to handle those resources or how to converse to your desired state. For the case of Nginx, it would be to configure your configuration. So most of the controller works this way in general. So one of the things which was the issue was, as we grew in terms of number of environments, our number of resources were also getting increased linearly. So our number of services, endpoints, pods. So for case of Nginx, it applies a watch on services, endpoints, pods, and ingress. And every time there is some change in any of those resources, a reconciler has to reconcile the configuration again and again. So this might not look much when you will consider a single environment, but let's say our environment right now comprise of, let's say, 100 services on an average, and we have about 80 odd KTS services, 40 app secrets, and these many Helm secrets and pods and endpoint. One critical thing that you have to keep in mind is we generally ignore Helm secrets, but for every release that you push via Helm, a secret is created in which we generally store your releases detail. And by default, the default history of Helm is about 10, and so these at max it can create about 10 into 100, which is 1k secrets per environment. That is what I'm talking about. So you could imagine, if I'm talking about hundreds or 200s of these environments, how significantly will start increasing the number of resources and number of pods and endpoints. So this will definitely impact the performance of each of your controller. Two at a time, your controller would be in crash loop back state. But say, let's for an example, if this would have to happen on your Nginx controller, so all of your environments behind that Nginx would be rendered useless. They would be just like burning money out there, because you won't be able to reach to those services because your controller has died. So one quick fix which comes to anyone's mind will be to vertically upscale the controller, but there is a limit to how much you can upscale in terms of resources. So there should be a better way to handle this. And so the two learnings or two ways we can handle this is, first, always limit your controller watches. So any of the controller would generally include some of the parameters via which you can control the watches of that particular controller on the basis of, let's say, namespace or field selector. So definitely use those. From my personal experience, we have gained some significant performance improvement by limiting the watches itself. And again, there is a limit to how much you can limit those watches, right? Say for Nginx, you have to watch services, right, of all those environments, but at that time, let's say we have limited everything, and that is also not even working out. So another alternative was to limit the watches on per environment basis, or to segregate those controllers on per environment basis. So before launching the fleet of services of those environment, we can spin up a controller just for that particular environment. So this would be useful for the cases in which you have a very critical workload, which such as your API gateway or Nginx controller. So in those scenarios, we have found out that generally spinning up a controller for that particular environment would limit the scope of single point of failure, because if we are having controller at per environment basis, then let's say for some reason our pod is impacted, the controller is impacted for some reason, it won't affect the other environments in the cluster. So yeah, these were some of the learnings. Moving on to the next issue. As we again grow in terms of environment, we started noticing that there was a very high response time on all of the services across all of the environments. So this was another issue that we got. And what we find out was that this was the issue related to DNS, just as always, right? It's always your DNS. So when we check, the current state was we were running core DNS. So a couple of pods of core DNS was working fine for us for a long time. But as we scaled, we thought that, okay, core DNS itself uses a Kubernetes plugin, which in further start a watch on the number of endpoints and services. So maybe again, it was the controller behaving weirdly. But apart from those also, we observed that there were a lot of unsuccessful queries at the core DNS logs. So one issue was that, and we noticed significant spikes in the resource consumption as well, because obviously we were scaling in terms of number of resources, so that was bound to happen. But why we were having some of those many unsuccessful queries, we'll discuss it in the coming slide. And core DNS was again a single point of failure for all the environment, because entire clusters services would be impacted if the core DNS was not working, as expected for some reason. This was another single point of failure in our scenario. So what we did is, so the issue of unsuccessful queries was because of a single dot, right? So to get into the details, you would see generally your all of your pods resolve config file includes three search domains. For example, in this scenario, I have echo, which would be my namespace, and SPC cluster local, and this and this. So there are three search domain using every resolve conf of each of your pods, and this is your name server, and this is your value. So what I have done is I spin up a pod inside the cluster, and I try to resolve this address platformcon.com. And if you would see, I have not appended a dotted last, which would mean that this is not a fully qualified domain. So you would see that number of queries that I have to do to do in order to resolve this address was 5. And herein you could see that obviously the search domain was getting appended to each of our queries. So first time namespace.svc cluster, then svc cluster.local, and so on. So you would see that number of queries was 5 and number of unsuccessful queries was around 3. So obviously we were making some of the unnecessary queries there. So how to solve this, right? The solution was fairly simple. It was to append a dot at last, so it would make this a fully qualified domain name, and you don't have to search for all of those search domain that you have in your Etsy resolve. So in this scenario, you would see that we got only 2 queries and we find any of the NX domain issues. So yeah, that was something. So we tried as a best practice to always include a dot at last or use fully qualified domain name in all of our services. So with the help of this, we reduce the number of unsuccessful queries at DNS. So that improved our response time. But that was not it, because again these queries have to be resolved by core DNS at some point, and you can imagine that there will be some point in future wherein this core DNS would run out of its own resources and we'll have to manually intervene to upscale the core DNS pod again, and then the same story repeats, right? To how much you can upscale or how to handle this, right? So just like the controller, we thought using a same technique, that is it possible to distribute the load in terms of how we are scaling. So core DNS load should also be distributed accordingly, right? And one of the amazing way to do this was to use a local cache. So there exists a project called Node Local DNS Cache. You guys would have heard of it. So with this, what we do is we run this agent as a daemon set inside the cluster. So all of your DNS query, so it is again a core DNS application in itself. So it uses a cache plugin. So what it does is all of your queries are intercepted through IP tables to this particular agent, and if it is found in your cache, then it is returned from there, else it will reach out to your upstream DNS, which is core DNS, the main kube DNS service, right? So implementing this helped us a lot, because as we grew, we increased the number of nodes, and on every node now there is a local cache of DNS, and those would be used before reaching out to your core DNS. So we distributed the load at the main core DNS to these local DNS caches, right? Now again, right, so there is again a single core DNS which again has to resolve some of the IP addresses at some point. So we have to ensure that those main core DNS instances also horizontally scales as we expand our cluster, or by expanding I mean number of environments. As number of environments are getting provisioned, it should horizontally scale itself as well. So there is another tool that you can use, which is cluster proportional autoscaler. Now using this, you could set up a linear or a ladder based scaling policy in which you can specify your cores or your number of nodes. So you could make a linear growth. Let's say for every node you want a single core DNS instance, or every 4 node you want a core DNS instance. So as you grow in terms of number of nodes, you can upscale your main core DNS instance as well. So you could have a linear policy or a ladder based policy to horizontally scale your core DNS instance as well. So yeah, combining all these three, the fully use of FQDN and implementing node local cache and proportional autoscaling, we were able to significantly reduce our response time. So herein you could see a graphical representation of our benefit that we got while implementing those 3 strategies. So yeah, that now comes to another section. So it is about how to expedite the overall provisioning time so as to improve the overall pipeline execution time. So let's see. Okay. So what we did is we introduced some of our static provisioner, and so we do understand that we will be wasting some compute, but we were able to compromise some compute if we can gain some of the improvement in terms of provisioning time. So what we did is we spawned some of the POS containers, and those having the pod priority uh, less than the actual workload. So it ensured that we have some certain instances always lying around, which could be utilized by an environment. So let's say if our CI is triggered, we can use those instances or those nodes to provision the actual workload of the environment. And so they don't have to wait for a node to actually be provisioned or registered with your Kube API server. So we save those precious around 5 minutes of the time by making use of those over provisioners. So another thing that we did was to maintain an warm IP pool. So we are using AWS VPC CNI in this scenario. So by having a certain pool always there, we can ensure that every time a new pod comes on to your node, it no longer has to reach out to your service provider. For example, in our scenario, it don't have to call your EC2 API every time it needs to get an IP, right? So you can tweak these settings using your minimum IP target and warm IP target. But I would suggest to carefully make the decision of what your target pool should be. Don't get, don't go too overboard on this, because if you have limited IPs in your subnet, then this might trigger another issue of your IP exhaustion. So what we did is we found out a solution that most of our instances are sharing same type of compute. So let's say 8x large. So we'll be using M series 8x large, C series 9x large. In that scenario, we have, in terms of CPU and in terms of memory, we have consistency in terms of nodes, right? So we calculated our average pod density at that time. So we set this minimum IP target to be that value. So every time a node is provisioned, there is always, let's say, if our pod density is 20, then we'll have a 20 IP address always in buffer, right? And warm IP target, we kept at 1 because we wanted to conserve the IP there. So using this, what we did was every time the pod was getting provisioned on any of the node, it always has to, it could easily fetch the IP from a local IP address manager, and it does not have to call your main EC2 API to fetch that address, right? Not recently, but AWS CNI now also supports prefix delegation. And now what they are offering is you can, every time a CNI is provisioned, that CNI will bring in a /28 subnet address along with it, so which calculates to about 16 hosts. So by enabling this and maintaining a warm prefix, again, let's say of 1, you would be maintaining a buffer of around 16 IPs. So till 16th pod, you don't have to invoke any of your EC2 APIs. On the 17th pod, you'll have to invoke a call which would extend your prefix to more 16 addresses. So either of the way, you could use any of them. We tweaked it using minimum IP target. So with the help of this warm pool in conjunction with over provisioner, we ensured that every time a new environment is to be provisioned, there are some certain IPs reserved for it and some compute reserved for it. And we noticed a significant improvement in overall time reduction that we were having earlier, right? So yeah, now let's move on to our last section where we will discuss about how we leverage spot instances uh, for the case of on-demand environment. Dynamic environments were ephemeral in nature. You could create them or destroy them at any point of time. Though some were a long-standing environment as well, we saw that it fits a perfect case to use spot instances, right? So it was a no-brainer for us, and we did implemented all of our fleet using spot instances. But using spot instances bring in a couple of challenges with it. So these two are the one which bothered us the most: the spot interruption and limited availability. With spot interruption, as you guys know, that the spot would be taken back at any point of time with a notice before in around 2 minutes before. And the other one is its limited availability. So we were running a single replica of all of our applications, so we need to ensure that we gracefully handle those interruption, and every time our environment is getting provision, we needed to ensure that compute is there to support that environment, right? So to solve these two challenges, what we did was, this is for spot interruption. So there is a project called AWS NTH, or node termination handler. This is something which I have prepared. So what it does is, let's say if your fleet is you are running on EKS cluster, and you have an auto-scaling group or the EC2 instances. What you can do is you can create some events in your SQS using an event bridge. And if there is any event of type EC2 spot instance termination warning, you could enqueue it to that particular queue. So every time any of the spot is taken back from AWS, an event is to be placed inside your queue, and there is another agent running inside your cluster, which is this NTH pod here. What it would do is it would dequeue that particular event and the details to which instance is going down, and it'll gracefully move out your workload. So it'll first cordon that workload so as to avoid future pods getting scheduled on it, and all of the existing pod would be drained properly to another node. So this was an amazing way to handle the spot interruptions, and there is couple of ways. So this which I explained you was using a queue processor, but there is another way which is using instance metadata service monitor. And if you'll go by this path, then you'll have to deploy this NTH using daemon set. So what it does is it listens on your instance metadata service address for EC2 events, and whenever there is a termination going, it'll do the same thing. It will cordon and drain out that particular node. So this helped us in handling those spot interruption. And the another piece was to how to handle the unavailability of spots. So let's say if you are using 2x large instances, and if M5x large is not available in your region or in your AZ, then how to handle it. So first and foremost, most of us know that instead of using a single instance type, what we could do is we could create a launch template and include bunch of similar compute instances together. So here, and let's say all of the 2x large of different series I have included for, let's say, M5, M5A, M5D. So we could include a bunch of these instances inside a single launch template. So let's say if M5 2x large isn't available, so we could switch over to M5A 2x large, right? So let's say even if all of so this helped us reduce or tackle this unavailability issue to some extent, but we noticed that in some scenarios, all of those instances were also not available, although it was uh, less frequent, but it was an issue. So what we did is we used cluster autoscaler's priority expander. So what you can do to handle those scenario is in cluster autoscaler there is a expander configuration which you can pass in. So in, for example, what I did is I used this configuration of expander. So in this I assigned some of the priorities to our node group. So here in this on demand is basically the node group in which the launch template would contain on demand instances, and the spot is a node group which contains all of these spot instances. So now what will happen is since the priority of spot instances is higher, so first it will try to launch all of the spot instances using this launch template. So it will try to first do the launch of your primary instance. Let's say M5 2x large in this case, but if 2x large isn't available, it will check these kind of instances, and if all of them are not available, then it will fall back to on-demand instances in our scenario. So it would ensure that at no point in time your cluster is exhausted out of your compute. So this would ensure that every time, let's say, a CI is triggered, there is compute available to you so as to provision your environment. So yeah, I think this sums it all. So using the spot instances and managing the potential shortcomings of it, we were able to confidently run all of the on-demand environments on Spot Fleet. As of now, we are managing all of the environments 100% on Spot instances. And with that, I would like to sign off. I hope you will find this talk useful. If you have any doubts, I'll be available today on the Slack.
Hi folks, I'm Steve. Thanks for checking out the session. I'm going to dive right in. This is a case that I worked through with a client last year, an extremely large telecom company here in North America. But I think it kind of exemplifies the early stages of what good looks like and some of the things to avoid. What works well, what I found really helpful, and things that you can implement in your environment, whether that's large or small scale or wherever you are in a platform journey. So let's dive right into it. What are we talking about? I'm going to set the stage a little bit, talk about a little bit of context, going to talk about the idea of crafting a pilot. So starting small with something that scales, that represents what we're looking for at a large scale, but without all the risk of a big bang. Nailing the basics. Before you scale it, you got to nail it. So what does that look like? We're going to also talk about gotchas and tips, so things that might get in the way and how to avoid common challenges. And then I'm going to give you a couple resources for taking next steps on your own. So a little bit of background. I was working with an organization doing a large scale implementation last year. They had kind of like an incubation area inside the organization, kind of like an innovation center, and lots of good practices kind of spread out across multiple teams, no real standardization, no common infrastructure, no platform to speak of. And they're starting to see the challenges, right? They're starting to see duplication of efforts, duplication of code, lots of confusion, lack of standards, low quality, lots of friction, lots of chaos, basically. And so before you kind of take this and consolidate it into a massive platform effort for the entire organization, you've kind of got to sort out the house at a small scale. You got to figure out, if we can't fix the innovation center, if we can't get them operating effectively, then how are we going to implement this at, a gigantic Fortune 500 company? This is kind of based on previous work too, like very similar model. They wanted a platform that they could use internally, but ideally sell to their customers, right? They see the Amazon model. They've seen the opportunity with having a very highly capable, high-value platform that can not only improve operations internally, but then provide a service, a valuable service to customers and partners. So not only are we solving this problem internally, we have to productize, right? We've got to make this a valuable effort to external customers, which means a higher level of security, a higher level of capability, customer experience. But there's a lot of value there, right, if you can capture it. So I presented last year on Predix, GE Predix, which is kind of like served as an example of what not to do in this case, right? We're using a lot of the things that we learned coming out of Predix, which was a very similar goal, right? They wanted this platform they could use internally, but they could also sell outside the company. And so learning from those mistakes, we set out to create this pilot success model that would scale to the large organization. And we started working collaboratively, right? So anyone who knows me knows I'm a huge fan of collaborative mapping. And that's the approach that we took here. We started bringing people in, collecting their perspectives, ideas, pains, challenges, mapping out a target outcome from different perspectives. What does this look like in terms of obstacles? What's between where we are and where we want to go? What does where we want to go look like, right? It turns out that there was different target outcomes depending on who you ask, right? Depending on the target customer. We have internal stakeholders, we have internal contributors who are going to be leveraging a platform. We have partners, we have domain experts and accountable parties like security teams and compliance teams, and we have regulators. So we did a lot of mapping. We did a lot of mapping on, who's the most important customer here? Who are the customers we don't want to forget about? And ultimately, what is the most important target outcome that we can focus on? Because you can't do 18 things at once. So we narrowed this down a little bit, and through mapping it out, we arrived at this target outcome of a self-service platform that would make it easy to do the right thing and hard to do the wrong thing, right? I mean, that's pretty high level. It's not specific, but it provides us guidance, right? We know that that means our customer, or at least this initial phase, is individual contributors, right? We understand that we have to make it seamless and easy for them to do the things that they need to do. That has implications for onboarding, access, self-service, documentation, user experience. And then hard to fail, meaning that we have to provide guardrails to enable things like security compliance, regulatory compliance, help people understand where they might be adding code that introduces risk or technical debt or complexity, right? So even though this is a very high level, somewhat nebulous target objective, we all can have a very good conversation about what it means. And that all got mapped out. We sort of exhaustively did this brain dump across everybody involved into a common place where everybody could look at it, agree, disagree, discuss, and align on what we're talking about and where we're headed, which is super valuable. So after that, what we did was we value stream mapped. So we mapped the current process that is involved in delivering code inside of our pilot team. So we mapped out all the activities in order, how long it took. We highlighted areas that were exceptionally, let's say, challenging or time-consuming, and added it all up so we could understand how long does it take to do these things right now? What is the cost of those things? And we understood how much of that was wasted time, how much of that was getting in the way of doing the right thing and doing it efficiently and effectively. So we were able to highlight 2 hotspots there. That's valuable because it takes everything that you could be looking at and narrows it down to just what is the main friction points, the main pain points that we could be looking at. And from there, we could dig in and we could talk about things like different tools that are used across the entire workflow. If you're implementing a platform approach, you want to make sure that you're integrating and incorporating all the tools that are involved so that we don't have context switching, we don't have friction for, as a developer, moving through this workflow. So that brought us to the pilot, right? What are we going to do to address the target outcome, knowing the pain points that we've highlighted in the workflow? And we could have highlighted everything from security, quality. You can really map anything onto a value stream map that pertains to workflow. So where quality becomes challenging, where we're not meeting expectations or specifications. So the value stream map really gave us like a framework for understanding the workflow that needed to be addressed with a platform. And what it also allowed us to do was highlight where we saw challenging dependencies. So if we look at something like deployment, we can understand by digging into that where we have external dependencies that are currently served by shared services. So when we need to deploy under the current workflow, we've got to go talk to the data team, we've got to go talk to the DevOps team. They do things for us. It's why things are taking so long. And we can look at what are they doing? What are the things that they provide that we could hopefully address through either automation, less friction, maybe instead of asking through Slack, we can fill out a form that automatically populates a ticket or whatever. We can start to look at what are the friction points in the workflow. And when you talk about addressing friction points in the workflow, those teams, the shared services teams, are providing capabilities to us, right? So we can look at what are those capabilities and are we actually able to provide those either through automation or doing them within the team? How do we enable self-service, right? So we can look at these capabilities from a couple different dimensions. Who owns them, right? Do we understand who owns these capabilities? Does anyone own them currently? Is there a backup for that ownership? Is there somebody that we can go to? So inside of our team, if we're trying to take over something like data refresh, do we have anybody on the team who can actually do that? Or do we have to look at just making it easier to access that capability? So we can understand that better by evaluating the skill level in the team, the resources available. That could be anything from documentation to APIs or integrations. And then we can pull all this together into a score. So when we're talking about achieving our target outcome, these capabilities are really what is going to enable that at scale. And we can have really good conversations about where we see the most challenging aspects of addressing those capabilities. So another lens for this is you could take a value stream map and you can layer your dependencies and capabilities directly on top of the friction points, right? So we can understand, we can highlight where the hotspots are and where the dependencies relate to those hotspots and the capabilities that are related to those dependencies. So all this really just makes it easier to have really high value conversations and get on the same page about what are we going to do about this stuff. So that all funnels into, there's many maps that I'm not able to share in the time that we have, but we're able to understand all of this together and look at breaking it down into things like, what are the standards that we want to incorporate into the platform? How are we going to prioritize our efforts? How are we going to actually make progress? There's a portion of this that's just dedicated to vocabulary. What do we mean when we say X, Y, Z? When we say platform, what are we talking about? That's all really important if you want to nail it before you scale it. So specifically about nailing it, the approach that we took was all about understanding the flow of work, right? So because primarily what we're trying to enable is making it easy to do the right thing. That's like focusing on workflow and a frictionless user experience for the individual contributors who have to be doing the work. And we focused on an internal development platform as a way of enabling that self-service. And we could broaden the scope of that by understanding, okay, well, where are we currently, right? So the ecosystem that we're operating under looks like this collection of product teams and platform teams that are entirely bottlenecked by shared services in the current state. So we understood where we were over relying on custom interactions with this team that's super overloaded. And we would have to break that pattern by introducing a platform that provided self-service. So we didn't have the bottleneck of shared services anymore. But we're able to map this out and then talk about it really productively by using this visual collaborative mapping. So how do you do this? How do you screw this up, right? So what does it look like to really not execute this well? And this idea of as a stadium on a desert island talks about a couple things for me. We're talking about not building something before we have an audience, before we have customers, right? So we want to understand from the people that we're building things for what they need. What are the issues that they have? Let's focus on the most painful, the most valuable, instead of everything that we could possibly target. And let's go and attack those things very specifically. What are the capabilities connected to those things? What are the dependencies that make those things challenging or unproductive? And then communicating effectively, right? So communicating with all the stakeholders who are either involved or affected or that we need to participate. It's all super important. So if you're interested in more about this approach, this idea of collaborative mapping that's specifically focused on workflow, I've got an ebook and an email course at this flow.visible.is. It's my website. If you're interested in hearing more about this, talking about this, if you've got a challenge that you'd love help with, I would love to talk to you. Thanks very much for checking out this session.
Greetings, PlatformCon 2023. I'm Skylar Bishop. Today is April the 11th, 2023, and I'm coming to you from a sunny, beautiful, and warm Chicago, Illinois. I'm going to talk to you today about the cultural risks of thinking that your shiny new internal developer problem will solve all of your engineering issues. A little bit about me. I founded an internet service provider in my family's garage back in the mid-90s. I worked for about a decade as a computer modeler, water modeling for the Army Corps of Engineers. I met Docker first in 2015 in a greenfield team that was autonomously deploying to production on demand with Bitbucket and Bamboo. Then I moved into cloud architecture, cloud consulting, and later into engineering management. And most of the reason why I moved into leadership was because I really wanted to work for people that believe like I did about what engineers should be enabled to do versus told what to do. So this is a combination of all of those things. as you may know from my talk last year, I have a couple of Star Wars references. Fewer this year, sorry about that. But this is the first from episode 4. Rebel platform engineers striking from a hidden base have won their first victory against the evil manual deployment team. And during that battle, Rebel spies managed to steal secret plans to the Empire's ultimate weapon, the internal developer platform. And like Star Wars, the Rebels used the plans against them. Now, last year, the perspective in my talk was really focused around the important role a tech product manager plays in that platform engineering team. And this year, I'm building on that. I have a new company, a new job. I've Jedi mind tricked myself into leading the software engineering organization. And my perspective is different. I've got new experiences, new lessons, and new mistakes. So now let's say that you've done the hard work of creating your internal developer platform. Whether you built it yourself and went out and bought one, you've implemented it in whatever way that you did. Teams are able to create ephemeral environments on demand. They've got access to your service catalog to deploy these paved roads, which are approved modular starter kits typically. And it all just works magically by default with your CI/CD platform, or at least it should. Now, your developers celebrate by opening tickets for your platform engineering team to fix or deploy things as they've always done manually. The support ticket counts spike, productivity doesn't increase across the board, but it does in pockets. And now your PE team is overworked and demotivated. It's very important to understand where you're going because teams have momentum. Individual teams have individual momentum and direction, and changing that direction takes time. So you need to communicate the benefits and costs early and often and level set with product leadership in the teams to drive that early adoption. So you got the tech right here, but you missed that the skill and the cultural changes probably should have happened before that. Well, now what do you do? And better yet, what could you have done first to prevent this? So here's the 4 parts that we're going to go through that today. How do you define that abstraction boundary of your platform, and why is that important? Organization structures are hard. What engineering cultural practices help adoption of these new automations? And how do you measure the uptake of skills and culture? So part 1, both you and your IDP need boundaries. When you clearly define the abstraction boundary of your internal developer platform, you're enabling your developers to focus from the boundary out. Conversely, you're allowing your platform engineering to focus from the boundary in. And that means they know where their responsibilities start, and PE can focus on their side of the boundary. Your assessment and understanding of your engineering capabilities, the skills your engineers have, the products that they create, and how they do their work are key to defining this boundary into the success of your IDP. But there's more. You'll find that those boundaries will invariably be wrong. So renegotiate them continuously. And this requires a great relationship with your engineering team leadership, product leadership, and your engineers. And don't forget to enable them versus tell them what to do, or worse, to do it for them. And as any good parent knows, or any parent probably knows, you may need to let them fail safely. Section 2, organizations are hard, and especially org structures. So like everything else in technology, DevOps and Agile are about people, processes, and technologies, and I believe in that order. People are the highest value to get right, but the hardest to change. Processes are somewhat in between. And finally, technology is the easiest to change, but the lowest value. Now, I would challenge anyone to look at any kind of a broad organization-wide issue with people and processes and to tell me when a technology has ever fixed that. I'm sure it's happened, but I don't think it's very frequent. Typically, technology does not fix process or people problems. So what then defines a good engineer or a great engineer? Well, I think these 3 are good starts. Curiosity and a never-ending desire to learn, lifetime learners, a willingness to try to new things, to fail, and to try again. And finally, I believe these 2 combined generate a relentless drive to understand and seek depth of knowledge. And I'll give you a particular example. I have a senior engineer in one of my greenfield teams. They created everything net new with all the latest automations. They wanted to do one seemingly simple thing. They wanted to put templates on their pull requests. They like their templates. Don't ask me about the reason why, but this is a sticking point for them. They wanted their PR templates. And so he did a deep dive into the automations to understand how they worked, to create that repo and to enforce some of the naming standards and things like that on the repos. And so he went through all the automation, all the documentation the PE team put together, and he determined how these repos were getting created through the automation. And because we also strongly believe in democratizing access to everything, he was able to go into things like Terraform Cloud, GitHub, and see the actual code that was generating these automation flows. And like a good open source programmer, he submitted a pull request to the PE team to fix the problem that he wanted, which were these PR templates. Now, I think that's a really great personification of that relentless drive to understand and seek that depth of knowledge. So what didn't I mention when I mentioned those three before? Well, I didn't talk about technical skills. And hopefully that's the obvious one. Now, they're the base requirements but I don't think there's a strong correlation between pure technical skills and great engineers. I've worked with hundreds of software engineers, and the best that I've worked with were not the deepest technically, nor were they the most experienced. They were typically the engineers that built clean, tested code and had killer instincts about what good enough meant. Great engineers also need great engineering managers and evolving flexible org structures. If you don't have engineering managers and leaders, hopefully you have a really small organization, or else you won't have the scale to drive that change and the ability to drive that change broadly. Now, I'm a big fan of not reinventing the wheel where it makes sense. And I think Will Larson's book, An Elegant Puzzle, Systems of Engineering Management, gives a lot of great learned lessons that Will had along his journey of engineering management. Now, I'm also a huge fan of Charity Major's blog. She's speaking in this conference. Go check her talk out if you haven't already. And her blog is charity.wtf. But both of them do much more justice to this than I ever could. Just realize that this is a solved problem and don't try to reinvent it. Take on the concepts and actions that these other people have gone through, they put their blood, sweat, and tears into, and build those up into your own. Piece them together in a way that makes the most sense for you, your organization, your company. Just be super careful not to hire too many too quickly, where your onboarding doesn't really get the attention it needs to. Don't overhire and don't underhire. Now, if that sounds complicated, well, it is. It's complicated. So just be careful. So part 3 is what cultural practices help the uptake of your internal developer platform? The answer here is, well, like any good former consultant, it depends. And it depends on what your outcomes need to be. Is your employer a startup? Are they a 100-year-old enterprise? Are they a manufacturer? Are you a lemur? These are obviously very important questions to ask yourself. And what does it need to be for your company and for your situation? And I'll tell you some of the outcomes that I drive towards. I want to see anti-fragile code bases that have deep investments in testing, automation and instrumentation are clean. I want to see services that are fully owned by the software engineering team with little to no external dependencies and interdependencies. And I want to see services that have service level objectives defined, refined, and aligned. To get these outcomes, here are some common practices. You want to have a deep partnership and interdependence with your product management organization. Your engineering tech leads should probably be in vertically aligned product teams that drive the culture and adoption for that particular product. But finally, realize that every team is unique. I said that a few times. Don't be lulled into a belief that one size fits all. So tailor your response to your teams. Part 4, final. How do you measure the value and success of your engineering culture? I think these key metrics should be carefully and broadly versus specifically used and can give you an organization level view of your engineering performance. Now, I lean heavily again on the solved work that Gene Kim, Nicole Forsgren, and Jez Humble did in their 2018 book, Accelerate. And now they talk about the 4 key metrics. Many people would argue these, but I think they're good places to start. Deploy frequency to production. In the book, they talk about how that's a proxy for batch size. Small batches, lean principles, that's what you're driving towards. Small changes mean small failures. What is your change lead rate? Clearly defined, again in the book, as your initial code commit to production. How long does that take? Your change failure rate, which is any change to production, including infrastructure, and how often do those changes lead to failures. And then finally, the amount of time it takes you to resolve an incident. We're going to use the classic definition of incident here from ITIL, which is any unexpected reduction in service level of a given service. Now, these metrics are a little bit more dangerous to use because people can game them. When you use metrics on a more localized basis, individuals or individual teams, they tend to break down because individuals and teams can game on them. They can focus on the metrics and kind of ignore the actual delivery. So be careful to only use these metrics broadly and to combine them with qualitative style surveys and measurements. So one question I get a lot is, why test failure rate? When you combine test failure rate with code coverage, you start to get a very semi-quantitative view of how useful your tests are at catching reversions, regressions, and bugs. And so those three metrics to consider and use very carefully and only broadly are mean time to pull request review, test fail rate, and code test coverage. Thank you very much for your attention today. I hope you have great tooling, great teams, and great engineering outcomes, and we'll see you next year.